Hi, and welcome to Cryo.do's ultimate guide to microservices using Java, Spring, and Docker. Our expert mentor will walk you through a detailed, hands-on course designed to help you master the art of building and deploying microservices, one of the most in-demand skills in today's tech industry. Microservices architecture allows for the creation of scalable and independently deployable services, making it a preferred choice for the modern enterprise application. By combining Java, Spring, and Docker, you'll be able to learn how to efficiently build, deploy, and manage microservices that are robust, scalable, and ready for the cloud. By the end of this coursework, you'll have the knowledge and skills to create your own microservices architecture and take on more advanced challenges with confidence. This is a free certified course which you can download to showcase your newly acquired skills. You can find the link to access your certificate in the description below. Before we begin, make sure to visit our website at www.cryo.do to learn more about our programs and resources. You can find the link in the description below. So get ready to dive into the world of microservices with Java, Spring, and Docker. Let's get started and happy learning!
Welcome all of you to this course on becoming a microservices developer using Java. This course will be spanned across 12 weeks and this is the first week of this course. In this week, we will be covering the following topics. First, the introduction to this course. Second, the prerequisites before taking this course. Third, what are the types of application architectures? Fourth, the comparison between various architectures. Fifth, the introduction to microservices. Sixth, the Java ecosystem for creating microservices application. And finally, we'll be creating a simple microservice as well. So in this week, the learning objectives would be, first, we will try to understand what are the various common application architectures that are used in the industry along with their advantages and challenges. Next, we'll understand what is microservices architecture and how we can implement microservices using Java and Spring framework. And finally, we will implement a simple microservices. So first, let's introduce our course. So this course is going to be a crisp yet detailed introduction to microservice architecture, starting with the fundamentals and gradually moving on to advanced concepts. We will cover real-world examples and tips would be provided to bring you on par with experienced developers quickly. Also, we will have hands-on coding and real-world projects to help you get a flavor of microservices development while you're learning. So the fundamental focus of this course would be to ensure that you understand what is microservice architecture. You really get the feel and the experience of understanding and developing a microservice application. We would also understand what is the role of the Spring Cloud and the cloud native application and how the microservices and cloud native applications are interconnected. Then we will also understand the other technologies like what is Docker, what is Kubernetes, what is container orchestration and other such technologies. And also we will be moving on to some advanced topics like config server and distributed tracing, log aggregation, monitoring, routing, cross-cutting concerns and so on. So next, let's try to understand what is the prerequisites for this course. So in order to take this course, it is expected that you should have at least basic or working knowledge of Java, Eclipse IDE and REST API concepts. However, we would cover the essential parts of Java and its other aspects throughout our discussion going forward. Now let's see how can we learn this course better. Pay attention to the topics which are being taught in the class and also ensure to understand the coding exercises provided at the end of each class. Try to make your own mini projects based on the knowledge gained through this course. The mini projects could be based on any real-world scenarios such as e-commerce app, cab booking, food delivery app, etc. So the core concept is like, you should first understand what is being taught in each week. After that, complete the assignments which are provided to you. And once you have completed the course, ensure that you also building some mini projects on your own based on any of the real world scenarios which you can take. So this will ensure that, whatever concepts you have learned in the class really stays with you for a long time. Okay. So before we go any further, it's first important that we start our discussion with the types of application architecture. So before we we go any further, let's try to understand conceptually what is an architecture, right? So before we build any application, even in in your industry, or even if you do it for your own personal project, it is important to understand what is our application is going to do and how we are going to build it, right? Even before you start to write your code. So it is important that we determine what is the pattern and technique with which it's going to be, our application is going to be designed, which will kind of act as an architectural blueprint before you build your application. So this is similar to the architectural blueprint which you create before building your house. So an architecture helps you to kind of visualize on how various parts of your application are going to be set up and interact with one another. Okay. So as you kind of grow in your career and become a senior developer, architect, and so on, ultimately you would be given this task of also to design the application architecture down the line. So it is a very important skill once you kind of mature in your project and you kind of grow in your role. So it's important that you also understand what role does architecture play and what are the various types of architecture which is used to build any application. So there are many tested architectural patterns which are available for creating an application. So it's not like you have to invent your own architecture every time before you create an application. There are many industry validated architectural patterns which are available for you, and each architecture has its own advantages and challenges. So it is important for us to understand several architectural patterns and their differences before choosing one. So on a high level, we can kind of segregate the various architectural patterns into the following three types. So I would call them you can call them either strongly coupled, loosely coupled, or decoupled. And an example for strongly coupled architecture would be something like a monolith architecture or a n-tier architecture. For loosely coupled architecture, the example could be event-driven or SOA. And for decoupled architecture, the example could be microservices. So don't worry if you don't understand what are these various terms, like what is a monolith, what is a n-tier, and so on. We would be getting into them slowly in the demo part once I show all these concepts to you on the whiteboard. So for now, all you need to remember is if you want to kind of segregate various application architecture, you can do that in the following three ways, right? You can either say they are strongly coupled, they are either loosely coupled, or they are decoupled. So before going further, let's try to just understand what does all these terms means, like what is strongly coupled, what is loosely coupled, what is decoupled. So a strongly coupled architecture means if there are various parts of your application which kind of speaks to each other, making change to one part of your application will also affect the other part of application, right? Loosely coupled means your application parts or the various parts of your application are not tightly bound or do not strictly depend upon each other in a very strict sense of fashion. So say for example, you may have two parts where changing one part may or may not affect the other part, but there would be some dependencies, but the the kind of dependence would not be too high. And decouple means that each parts of your application are kind of independent of each other, and even if you make change to one part of your application, the other part of the application will not be affected in any case. Okay, so let's try to understand all these concepts on the whiteboard. Okay, so before we proceed any further, let's try to summarize what we have learned. So we learned that architecture can be defined or classified on three high-level parameters, right? One is tightly coupled, one is loosely coupled, and the third is decoupled. So for the tightly coupled, what we said is, so assume that this is your application and it has say 2-3 parts. So maybe just imagine that this is the UI or the front end part of the application which the user will be seeing and interacting. This will be the API part or the services layer where you'll be writing all your business layer, and this is the database part which is kind of going to store all your databases, all your data in your application. So what does a tightly coupled means is all these three are so strictly bound to each other or strictly coupled with each other that even if you make a small change in the API layer, it is going to affect your DB and the UI. And similarly, if you make a small change in your UI, it will affect your API and DB. And similarly, if you make any changes to your database, it will be in turn affecting the API and the UI. So this is what is called as a tightly coupled. So as the name implies, they are tightly coupled or tightly joined with each other. Okay. So this you can just imagine to be the bricks of your wall. So just assume that you have a few bricks and you just stack them one above the other. So if you try to remove one of these below layers, right, the entire wall will collapse. So this is something like that, like, wherein changing just one of these blocks will be affecting the entire structure. And an example of this tightly coupled architecture is monolithic architecture or an NTR architecture. Okay, so what is a monolithic or an NTR architecture? So it is just same as what we have learned for tightly coupled. So in a monolithic architecture, what happens is, so just assume that, this is our application. So maybe for namesake, just assume that, this is an IRCTC booking application. Okay, so just assume that, we are going to build IRCTC as a monolithic application. So when you build IRCTC as a monolithic application, what happens is all the code for the front-end facing website or the mobile application, you'll be dumping it in one module and keeping it over here. All the code which deals with the actual ticket booking, checking whether the seats are available and all that, you'll be writing the code for that and keeping it in one module. And all the data that you'll be storing, you'll be kind of keeping it in the database layer. And this entire stuff would be deployed to a server as a single block or as a single cohesive application. So this concept is called as monolithic application, where everything of your application is kind of sitting in one server. Okay, so what I mean by that is, so the front facing UI is nothing but user interface or the actual website, right? So when you open irctc.co.in, the website that you see is nothing but the UI code. Okay, so the API code, API is nothing but application programming interface. This is nothing but in order for you to kind of fetch the data and show it to the user, you need to do some transformations on it. So that is done by this API. So if you guys are already familiar with the basics of Java, so I'm sure that you will be able to recognize these terms. For people who are kind of not comfortable with these terms, let's just quickly revise or summarize what are these things. So essentially, when you develop any application, there are three fundamental parts to it, right? So one is the UI part, one is the API part, and one is the database part. Okay, so all these three put together is what will be making your application, and this is common for any application, whether you take Google, whether you take IRCTC, whether you take Uber, Ola, Swiggy, Zomato, any of the day-to-day application that you use. So what are all these terms? So user interface means that whenever you open any website or your mobile application, the data or the stuff that you see on your screen, right? So that is nothing but the user interface or the UI. So the code that you write to make the screen or make the user interface part is called your UI code. Okay. And similarly, when you write this UI code, most of you would be performing some action, right? Say for example, if you're opening IRCTC website, so what do you open your IRCTC website for? Either you make a booking, you check a booking, you cancel a ticket, or you just want to kind of check what is the current status of a ticket, so on and so forth, right? So when you performed all those actions, what happens is in the database, right? So database is nothing but this is just a storage where all the data is dumped for you, right? So this is the icon for database. So this essentially only contains all the data which is stored as a table or as a record, depending on the technology that is being used. So what happens is whenever the user performs any action over here, so say he or she says book a ticket. So what happens is in your database, a new record gets created or inserted stating that, this is the user ID, this is the passenger information, this is the train, this is the date, this is the payment made, and this is the kind of the card used for making payment, so on and so forth. So all that record will be entered in the database, but this transaction from UI to database will not happen directly. There is a layer in between which can be called as the API layer or the service layer, there are various terms for it. So the work of this API is to ensure that whatever request is coming from the UI, right, you kind of act on it, transform it, apply your business rules, any logics that you have. Say for example, you want to book a Tatkal ticket. A Tatkal ticket cannot be booked early in the morning or late in midnight. I'm just giving a hypothetical scenario. Or maybe you are opening your Swiggy application and you want to book some food, but what if the hotel itself is closed? So all this kind of business logic checks, validation is what the API will first do on whatever request is received from the UI or the user, and then it will check in the database whether it is a valid transaction which can be allowed, and if so, it will then allow that transaction to happen. So in this case, if it has to be a new ticket booking, it will allow this record to be entered in the database. If it is a new food order, it will allow that order to be placed, so on and so forth. Similarly, if we want to even fetch some information from database, so say for example you want to see the list of all the tickets that were booked. So what happens is the user will make a call to the API. The API will then make a call to the DB. The DB will return the data that is fetched, and the API, if required, will transform the data in a way that it becomes easy for the user to understand on the user interface and send that data back to the UI. So this, as you can see, is a two-way process. So the data will also, like that request will also go from UI to API to DB, and also vice versa. So it will also come back once you make a request, the data will flow back from database, API and UI. So this is how any application works, irrespective of the architecture use or the technology use. So this is a high level understanding of how an actual entire application works. Okay. And the focus of our course, since this is going to be a microservice course, we are going to be focusing on this part, right? The API part. So what we are going to essentially do is we are going to cut off this part of just having this API and DB independently hosted as separate applications. We'll first understand what is microservices in due course of time. But just to let you know that the focus of this course is going to be understand how we are going to create this API part and ensure that it is talking with the database part, and also kind of sending the request back to the user interface once any request is made. We are not going to create any user front-end user facing screens because that is outside the purview of this course. But what we will definitely do is we will take up a real world example. What we will do is we will take an example of a bank. So you can just assume any bank that you know. So maybe like SBI, Citibank, any bank. So what we are going to do is in our course, we are going to create banking microservice application which will be composed of multiple departments. So as you know, a bank has multiple departments. So what we'll do is we'll try to create microservice for this bank, and then we will take it up and we will put it in a container. So what is a container? Don't worry, we will be discussing on that. And then we will be orchestrating this container. So what is the meaning of orchestrating is we will be kind of automating a few tasks and a few stuff configuration for this container so that our job of maintaining this microservices become easy. And also we will be having a few more additional stuff added, like for example monitoring, self-healing and all that stuff, diagnostic and all that stuff. So what happens is, as you kind of build your application, we will also take in the real world scenarios where we will try to understand how does that microservice applications actually kind of deployed into the cloud. So we will be doing all that stuff together. Okay, so this was just a quick detour to understand what is a application all about. So coming back to the types of various architectures. So first we saw that on a high level there are kind of three types of application architecture. So we saw that one is the tightly bound, one is the loosely bound, loosely coupled, and the third is decoupled, right? So I'll also write coupled over here. So all these three together are nothing but your types of architecture, right? So first we saw what is a tightly bound, tightly coupled architecture. So for the example for that we saw is monolithic. So what we saw in the monolithic application is, as I said, you just take all your UI code, put it in one module, take all your API code, put it in one module. And for this API, you also need to write a layer or a module which will be doing the work of communicating with the database. We normally call this layer as data access layer. Okay. So what we essentially do is we take all this code together, okay, wrap it up as a single application and deploy it in a server as a single bundle. So this is nothing but monolithic application. And then from the server, this application will be talking to a database. Okay. So you can have a separate database, that is all right. So what happens is in a monolithic application, since all these are tightly coupled or bundled together in a single code, whenever you try to make change to any one of these components, the other components will be definitely affected. Okay. So that is kind of a feature characteristic of monolithic. But one advantage of having a monolithic application is that the development is faster because everything you're going to bundle it as a single application and it is tightly bound. So the development would be kind of easier. You don't really need to bother about too many of network calls happening between each layer, so on and so forth. And also there are fewer cross-cutting concerns. So what I mean by cross-cutting concern, okay, so this is an important term which you should understand. So what is a cross-cutting concern is any feature or characteristic which will be acting on all the three layers, which is UI, API and also data. right? So say, for example, one aspect could be security, one other aspect could be latency, right? So what if I have to ensure that my application is secure? So in the monolithic kind of setup, you don't really need to worry too much because all your code is going to sit in a single server and as in a single module. So everything is going to be kind of managed centrally over here. So any security related code or configuration that you do for UI, API and data access is going to be kind of common and deployed to a single server. So kind of the management of your code and also the cross-cutting concerns become easy in terms of the tightly coupled architecture like monolithic architecture. Similarly, similar to monolithic architecture, we also have something called as n-tier architecture. So what is a n-tier architecture is? Let's just understand from the name itself, n-tier architecture, right? So what does a n-tier architecture mean? So basically what we do in our n-tier architecture is we just break our application into logical layers and physical layers, okay? So for example, let's take a simple example. So assume that I have a application and I'll just take two common examples. So in industry usually we have either two-tier architecture or three-tier architecture. So if you take a two-tier architecture, normally what happens is you have this UI or the front-end part of the web application part of your code. Okay, so that is one module, and there will be a server module or the API module which is kind of going to handle all your business logic and other transformation and server related aspects. Both of these is going to be kind of bundled together in a server, and there will be another layer which is the database layer which will be kind of talking to this application. So both of these would be kind of deployed to server as a single module, and your database would be sitting in a different server, and both of these are going to talk to each other. Why this is also a monolithic application? As you can see, we are tightly bundling the UI and API together along with the database, right? So this is kind of a two-tier architecture which is part of a entire architecture setup, right? Similarly, for a three-tier architecture, what happens is we have three layers. So one is UI, we will be deploying UI to the UI web server. We will have the API or the web services which will be deployed to the web service, the API server. And finally, we'll have the database which will be deployed to the database server, right? So since we have three different layers over here, one is called the presentation layer. The second is called the application layer. The third is called the data layer, right? So if you just go back and summarize what we learned earlier, how the application works. So we said, right, an application will have a UI, it will have a API or the web services, and also it will have database. So this three tier just tries to logically split our application to these three logical layers, okay? So, and similarly, you can also have other tier architecture as well. So if you want, based on your setup, if you think that, no, I need a four tier architecture where maybe I will also split this application into two parts. One could be my core app and the second could be any third party integration, so on and so forth. So all these are kind of various approaches on how you can tackle n-tier architecture. So again, in the n-tier architecture, in terms of management of your code, it becomes slightly difficult because you have now multiple layers of the code to manage. But however, in the long term, in terms of management of your code or maintenance of your code, this becomes easy because you kind of now have separate layers operating from separate servers. So kind of the maintenance of the code becomes easy down the line. So the next architecture which we are going to discuss is the loosely coupled architecture. So what is a loosely coupled architecture is? So an example for that would be SOA or event-driven architecture. So what this means is, here in this architecture, we are not going to kind of tightly bind each of our modules to one another, but rather we are going to have them loosely coupled. So what does the word loosely coupled means is, as much as possible, say I have two modules, right, or two components of an application, I will try to bind them in such a way they are least dependent on each other, right? They are not strongly dependent, but they are least dependent. Meaning, if say there are 10 things in my application component 1 and there are 10 things in my component 2. If I kind of modify 4 of these data in my component 1, this is still not going to affect my component 2. Maybe this component 2 only depends on the 6th and the 7th kind of the output of my component 1, which I'm not touching. So that is kind of an example of a loosely coupled architecture where two services or two components depend on each other, but they have minimal dependencies. Okay. An example of this is SOA and event-driven architecture. So what happens in a SOA architecture is, SOA, the full form of SOA or SOA is service oriented architecture. So I'll just give you a high level understanding of what is SOA. So this is kind of no longer used in industry. All these are kind of outdated now. after the invention of REST APIs. But it's always good to know that, what are the various architectures involved. So what happens in a SOA architecture is there are a few service consumer. A consumer is nothing but a person like you and me, or maybe another application as well, which is going to talk with our application, right? So here you would have our services, okay? So services or APIs. So what is that is, so what happens is you will have a ton of different services which are kind of exposed, okay? So just imagine that, you are going to kind of build application for your company. So obviously in your company, you will have multiple departments. So like, you will have HR, you will have finance, you will have marketing, you will have sales, you will have software development, you will have like, order and purchases, so on and so forth. So each of this department would have or expose its own services. But what happens is instead of directly giving them to the consumer, we will have something in between which is called as a service bus. Okay. So the work of the service bus is to kind of act as an interface between your consumer and the services with which it is trying to interface. Okay. So what is the advantage of service oriented architecture is, as much as possible, we are trying to reduce the dependencies between the services, and also like, the kind of like, dependencies which it will have with each other. Okay. So there will be only minimal dependencies. And what happens is all these kinds of acts on a contract. So what happens is if a consumer is trying to consume a service, right? So they will have a contract. The consumer will expect like, will be sending a request in a particular XML format to the server, and the server will be responding back to the consumer in a particular XML format. So as long as this particular format is not violated, everything here would be working fine. Okay. So before the advent of REST and microservice architecture, SOA was kind of the de facto enterprise standard which were used earlier for developing enterprise applications. The next architecture which we have in this series, of loosely coupled, is also called as event-driven architecture. So what happens in a event-driven architecture is, this architecture, as the name suggests, it works on events. Okay. So I'll just give you a very high-level example just to make you understand how it works. Okay. So just assume that, you have just take an example of maybe your stockbroking application, right? Or maybe your live score application. What happens here? So whenever there is a raise in price of the stock, or when a batsman hits a ball for some hits some runs in a ball, it triggers an event in your system, and that event ensures that, the data is getting updated in the database, right? And it gets processed and gets shown on the UI. On a high level, this is what an event-driven architecture is all about. An event, like any external event, will be triggering a series of transformations in your application, and based on that input, the data will be processed. Okay. So here also what happens is you have different components in place, each doing its own work. So here also it is kind of loosely coupled, where they are not strictly coupled or tightly bound with each other. Each of these can be deployed in its own server and have its own interfaces and all. But they all are expected to interact following certain standards, and that is why it is called as loosely coupled. Okay. The last architecture which we are going to discuss is decoupled. Okay. This is not really a strict term, because sometimes decoupled and loosely coupled are kind of interchangeably used. Okay. So what happens in a decoupled system is you can have a bunch of services which are developed. Okay. So when I mean services, what I mean, so assume that, you have an application which you're going to write for, say, the HR department of your company, right? Or maybe you're developing an application for your entire company. So each of this service can be a service for that particular department. One can be of HR, one can be of marketing, one can be of sales, so on and so forth. We'll also see how we have to kind of make the services down the line, where we will discuss what are the best practices on how many services we should develop and how each of the service should function. Okay. So that is a separate discussion altogether. But for now, just understand that, you can have a ton of different services, and each of this service will have its own infrastructure, meaning it will have its own API service, it will have its own database. Okay. This will have its own API service, it will have its own database. This will have its own service, own API service, and it will have its own database, so on and so forth. So each of these microservices would be deployed as a separate module, either in the same server or in a different server. That is up to the architect who is designing the system. But the logic is each of these services would be independent of each other. Okay. Even their databases are separate. So in this case, what happens is, even even if there's a change in one of the service, the rest of the services will not be affected. And similarly, if we have to upgrade one of these services, say tomorrow in the HR department there's a major change and we want to kind of add new functionality, this can be done independently and this can be deployed independently of other services. Whereas if you take the case of Monolithic, what happens is all the three codes are kind of tightly bound to each other. Even if you have to update a small part of one part of the application, the entire application has to be redeployed and updated and all that stuff. But whereas over here, even one single part of the service can also be updated and independently deployed. So that is the beauty of decoupled architecture, and the prime example for this is microservice architecture, okay, which is the focus of our course. So quickly, just to summarize, like what we have learned so far, we saw that we have tightly bound tightly coupled architecture, we have loosely coupled architecture, and we have decoupled architecture, right? And we also saw that in tightly coupled we saw what is a monolithic architecture, what is a NTR architecture. In loosely coupled we saw what is SOA, service oriented architecture, and event driven architecture. And finally for decoupled architecture we saw what is a microservice. So if conceptually I have to just draw a diagram for microservice, how it will be is, so assume that this is my UI layer or my client who is consuming my application. So always remember that one more thing is, it is not always necessary that the API has to talk with UI. It can also be possible that your application can interface with another application as well. So say for example, when you book a flight ticket, right? So when you go to any of these sites like Make My Trip, Clear Trip, or booking.com or any of those sites, what happens is these sites, right, when you enter their UI and enter the data, it will be going to their API server. But from this API server, internally, it will also make a call to the API server of the particular airlines, right? So say for example, I'm booking a flight from say Delhi to Mumbai. So what happens is this Make My Trip or any of these travel agent website will be internally making an API call to say Air India or Indigo server and fetching that detail and then showing it back to you, right? So what I'm trying to say is, so in this case, for the Air India or the Indigo Airlines, there is no UI involved here, right? So all it has is, it has a API layer and it has a database layer, and the consumer or the client for this particular system is nothing but your Make My Trip API server, right? So this is what I mean that, it can either be a UI or can be another client API as well. So if again, just proceeding with our discussion. So if I have to kind of draw a conceptual diagram of my API architecture. So what happens is, there could be a consumer or client, which can be UI or API. It will make a call to my API gateway. Okay. And from this gateway, based on the request which is coming in, it will be routed to one of the microservices, which will have its own database. And all of these are kind of separated from one another. As I said, they are all independently deployed. So what happens is, even if there is some changes which I have to make to service 1, I can do that independently without touching service 2, 3 or 4. Okay. And again, there can be some cross-cutting concerns like, as I said, security and all that stuff. So which can be kind of managed as a horizontal part. Okay. Don't worry, we'll be discussing microservices in detail in the oncoming chapters. So that was pretty much all about microservice for now. So with that, we have reached to the end of this first part of the session. Let's meet in the second part now. Thank you. Hello everyone, and welcome back to the second session on microservices. In this session, now we'll continue with our discussion of the comparison of various architectures that we have seen so far. So as we saw, there are 3 types of architectures. One was tightly coupled, the second was loosely coupled, and third was decoupled. So we also saw how they are architected and what are the various parameters by which we design them. So now let's try to understand what are how they compare with one another. So the first attribute which we'll use for comparison is the implementation and maintenance. That is one of the key parameters which we use to evaluate any architecture. That is how easy it is for us to kind of implement that architecture and also maintain it over the time. So as we saw that for monolithic, the implementation and maintenance is easiest among the others architecture. Why that is the case? Because since we are keeping all the presentation layer logic, the application service layer logic, data access layer logic, everything as in one code base, and also deploying it to a single server, it kind of becomes easy for us to maintain that application, also develop it easily. But if you take any architecture like which is loosely coupled like SOA or event-driven architecture, the implementation and the maintenance becomes partially complex, because now we have to deal with developing independent systems which are deployed on different servers, and also we have to also find a way to interface between each other. So that is why the implementation for loosely coupled server is partially complex. And finally, if you take the decoupled architecture like microservices, the implementation and maintenance is complex, and all these are kind of relative. When I say the easiest and when I say complex, so these are just relative to one another. So if I have to just rate implementation and maintenance between all the three architecture, then I would say the microservice architecture is most complex to implement and monolithic architecture is the easiest to implement, right? And why we say it is complex for microservice architecture, that is because as we saw that we have to develop independent services and a database for each of the services, which will be again independently deployed on different servers. So in this case, the kind of code and overhead which we have to write and manage is large. That is why the implementation and maintenance for microservices is complex. The next attribute which we will be used for comparing is scalability. So what we mean by scalability is, so I'll give you a very simple example. So assume that you are developing an application for booking a cab, okay? So you just imagine that you are a startup who just invented a cab booking application. So as you know, when you just initially develop your application, there won't be many users, right? Probably it will be just 10 users or 100 users. But just assume that you have started to grow like Uber. So over the time you have really garnered tens and thousands of customers. So what happens is over the time, as your application popularity grows, even the load of your server on your server it goes up, right? So today there will be 10 users accessing the application, tomorrow there will be 100, then day after there will be 1000, so on and so forth. So when we say scalability, all it means is, does our application grows over the time as the load on the server increases, okay? So in case of monolithic application, which is like in the case of the tightly coupled architectures, it is not easily scalable. Why it is not easily scalable is, since we are going to kind of just deploy all the application in a single server. So what happens is, whenever you have to scale your application or your application requirement increases, either you have to make changes and redeploy all your application in the server, or you have to kind of add an extra server manually and then deploy all this application into it. So the kind of the work which you have to do to make it scalable is not easy. Okay, and mostly monolithic applications are also on-premise server. What do you mean by on-premises? Since you are going to have a server physically in your environment where you're going to deploy it, so this maintenance of server and scaling of the server is not quite an easy job, because you cannot just add another server on the go without first having them in your environment. For loosely coupled architectures like SOA, the scalability is partially complex. Why? Because since it is loosely coupled, the components can be independently scaled, but still there are certain limitations which has to be taken into consideration. They are just not infinitely scalable. You also have other complex parameters in place, because they are going to be interconnected using service bus, and there could be other server related restrictions as well. But if you take decoupled architecture like microservices, scalability can be easily achieved. Why that is the case? Because since your servers are independently deployed in the cloud, and as you people may know, in the cloud it is very easy to spin up a new instance and create a new instance of your server just on the go, right? You don't really need to have all this overhead of manually provisioning a server, then starting the server, deploying your application and all that. So when you use any of these cloud providers like AWS, Google, or Azure, all of them provide this auto scaling option. So once you deploy your microservice application, it is very easy for us to kind of scale our application on the go. So what happens is, tomorrow if you, as I said, if you say develop a app which is a Uber competitor, and over the time your application popularity increases, so you don't really need to sweat a lot in order to make your application handle the large load. If you enable auto scaling and other such features which are available with the cloud vendors, your application can easily grow over the time. The next important attribute for our application is testability. So what we mean by testability is, how easy is it for us to test our application, right? For monolithic, the testability is really not scalable or not easy. Why that is the case? Because since everything is kind of tightly coupled, it is not easy for us to independently kind of test each and every part of the application independent of each other. So either you have to write a test case which will test end-to-end scenarios, but there you cannot test a few scenarios where you just want to slice and dice your application and test just a few functionality of it. So say for example, if I develop a application for IRCTC, right, for example, and I just wanted to test the part where I want to test if the logic for Tatkal is working fine. If it is a monolithic application, I have to write the test right from the user clicks on the booking reservation system right till the point that the ticket is generated. Because my entire code is so tightly coupled, I cannot just take out a single functionality and test it independently, right? But whereas in case of loosely coupled architectures like SOA, testing is partially doable, or I would say we can achieve a good sense of test cases. Why that is the case? Because since we are going to develop loosely coupled components, it becomes easy for us to kind of isolate the few components and test them independent of the other components. But whereas in microservices, since they are totally independent of each other, the testing can be easily achieved and you can easily slice and dice your application to write your test cases accordingly. And the last parameter which we are going to discuss today for this comparison is fit for agile development. So first we should understand what is agile development, right? So some of you are not familiar with this agile development concept. So in the last, I would say 10-15 years, there is this concept of agile development, which is now the industry standard for developing any application. So earlier what used to happen is we used to follow the waterfall software development lifecycle, wherein each phase of your application had a definite step, and we used to develop and complete the application in its whole. So say for example, if I had to write an application for Uber, right? It was not I could just write a simple prototype this week, test it, and then ask my user how it is, and then again keep on improving it. How the Uber used to be developed in those days? What I mean to say is before Agile came into picture is, first you used to take the requirement from the end user, from the business users, then you kind of analyze those requirement, then you kind of wrote the code for that particular requirement, then you tested it, then it went for user acceptance testing, and after all the approvals was received, and then finally was the software made available to the end user, right? So this used to be really taking a lot of time, sometimes even years, and it was really cumbersome process. So that's why what happened is now it has been replaced with agile development. So what agile methodology says is, instead of waiting for quite a lot of time and doing a lot of redundant work on that aspect, it is better that you just keep on iterating incrementally and develop value adds just over the go. So say for example, if I'm going to develop a Uber app, maybe in the next 1 month I will develop a simple app which is just going to let me book a cab from say point A to point B. That's it. No other features enabled. So maybe in the next iteration of that, probably I would even get a feature where I could schedule a ride maybe some days or hours in advance. Maybe in the third iteration or in the third release, I would have a feature where maybe I could book for my friend or relative. Or maybe, and in the next iteration, maybe I could have something like a profile where I could save my card. You're getting my point, right? So the whole point is, if the same was done in waterfall, what used to happen is all these features usually used to be given or released in one single build, and that used to really take a lot of time, because developing all this together used to really be a time-consuming process. But in Agile, since we have kind of made things loosely coupled, and the focus is more on the value adds or the end user, we are doing incremental deliveries, right? So why we were talking about Agile is, since Agile is, I said, the de facto standard for the today's software development lifecycle, tightly coupled or architecture like monolithic are not easily fit for Agile development, because as I said, monolithic architecture are really a good fit for the water cycle kind of lifecycle of development, because there you really developed a lot, the entire application in one go and deployed. And if you take loosely coupled architectures like SOA, they are partially a fit for agile development. Why I say partially? Because since they have components which can be independently developed, they can be developed by various teams in parallel. But there are again a few bits and pieces which needs to be which has some dependencies with all these components. As I said, you have the service bus and other infrastructure related setup. So that's why it's not a full fit for agile development. Whereas if you take any decoupled architecture like microservices, it is a perfect fit for agile. And why that is the case? because each services, since they are independent and you can just develop them independently, you can have multiple teams which can work in parallel. So for the same Uber application, what I can do is one team can work on the feature where they can book the cab, the other team can book on a feature where they can book the cab in advance, the third team can work on a feature where maybe they can book the cab for friends or relatives, the fourth team can work on profile, so on and so forth. So that is why decoupled architecture is the best fit for agile development. So moving ahead, now that we have understood what are the various architectures available, so far whatever architectures we saw, these were just to ensure that you have a broad idea of what we are doing. So before just jumping into microservices, it is also important for you to know what are the other alternatives available in industry today and why we are learning microservice. So I hope by now you would have understood that microservices has a lot of plus points compared to other architectures, mainly in terms of what we saw right now, right? It is easy to implement. I won't say easy to implement. It is easy to scale, easy to test, and also it's very a perfect fit for agile development. We also saw the challenge that it is a bit complex to implement and maintain, but in this course we'll also see how we can mitigate that to a certain extent, right? So without wasting much time, let's now jump into the introduction of microservices. I'll just dive a little deeper into microservice architecture and understand what it's all about. So microservice is a pattern in which the application with several independent services is composed. So as you can see on the picture on the right hand side, so as we have a user interface which will be talking with the API gateway. API gateway is nothing but you can just say it is a component which will just listen to the request which is coming from the UI and then decide to which microservice this request has to be routed to. Okay, so what happens is when you develop an enterprise application, normally the user interface will not directly tell the server which microservice or which server this request has to go. All they will have is they will have a certain request in a format and they will have certain payload attached to it. Then your API gateway will dynamically decide then okay which request, which microservice server will this request go to. Does it goes to the HR microservice or the I'm just giving a simple example from my enterprise. So does it go to HR in microservice or does it go to the operation microservice, does it go to the sales microservice, so on and so forth. So microservice is just kind of the API gateway is nothing but just kind of an interface which sits between the end client and the microservices. And each of these services that you see below, right, microservice 1, 2, 3 and all that, so each of these service specializes in performing one particular task independent of other service. Okay, so say for example, let's take an example of bank which we are going to develop in this course. So if I take bank and bank has many departments, as you know. So in that, if I just take the example of say loan department, so one specific function of loan department is to give loans, right? So I will have a API or I will have a microservice which is designed only to grant loans. Okay, so that API's only function is to ensure that based on the request received, I will either approve a loan or give a loan, or I will reject that loan, right? I won't do any other additional task with that. For example, I won't give you the balance or I won't tell you what is the status of your account and all. For that, I'll have to develop a different microservice. So the moral of the story is each microservice will only specialize in performing a particular task and that has to be independent of other service. That is a key point to be noted over here. And since microservice applications are composed of several independent services, they are also easy to develop, test and deploy independent of other services. Okay, so don't get confused. In the earlier comparison, we said microservices are generally little complex to develop and maintain, but here we are saying they're easy to develop, test and deploy. So let's understand what it means over here. So as I said, today we have agile development methodology, right, where the focus is on creating small features incrementally over the time and develop the entire application. So what happens in the enterprises, normally for a particular application there will be many teams which will be working, right? And since each of these services are independent, it is easy for us to kind of split each of these services into features and give it to them independent teams. So say for example, if I have to develop Uber application or IRCTC application, so I can have say maybe 5 teams. One team can just focus on the train ticket reservation part. The second team can just focus only on the food ordering part. The third team can maybe just focus on the part where you can also allow the user to book flight tickets, so on and so forth. So what happens is all these 3 teams don't have to depend on each other. They can just simply start the development, testing and deployment activities independent of each other. And finally, when all of them are complete, I can just integrate all of these into my core application and we are good to go. So that's why we say that, since they are independent services, they are easy to develop, deploy and test. Okay, and why they are also easy to test? Because since they are independent, every team can write their own test cases. They don't really need to depend on other team to write their test cases. And also microservices are distributed and decoupled from one another, so they can be scaled very easily. So what is the meaning of that is, since we are kind of like, decoupling each service from one another. See, this is a term which we are repeating again and again, right? We are saying that, it is an independent service, it is decoupled service. So what is a benefit of that is they can be scaled very easily. Okay, so I'll give you an example of this. So just assume that, we have developed maybe like, we have developed an e-commerce website. Okay, so maybe just take the example of Amazon or Flipkart. So what happens is, Amazon or Flipkart are really made of tons of microservices, right? So assume that, some festive season comes in, maybe like, Diwali, Holi, Eid, whatever. So suddenly there is a spike in the people searching for a particular product. Okay, so what happens is, we want to ensure that our application is able to handle that search query faster. So maybe the people are loading our application and searching for, say, maybe a kurta or pajama, whatever. So your microservice which is concerned with that particular search feature, right, which is searching for the user query, should be scalable at that particular period of time. So in case of microservice, it is quite easy to do that, because since our services are independent, we can spin multiple versions of multiple deployments of that particular service into other services. As I said, cloud vendors support this auto scaling feature, so we don't really have to sweat a lot and write a tons of code or do a lot of configuration in order to achieve that. Similarly, if we have to develop cloud native applications, microservice architecture is one of the necessary ingredient. Okay, so what is the meaning of cloud native application? Don't worry, we have a in-depth discussion about this in the next week session. But for now, just understand that cloud native applications, as the name implies, are the applications which are written for cloud. Okay, so what is cloud? If you people are not aware, we basically have there are three famous vendors of cloud. Like one is Azure, Google, and AWS, Amazon Web Service. So what cloud means is, earlier whenever you used to write applications, we used to kind of have the servers for that particular applications installed or bought out, and we used to maintain our own server farms, right? The enterprise you really used to maintain their own server farms. But over the time they realized it is really a waste of effort and energy and all that thing to have all that ourselves and maintain it. Because say for example, if you take a company like Uber, right, their core strength or their core revenue is from writing the code which helps you to get the cab and do all that stuff. But if you're going to spend a lot of energy just to maintain the server, deploy the server, monitor the server, they really are spending part of the energy which could be used productively in some other part of the application. So that is why this cloud came into picture, wherein we are outsourcing the infrastructure part of our application to some third party vendor like Microsoft, Google, or Amazon, wherein they have the infrastructure upon which we can deploy our application. That is just a very simple definition of cloud. Cloud also has other advanced features, wherein you can also have certain services also has a certain services outsourced. So say for example, you want to do SMS, or you want to send automated emails. So even those kind of services, instead of writing your own application, you can simply subscribe to the cloud vendors and get that service provided from them. Okay, so and also another thing to notice, the industry is now slowly moving into the cloud native or cloud first application. So wherein any application that you develop has to support cloud as well. And in order to develop cloud native application, microservice architecture is one of the essential ingredient. Why? Because since microservice develops kind of independent services, it is one of the necessary ingredient in order to ensure that it is able to run in the cloud and able to scale fast. And with this, we have come to the end of this session. In the next session, we will now next understand what is the Java ecosystem for microservices. Thank you. Hello everyone, and welcome back to this third session of week 1 on microservices development using Java. So now let's focus on the Java ecosystem for creating microservices application. So in order to develop microservices, any programming language and its associated frameworks or libraries can be used. However, Java is one of the most popular programming languages which is currently used by many software companies around the world for writing microservices application. And in terms of popularity, Java really ranks on the top along with the other popular languages as well, like maybe .NET and Python. So within Java, since as you guys know that Java is a language, but within Java we have a few framework, and one of the leading framework is the Spring framework, which is popular and trusted solution for implementing enterprise application. There are many projects within the Spring framework, with each project addressing a particular aspect of application development. And for microservices development, we generally use the Spring Boot and Spring Cloud extensively. So before we go any further, we have to understand what are the key benefits or advantages of using the Spring for microservice development. As we know that Java is a language, but Spring is a framework which helps us to create microservice application. So before we go any further, it's also important that you understand what is the difference between a language, a framework, and a library, right? So I'll just give you a very quick recap of that. So language is nothing but the broader sense, the larger picture or the larger platform which allows you to create something. So it gives you all the syntax, semantics, the runtime, libraries, and the means to deploy the application, all that stuff. So language is anything like Java, .NET, or JavaScript. So all these are nothing but your programming languages. So wherein they give you specific syntax by which you can communicate with the computer in order to perform a particular task. That within each of these particular languages, you have something called as the frameworks. So what is framework is nothing but they basically are a few patterns and technologies which are implemented in that particular language, which gives you some solutions out of the box. So say for example, if you take Spring for example, if you just want to write web applications with minimal code and where you want to focus more on your business logic rather than just the setup of your application, so those kind of scenarios is where you use the framework, wherein they give you a pattern to follow. They have certain tried and tested ways of doing application architecture and implementation. So what you do is you just use that particular framework and follow the pattern which is recommended by the authors of that framework in order to build your application. And finally, we have something also called as library. So library are nothing but the small utilities or tools which helps you to do a certain feature. So say for example, I could have a library that just converts Word to doc, or maybe a library which converts my Word document into a PDF document, something like that. So library is basically not a framework. It's not as large as a framework wherein it gives you patterns and solution for the entire application, but rather it is very narrow and specific for a particular feature or use case. Okay, so we have a tons of libraries and also tons of framework. So within Java's ecosystem, Spring is a very popular framework which is used for writing enterprise application, and even for microservices we have the Spring Cloud, which is used extensively for writing microservices. So the following are the key benefits of using Spring for microservice development. So first thing is it's very easy to set up, configure, and build microservices using starter projects. In the next session, we will be actually creating our own microservices using Spring. So you will actually see this for yourself, like how easy it is to create a very simple application using Spring. Literally you don't have to write a lot of code for that. Next is the security, configuration management, and other capabilities are built in. Since it is a framework, there are a lot of design patterns and recommendations which are given by the Spring team itself. So the advantage of that is you don't really have to bother about a lot of such cross-cutting concerns and management as well. It also supports auto configuration where possible and avoids XML configuration. So the beauty of this is whenever you create any new class or any new application, so it will try to see if this can be auto configured. So I'll give you one simple example. When you create a simple starter project from Spring, so it automatically downloads all the Maven dependencies for you in the background. It sets up it has its own built-in server and all that stuff. So when you just run the application, all that things comes into the play and your application starts up. So the beauty of this is you don't really have to write a ton of XML configuration, other stuff, which used to be the case in the previous in the pre-Spring era, where you have to write all these things by yourself. Next is the deployment and monitoring of microservices are easy with embedded server. So what Spring does is Spring has this built-in Tomcat and Jetty servers embedded. Whenever you write your application and you want to deploy your application, so using those embedded server, the application can be deployed and started quickly. So even this we'll be seeing in the next session, where you can see for yourself how without doing any server configuration we can still run our Spring microservice application quickly. And finally, Spring has a wide open community of Spring developers. So the advantage of this is whenever you run into any issues or you want certain features or you're not able to understand how to do a particular scenario scenario, you can very easily look up that question either in forums like Stack Overflow, where you can get solutions. And even if you have any active questions which are not yet answered, there will be people who can easily answer that for you, because the number of developers who are using Spring is quite huge. So Spring ecosystem is quite large. Just like Java, even Spring is quite big because it is a framework. It operates on multiple layers. So, and the Spring framework is basically just an overarching term under which there are these many projects, and also there are new projects coming up every time. So what we have done over here is we have just conceptually divided or separated each of these Spring projects based on the capabilities or based on the layer on which they operate. So on a high level, you can say that Spring can be divided into three parts. So one is the Spring IO platform, which is the web layer. The second is the Spring Boot part, which is the common layer. And the third is the Spring XD part, which is basically nothing but operating on the service layer and data layer. Okay. So what each of these project does, and what is the implication of that, probably you can just look at it quickly, like based on each of the project does. But all you need to understand is each of these projects are only concerned with a particular aspect in that particular stack. So say for example, if I take Spring Test is only concerned with writing the testing your application and nothing else. So if you take Spring Session is only bothered with maintaining the session and all that stuff. So whenever you want a particular functionality, you have to use that particular Spring project in your application and do it. And for our case, since you are going to write microservices, which is going to be like hosted in cloud, we will be utilizing Spring Boot and Spring Cloud to a greater extent. Okay, so let's just quickly run through what are the various parts of what are the various projects of Spring and how they work. So at a high level, right, if you just see, as I said, it can be divided into three parts. So what we'll do is we'll just quickly just check, just see what are each of these projects and what it does. So first, just let's quickly get into Spring Web Services on the left hand side that you see. So Spring Web Services is nothing but it just helps you to build a contract-based, SOAP-based web services. So what happens is as we saw earlier, you have something called a SOA architecture, right? So wherein what was a SOA architecture is, as I said, you have two entities wherein they establish a contract between each of them, where the client kind of requests a particular request in a particular format, and the server will going to respond them in a particular format. So if you want to kind of build a contract-based web services, so that is where when you use the Spring Web Services. So Spring Web Services is similar to the SOA architecture, where you have the SOAP-based WSDL and all that stuff coming into play. So where this is basically used is whenever you have you have to write any domain specific languages, or you are dealing with any of the traditional services where the SOA architecture is still into play, or contract based API is still into play, and that is the place where you use the Spring Web Services. Next, you have something called as the Spring Social. So as the name eliminates, as the name says, it is nothing but just a plugin or the tool where you can kind of allow the user to interface with Facebook, LinkedIn and all those social media sites, and in order to create new account for your application. So you people would have seen scenarios where you go to a particular application, and instead of creating a new login, you can directly link your existing Google or Facebook login to that particular application, right? And it creates an account for you. So in those kind of scenarios where you have to kind of integrate the social applications with your application, you use the Spring Social. So the next we can talk about the Spring for Android. So what, as the name suggests, this is basically for developing native Android applications. So what happens is if you have to develop any native mobile Android app based application using the Spring framework, so this project helps you to do that. Next, you would have seen that there's a project called 8 OAS, Spring 8 OAS. So what is that is basically 8 OAS is nothing but it's a principle. So what happens is on a high level, right? What happens is you can develop REST services which can return metadata about other discoverable services or representation. Okay. So on a high level, right, what we can say is it doesn't really have dependencies, and it is really easy to introduce and pull things out of your project. Okay. The next is kind of Spring Mobile. So Spring Mobile helps you to, as the name suggests, mobile applications or mobile friendly pages. So if it detects that you are accessing the application from mobile, then it can serve you the pages which are optimized for the mobile platform. Okay. The next is the Spring Web Flow. What is a web flow is it allows you to kind of separate or split the data between multiple screens for easy navigation. assume that you're kind of developing a bank application, and you want to create a bank registration form. So you would have noticed that the form gets split into multiple screens. So where in the first screen you have introduction, second screen you have maybe your contact details, third screen you have your income details, so on and so forth, right? So those kind of scenarios where you want to kind of split your data into multiple screens, make the navigation easy and all that stuff. So that is where the Spring Webflow will come into picture. And finally, we have something called the Spring Security at the bottom. So Spring Security, basically, if you see, is kind of the core to all this, because it is something like that makes your application secure, and it kind of controls like who can interact with your application, and what is the level of authentication and authorization. So Spring Security is basically, see, the other projects can be optional in your application, like depending on what you do, but Spring Security is definitely not optional, because it is something that you have to include as part of any application which you are developing. And Spring Security also has its own database schema, and that is kind of the use of Spring Security. So wherein you write the logic for all the authentication and authorization. And after that, you see in the center there is something called as the Spring Boot. So Spring Boot is nothing but they all leverage again the Spring framework, and these are some of the common projects which we have, which is a core container, messaging, AOP, which is aspect-oriented programming, Spring Web, data access, test. So using all this, the use of this is they all help you to kind of develop the core application or the common modules of your project. So the next part you see on the right is the service layer projects. So what happens in the service layer is whenever you want to write services and integrate services. So that is where these Spring Cloud and Spring Integration come into picture. So and then finally we see something called as the data layer. So what is the data layer is these are predominantly into data handling and manipulation. So whenever you want to handle the data and manipulate the data, that is where you use the projects like Spring Batch, Spring Data, Spring LDAP, and AMQP. Okay, so that was pretty much about the Spring ecosystem. So this was just a high level understanding about what a Spring ecosystem is all about. If you are new to Spring and also new to Java, I would highly recommend that you just spend a few time after this session understanding about what is Java and why Spring came into picture, what are the various projects of Spring. So in this course, as much as possible, we will be covering each of these projects which is applicable to our microservice application while building the banking application. And I'll be explaining and making you understand what are the various parts of Spring. But humanly, it is not possible to make you understand all the parts of Spring ecosystem because it's quite big. Hence, I personally advise you that, you also kind of explore this in your part-time, like whenever you get some free time, just go ahead and, just go to the Spring website and try to understand what each of these parts are doing at the end of this course. And that's pretty much about the Java ecosystem for microservices. And before we go further, it's also important to understand what is the runtime, how the runtime of Spring framework looks. So what is the meaning of runtime is whenever I kind of create run my application. So what happens is in my JVM or in my main memory, there is something kind of a container created under which all these things run, right? So what happens is for my application to run, there are also a ton of other components which has to run in order to ensure that my application gets executed. So for this is how a sample Spring framework runtime looks like, where you have a ton of other components which will be running in the main memory. So where you can see that you have this data access integration component under which you have this JDBC, ORM, OXM, JMS transaction. So basically what it does is whenever you want to interact with data or manipulate data, that's where you use this data access and integration comes into play. The next you have the web layer where you have this WebSocket, servlet, web portlet. So basically whenever you have any incoming request and other stuff which is coming from the web application, so these guys ensure that all those requests are handled properly. Then you have this common layer of AOP, aspects, instrumentation, messaging, which is kind of the common layer which runs across. Then you have the core container. The core container consists of the beans, cores, context, and spell. Spell is nothing but the Spring expression languages. And finally you have the testing framework. So the core container is nothing but, as the name suggests, it is the core, and it is it provides kind of the implementation of the features like Spring provides us something called as inversion of control, dependency injections, and singleton design, and so on. So to implement all that, we require this core container. And this bean is nothing but the factory design pattern which using the bean factory by which we can create multiple beans, and so on and so forth. So The focus of this course is really not the Spring, so I'm not going to really go much deep into Spring any longer. But this was just like, to ensure to make you understand that, you at least have a basic understanding of Spring before we dive into creating the microservices. So as I said, I highly recommend that you guys just go back and go to the official Spring website, spring.io, and just kind of like, understand what this Spring is all about in case you're not aware of Spring. And also, if you're not aware about Java, like you're not too much conversant with Java, I would recommend that you at least have a basic knowledge of Java so that it helps you to pick up this course as we go ahead. But don't worry, we'll be covering most basic part of the concepts as required. So in order to make it easy for you. So with that said, we have come to the end of this session. But before we wrap up, I just wanted to quickly summarize why we are using Spring and what is the advantage of using Spring and like all that stuff, so that the concepts really stay in your mind. So just remember that we have seen what is the advantage of microservices, right? So we saw that microservices, it's easy for us to create independent services. Each of them can be scaled easily and all that stuff, right? So then for writing microservices, we have a ton of different languages. So normally Java is usually preferred in the enterprise. And within Java, a Spring framework is normally recommended for writing enterprise application. So what are the features of Spring? One is it is lightweight, because the size of the Spring is very small, and it is very easy. And it's very lightweight, and the bottleneck or the runtime is quite smooth. The second thing is it has something called as inversion of control. Okay, so what happens is Spring framework gives you kind of a loose coupling. So what happens is each object, like as you saw, right, Spring framework has multiple independent projects which can be used for different purposes. So what happens is each of these objects can give its own dependencies instead of looking for dependent objects. So you can just pick and choose different projects as you want, pick and choose different modules as you want. So this concept is called as inversion of control, wherein you're just loosely coupling your entire framework. Next is something, as you can see even in the runtime over here, is called AOP, or aspect oriented programming. So what happens is in the aspect oriented programming, we just kind of separate our application business logic from the system services. So that is the core concept of aspect oriented programming. So what happens is all the business logic, you just kind of separate it out into a different services, and any services which are only concerned with the system runtime keep up and your application, that you separate it out. So the beauty is you can evolve both of these services parallelly independent without tightly depending on each other. That is called as aspect oriented programming. The next is Spring framework also kind of creates and manages the lifecycle and configuration of the application object. So it kind of provides a container or a runtime where all your application objects and beans would be managed by itself, so that it reduces an overhead for you. The next is Spring framework also provides MVC, web application framework, wherein using that MVC framework, you can kind of develop web application out of the box. So Spring kind of gives you an end-to-end solution to create application. And also finally, the Spring also gives you means to kind of manage transaction. So since it gives you a lot of abstraction layers, it is very easy for us to kind of manage transactions. And also even in case of JDBC and other kind of data integrations, we can also handle the error effectively. So that these are kind of some of the few advantages of using Spring. So with that said, we have just reached to the end of this third session, and in the next session we will then start with the creation of microservices. Thank you. Hello everyone, and welcome back to this fourth session. So now we have so far talked about the theory about the background of microservices, what is the Spring framework all about and all that. So now let's get our hands dirty and create a simple microservice. So before we proceed to create the microservice, the following are the essentials which are required in order to create a simple microservice. So first, you should have your Eclipse IDE downloaded and installed in your local computer. It should have JDK 11. So for this course, we are going to go with Java version 11. So I highly recommend that you have version 11 so that you are able to follow along in this course and you don't have much of errors. So next, you should have stable internet connection, because when you are downloading Eclipse packages, if you have a very slow internet, then it will take a longer time. Next, you should have something called as a Postman. So the use of Postman is whenever you develop a API server, and in order to query your API server, you can use API in order this Postman API testing application in order to make a call to your server and get the response. And finally, we will use a service called as Spring Initializer. so which is accessible over this website start.spring.io. So what this is useful is like whenever you want to create starter project, like having some basic code of Spring Boot with the functions we want, we can just do that out of the box. So we'll be seeing all of this once, we'll be getting started with creating a microservice. So now let's head over and create our microservice. So before we go ahead and create a microservice, so as I said, the first step is you have to install your Eclipse IDE, and when you install the Eclipse IDE, along with that, even the JDK or the Java development kit also gets installed. So to install Eclipse, it's very easy, as you may know, that just Google for Eclipse download. The first link that you get, Eclipse downloads, or in the site eclipse.org/download, click on this. And on the left hand side you will see something called as Get Eclipse IDE 2022-6. So at the time of this recording, this is the latest Eclipse IDE that we have, but in case you're seeing this as a later point of time, then this version might get updated. So however, that doesn't really matter, so you can even download the latest IDE as well. So just click on this download button based on the operating system you're using. So for this course we are using Windows operating system, so the steps that you see here will be for Windows, but even the same applies for Mac and Linux as well. So just click on this and the Eclipse will get downloaded after some time. So just to save some time, I've already downloaded the Eclipse IDE and I'll just show you the steps that you need to do after that. So once the installer is downloaded, open that installer, you'll see a windows like this where it will ask you what is the Eclipse IDE that you want to install. So click on this option where it says Eclipse IDE for Enterprise Java and Web Developers. Okay, so this is the one which you have to select. And once you select that, you'll get this window where it will ask you to to select the Java VM which you want and the installation folder. So this installation folder can be any location in your local computer, that is up to you. And for this Java, what you need to do is just click on this drop down and select this Java version 11. Okay, not version 18 or 17, but version 11. So as I said, we'll be proceeding with version 11 in this course. So it's recommended that all of you select version 11. So all of us have the same code and consistency. So once you have this, you can just click on install. So based on your internet speed and the server speed of Eclipse, this might take anywhere between 5 to 10 minutes for installation. And once it's installed, you will get a button to launch. You can just launch your Eclipse. And once it is launched, you'll get a window like this. So this is the high level summary on how to install the Eclipse. For Postman, all you need to do is just go to a browser, type Postman, download. So the first link that you see in the Google, which is postman.com/download. So just click on that. So here, based on the operating system, you will get the version. Just click on that. And once the installer is ready, so once the installer is completed and just open it, it will automatically install the Postman for you. And you'll see the screen in your computer, which says create an account, a free Postman account lets you and all this. So you don't need to really create account and all. So for the starters, all you can do is just click on this link below, which says skip and go to app. So just click on that and it will open this Postman UI for you. So that's it. You have also installed Postman. So the three major stuff, which is Eclipse, the JRE or the JDK 11 and the Postman, the three of these stuffs are ready for us to use. The fourth thing that we also saw is the Spring initializer. So I'll just show you what is the Spring initializer all about. So just go to this website start.spring.io. So what the Spring team has done for us is, so as I said, there are a ton of Spring projects which can be used for a variety of purposes. So instead of you writing all the code by yourself and linking all the dependencies by yourself, all you can do is just generate a starter project of that particular project which we want and just write the business logic on top of it. Okay. So for now, what we'll do is, since we are going to use a Java project and a Maven project, so this is all default selected, right? So Maven, basically you can have a Maven project or a Gradle project. So Gradle is basically a newer type of versioning or a newer type of build tool, which gives you some additional functionalities as well. But we will use Maven, which is kind of used now in the industry. And for the language, we'll go with Java. And the Spring Boot, the current version is 2.7.1, which is auto selected. And here we have to give a few project metadata. So the first is group. So if you are already aware of the Java naming conventions, you know that this really follows the opposite of whatever is your website name. So in case my website name is say skilllink.in. So here my group name would be something like this. So in our case, what you'll do is we'll just give the name of a project as demo. So I'll just give it as com.demo, and the artifact and the name will also be demo. and description can be like demo for Spring Boot. This is fine. Packaging will be jar. That is also fine. And Java, since we are going to use 11, just click 11 over here. Okay. The next, it will ask us to kind of install the dependencies. So dependencies are nothing but the various Spring projects that we saw, right? So here you can select all that dependencies and other stuff which is required for us in order to create our project. So the first dependency that we'll require in order to write our application is Spring Web. So either you can see from here or you can also search over here. So you can just type web, and the one which shows Spring Web, you can just click on that. Okay. And there are also a ton of other dependencies which you can see over here. So for the time being, we'll just go with Spring Web. Okay. And that's it. So you can just click on generate right now. So what it will do is it will kind of download a zip folder for you. So next, just go to the downloads folder. So, and you just extract this code. Yeah, so I've extracted this code over here. You can see this demo now. So that's it. We have our basic Spring folder ready now, right? So as I said, Spring gives you a lot of starter project which helps you to kind of fast track your application, right? So this is the practical demo of that. You saw now that, just by selecting a few options, we were able to create a quick starter project, right? So even for a complex application, this is how you start it. So based on whatever dependencies you have, you just kind of like select those dependencies and the language you want, and you can get the starter project created. So the next step is now open Eclipse. So once you open the Eclipse over here, just head over to the file over here, and in the file you will have something called import. Click on that, and in the import there will be something called as a Maven. Click on Maven, and here there will be something called as existing Maven project. Click on that, give next, and here in the root directory just hit on browse. And now just go to the starter project which you downloaded. So in our case, it was demo. So under downloads, I just went to demo and I selected this particular folder now. So once I do that, automatically you see that, this pom.xml will come over here. So pom.xml is nothing but it's kind of a file which gives all the dependencies and information about the project. So once you see this, just click on finish. So at the bottom right hand side, you will see that, there's this small progress bar which is running, which says importing Maven project 9%, 10%. So depending on your computer speed and internet speed, this will take some time. So I just request you all to hold on till this is completed. And meanwhile, till it comes, what you can do is just go to Windows over here, go to Show View, and you can click on Project Explorer. Yep. And once you click on that, just click on this button over here and this will expand. So this will now show you the project which has been opened. So till this Maven importing is completed, we won't be able to run our application. But what I'll do is till then, I'll just try to quickly explain you the structure of what is the structure of the Spring project all about and what we were doing over here, right? So the first folder that you see over here is under demo. You have something called the SRC, and inside this SRC, you have something called main, and inside this, you have Java and resources, right? So this main Java, this Java is where this is have all the Java core packages and classes which we'll be writing for our application, and anything which is non-Java in nature, such as any property files or Spring configuration files, all those kind of files will be going into this resources. And here we don't have another folder here, but usually there'll be also another folder called web app. In case you are also having any deployment descriptions and all, you can put it in that web app. And you'll see this test folder over here. So this is nothing but writing all the unit test cases. So that is why we have this test folder. So again, here you just have Java folders, which means that you'll write test cases for Java application over here. If you also want to write some test cases for non-Java resources, such as property files, configuration and all, you can have a folder over here called resources, just like above. And in that you can dump all your test configuration. And apart from that, pretty much same. So target is nothing but here you all have the metadata, and these are just the pom.xml. As I said, this is the property file of your application, and that's it. These two are the Maven commands. So you can see here that the progress is going good, and the download is going on. So meanwhile, I'll also tell you quickly about another quick thing about Spring. So for that, I'll just go to the whiteboard. So whenever we develop any Spring Boot application, right? So we kind of split our application into layers, okay? So the first layer, this is also similar to what we discussed about the parts of application. So first layer is something called as the presentation layer, which will be talking to the business layer, which will be talking to the persistence layer, and this will be talking to the database layer. So what is all this about is, a presentation layer is nothing but, as I said, this is the front end part of your application that your user interacts with. This will make the calls to the backend and fetch the data and show it to the user. Business layer is nothing but this is the core business logic part or the services part, which is responsible for implementing all the business logic and validation. So anything that deals with any validation, authorization and all that stuff, so that will be handled over here. Persistence layer is nothing but, this is the part where all the logic for talking with your data and storing the data in your database and all that will be handled over here. So anything where you want to convert your data or do all that stuff, that will be handled in the persistence layer. And finally, the database layer is where the actual physical database MySQL, MongoDB or H2, those kind of database would be kind of residing over here. So this is kind of the Spring Boot architecture. So if we have to translate this in terms of Spring objects, so basically what it is like, if you just kind of think about it, so this presentation layer is nothing but kind of the client which will be making the request, that will be kind of handling flowing over to the controller, which is nothing but the business layer over here. Then it will be going to the persistence layer, which is nothing but the service layer, and from there it will be updating the database. So this is how the flow goes of the Spring Boot. So this is just kind of a quick detour we did just to make you guys understand how we kind of structure our Spring Boot code. So now let's go back to the Eclipse. We see that the import is completed because down we don't see any progress. And also here if you see that, you'll see that there is a new folder created which is called Maven dependencies, and if you just open it, you'll see that now there's a ton of dependencies which has been downloaded and installed. So that is the beauty of Spring, right? So just by configuring and selecting a few of the dependencies, it is internally able to find out what are the other dependencies it has, and it is able to download and attach all those Maven dependencies by itself. Right. So as I said, the core of the application code is sitting in this src main Java. So I'll just go to this src main Java. You'll see that a package is already created called com.demo.demo. So this was the name that we gave, right? So com.demo was our artifact name, and this, if you just come to the Spring, so if you just come to the Spring website, you see that the group name was com.demo and the artifact name was demo. So that is why our package name is com.demo.demo. So coming back, so if you just open this package com.demo, you'll see that there is a Java file created which is called as demo application. Just double click on that, and you will see that there is already some dummy code written which just says public static void main, meaning that this is the main class. And here you will see something called as a Spring Boot application with a @. So anything in Spring Boot application, in Spring Boot code which you see with @ symbol, which is nothing but it is called as the Spring Boot annotation. So what is Spring Boot annotation is? So it is basically a metadata which tells your application that what is the properties or what it is, what are the information that are associated with this particular code. So in this case, what we are telling our code is this particular application, this file is the main file for this Spring Boot application. Okay, so that is the use of this Spring Boot application annotation. So don't worry, we also have other annotations as well. So as and when we'll be using each of these annotation, I will just quickly tell you what those annotation does. So for now, you can just remember that whenever you create any Spring Boot application, so the main class of that particular application will have this @Spring Boot application annotation, and it will, when you use that, it will import in order to use that, you have to import it from this particular path. Okay. So now, in order to create our test microservice or test application in Spring Boot, what we will do is we will just go to this package over here, right? And so if you already used created Java, but in case not, let's just go through that procedure of understanding how do we create a simple application, a simple class in Java, right? So all you need to do is just go to this package over here, right click on top of this package. It will open this context menu. Just click on this new over here, and here you just select class. So that will open this window for you. So what we are doing over here is now we are creating a separate class which will be doing which will be handling a request for us. So as you know, microservice is nothing but just a API. So what is a API? It basically is a service which kind of accepts a request and returns a response, right? So in our case, what we'll give the name of this class is, so since the name of our application is demo, so we'll follow the same name nomenclature. So first we will write demo, then, and since this is going to be a REST controller, okay, so we will write the name of this class as REST controller. So just remember that, this has to be a Pascal casing, so which means that the first letter of each word has to be in caps, and you don't need to do any of the other changes. So just give the name as demo REST controller and just click on finish. So once you do that, so automatically a new file gets created under package with the name demo REST controller. And here you see that, by default, it has just created this template code and left it over there. So now what we need to do is we have just created a new class where we are now planning to write our microservice. Okay. So now what we will do is, since this is just a very simple microservice, we will just first write a microservice which on hitting which we just get hello world. Okay. So how to do that? So the first step for that is just above this public class demo REST controller, just click on that, the line above that, and press enter. And after that, just type @. And since this is going to act as a REST controller, we have to use a Spring notation called as REST controller. Okay. So just type REST controller. Just ensure that, the R and C are capital over here. So once you finish typing REST controller, you will see a red line below that because we have not yet imported that package. So to resolve that, on the left hand side, just click on this icon over here. So it will say that, once you click on that, it will say import REST controller from org Spring framework this. So just click on that and automatically now that gets imported for you. So this is another beauty of that. You don't really need to remember each and every path and package. So just type that name. Once that error comes, click on that and then you can import. So this is the step one, where first you convert this particular class as a REST controller, okay, using the Spring Boot annotation. The next step is we have to now define the API. And before we proceed further, in case if you guys are not aware or you guys are not clear, let's just quickly get into whiteboard once. So how does a API or a REST works? I'll just give you a very simple definition of that. So just assume that this is my application or my server. Okay, so just assume that this is my server and say maybe the name of my server is say skill.com, just for example. Okay, and I have a ton of services which has to be exposed to the outside world. So what I will do is, under this domain of skill.com, I will have a ton of services exposed to the outer world. Okay, so maybe I would have something like skill.com, /HR, skill.com / maybe marketing, skill.com / something. So each of these services would be identified with a particular URI, which is nothing but uniform resource identifier. This is different from a URL. So what is a URL is basically nothing but when I say skill.com, that is a URL because it tells a location. But in this case, in that server, it points me to a particular identifier of that particular resource. That's why it is called as URI. Okay. So in case of APIs, we use this word as URI, endpoint URI, to specify the address. So this is how generally we kind of expose the services. But inside the server, what happens is each of this port will be running in a particular, each of the services will be running in a particular port. As I said, microservices are independent and deployed independently. So what happens is this HR microservice could be running in 8080 port. This skill would be running in 8081 port. This would be running in 82 port. This will be 83 port, and so on. So what happens is inside the server, we reserve one port for one particular service, and internally what happens is if you want to kind of access your service, what you will do is you will do skill.com :8080, then you do /skill or HR or whatever you want, right? So this is how we normally access the service internally. But when you are exposing it to the outer world, you just give it like skill.com /HR, and your API gateway will then internally convert this address to this address and route it. So that's why, remember, when we talked about microservice architecture, we also talked about API gateway. So what API, one of the work of API gateway is also this. So from outside world, we don't give the end user all this port number and all. So what we just give them is skill.com /something, the microservice name. Internally, this API gateway will have the mapping that, okay, if it is HR, then it has to go to the 8080 port of this particular server and then point it to the HR service. So that is the work of gateway. Okay. So now with that clear, let's get back to Eclipse. So now as you saw that since we are going to expose a variety of services with each having its own name. So let's now first kind of like, write a simple service which will just return maybe the word hello world. Okay. So how to do that? So the first step of that is you have to use an annotation called as get mapping. So remember that as I said, in order to write any Spring annotations, all you need to do is just use @ and then start like just type the name of that particular annotation in Pascal casing. So once you do that, you'll get this kind of this red annotation, this red error over here, meaning that, you haven't kind of imported that particular package. And before you just click on this, this get mapping has to be completed, like the syntax has to be completed. So what we need to do is just open close bracket. And inside this, all you need to type is value equal mark, double quotes, and inside this just give slash. Okay. And here just close the bracket. And now you can. So before that, all you need to do is just like, write get mapping, open close bracket, value equals to double quotes slash, and still you'll get this error. But before we kind of auto import, we have to finish this syntax. So just to let you know what this get mapping does is, so basically what we are doing over here is whatever function we write below this, right? We are just mapping the HTTP get request of that particular request. So in this case, slash means if the user hits, like if the end user just hits our server, which is in our case localhost :8080. So then that particular request will get mapped to this function what we are writing right now. Okay, and it will fetch that request and it will handle it to this particular function. Okay, that is the work of get mapping. So once you give this annotation, after that you have to bind a particular method below this. So what we'll do is we'll write public, and since we are just going to return a simple string, the type is going to be a string. Next we have to give a name to this method. We'll just give it as say hello, then open close parenthesis, and here we just return a simple hello world. Close it with a semicolon, and let's make it better. We can rather say hello skill link. Okay. And now you can complete this import. So all you need to do is just click on this round over here. You'll get this import get mapping. Click on that. And now this error will be gone, and also this works. So now let's summarize what we have done so far. So the first step was we created this Java class file outside in this package. So that was step number 1. How we did it? Just right click on this, go to new, click on class, and here just give the name of the controller which you are creating. Since we are creating REST controller, we just gave the name of the application and REST controller name. Also remember that the nomenclature or the naming of the file should be such that even if a new developer comes, he or she should be able to make out what this file is doing. So that's why we are giving it the logical name of REST controller, meaning we are writing a controller which is going to handle the REST calls, right? So then after that, what we did is we just added this annotation of REST controller on top of this main class, meaning that telling that, this entire class is going to act as a REST controller handling all the APIs. And next, for each of the API endpoint which we are creating, now we are going to create a particular method to handle that particular request. And in order to make this particular API handle this particular function handle this particular API, we have used this get mapping annotation. So what this get mapping will do is it will listen to the server request, and any request which comes on slash, it will take that and give it to this particular string method. This particular hello method. So in this case, what we have done is whenever any request hits on just localhost :8080, we would be just returning them the string of hello skill link. Okay. So now let's test whether this works fine or not. So how to test it? So if you are a particular traditional Java server developer, or you know a bit about API development, you know that, before you even run your server, you have to configure your server and do all that. But since, as I said, the Spring Boot comes with its own set of internal server configured, we don't need to do any of those configuration. So all you need to do in order to run your application is just go to this package over here, right click and click on run as Java application. That's it. So, and now now for the first time it is asking select the resource to save. So what happens is, like, before you run your code, it's always better that you save your file. So in this case, you can always just click on this checkbox. Okay. And now that's it. So what happens is it will open a new console tab over here where it will say Spring, the version, and you'll see all this 4 file line coming. Sometimes you will see this pop-up coming on Windows, which says that, Windows Firewall has blocked some of these features. So if that is the case, just select that and give allow access. So that will ensure that, Spring Boot is working fine. So now your server is up and running. So how to test whether your server is up and running? If you see the last line, right, in this console, it will say that started application in 6.16 seconds, right? And JVM is running. So which means that your application is up now. So in order to test, we can test it in two ways. So the first step is you can go to Chrome. Just go to Chrome and type localhost colon 8080. So this is the default port where your application runs, and press enter. So you will see that it has given us the value of hello skill link. So this is one way of testing it. So this way of testing works if it is just a simple payload, or you're not sending any payload, like it is just a simple GET request. The other way of testing it is you can also do it in Postman. So how to do it in Postman is, so just go to your Postman over here. So since this is the first time we are kind of testing our application, what we can do is we can just first create a collection. So collection is nothing but, you can just basically call it as a project or a microservice. So just for our case, we are just giving it the name of demo. And inside that, now we can add the lot of other microservices or functionalities which are developed inside it. So here, if you come now, you'll see something called as add a request under demo. So just click on that. So you can give a name to this request. So in my case, I'll just give it as / okay. So this is going to be a get call. So I'm just giving a name as get. And here the URL is going to be localhost colon 8080. Right? And now to test it, all I need to do is just hit on send. You'll see that here now the response has come as hello skill link, right? So that's it. So this is how you can test your application in Postman as well. So in the due course of time, we'll be using Postman extensively especially when we are doing kind of post call and other calls. So Postman is generally preferred for testing the APIs. So I hope till now it is clear how we have written a simple application and how we have kind of tested it as well. So I'll also now give you a few other scenarios, and always remember that whenever you're making any changes to the application, always stop your server and start it, or else the data won't get reflected. So how to stop your server is in the console on the right hand side, you'll see it like a stop button in red. So just click on that. It will stop your server. So now your server is down, and to validate that, all you need to do is just go and refresh this. You'll see that, this will spin for some time and later throw error. So that means that, your server is now stopped. So always ensure that, whenever you want to test your latest code, stop your server and restart it. That is one of the important point. So now let's see another scenario. So let's now create, I'll give you a scenario, right? So now let's just create an API which is just going to return an object. Okay, so object is nothing but a key value pair. So how we can do that? So the first step is we have to write get mapping. So I can do it in the same file as well, right? So in this same demo res controller, below this hello, I can just now create another method. So I will just type get mapping value equals to double quotes. Here I have to specify the name of my microservice name, right? So here I'll just give it as maybe JSON. Okay, so which means that when my user is hitting /JSON, this particular method will get invoked. So next is public. So here, since I'm going to kind of return a JSON object, so I'm going to set the type of this particular method as map, and inside map I'm going to just return a string and object. And again, you'll see there's an error. So for that, what you need to do is first we'll complete this line and then we'll resolve the error. So then the name of this object, I'll just give it as map, and I will then initialize a new hash map. So now what we can do is we just need to import all this stuff. So first I'll import map. So just for that, you just need to click on this error, click on this import map. And here we just missed out parentheses. So that is done. So the next is we also need to import the hash map. So just click on this error over here, hit on hash map. So this error will get resolved now once we just complete this kind of thing. So now what we'll do is inside our map, we'll just put a couple of keys. Okay. So what I'll do is maybe I'll just say key one, I'll just put name, and the value of that I'll just put as skill link. And the second key, I can just put it as maybe location, and I will put the value as Chennai, for example. And finally, I'll return this map. So there has been a small syntax error over here. So that's why we're getting a ton of error. So basically here we forgot to initialize the object, the method name. So here in our case, we'll just give it as get. And now it should be working fine. Align it a bit. So here now for map, we would say give the type as map string object, and that's it. And once you finish that, yeah, now we are good to go. So I'll just summarize what we have done. So here we are returning an API, like we are returning just a string for an API when you hit the slash. But in case you want to return the object, right? So if you take any real world scenarios, we normally return objects, JSON objects. We rarely use API which just returns us string. So in those kind of scenarios, what we can do is we have just created a simple REST controller which just kind of like, gives you an object which having two values, one which will give you name as skill link and location as Chennai. So now let's check whether this works or not. So for that, again the same process. So as we have already stopped our server, just go back to this demo, click on this run Java application, and that's it. So now your Spring application will again restart. And once you just see that started application and 5 seconds, whatever the number over here, so you can head back to maybe Postman. And over here, we'll just create another request. Okay, so how to create another request is just come over here in the demo under collection and just click on add request. So here you just give the name as maybe /JSON. The request here will be localhost 8080/JSON because that is the name of the controller, the service which you have given. Now you hit on send. So now you see that, in the response we have got a proper object, so which has the name as skill link and location as Chennai. So this is how normally we kind of interface between services. We kind of send between JSON objects and not strings or numbers and any those kind of things. Okay. So now we are clear that how we can create simple services using various types and all. So using other JavaScript Java notations, you can kind of create different types of API responses that you want. So in your assignment for this week also, the assignment would be using the same concepts which I learned right now. You would have to return the current server date and time as a string whenever the user makes a request. So say for example, if the user is making a request right now and the time is say 16:54:25 of today, whatever day is, so you have to return it in that particular format. Okay. So the details would be of the assignment will be shared to you later, but this is what you have to do. Create another service which would be kind of exposing that functionality for you. And you can use all the built-in Java libraries and classes which helps you to kind of get the current date, time and all that stuff. So coming back to the discussion. So far we have seen that how to create different APIs and return the various values based on what you require. Since this is just a demo application, we have just hard-coded values and sent it. Over the course of time, we'll actually also connect with a database and also make some transformation on the data before returning it to the end user. So that was all about this creating this sample API REST controller. And before we wrap up, I also wanted to show another thing to you guys. So at present, we are running this server on the default port, which is 8080, as you can see in the log also over here. But what if we want to run our server on a different port? So before doing that, I will just stop our server by terminating it from this console window over here. And after that, what we can do is just come to your Eclipse, just click on anywhere in the code and just press Ctrl Shift and R together. It will open this window. The combination is Ctrl plus Shift plus the letter R. So when you press on that, you will get this window with the name Open Resource. So here you just type application. You will see a file over here called application.properties, which is sitting inside your SRC main resources. So as I said earlier, resources is nothing but anything which is non-Java related configuration and other files, which will be sitting over here. So either you can manually just navigate over here and open it, or directly we can also search for a file from this finder and open it. I highly recommend that you guys use this often because it saves you a lot of time. So just click on this application properties. So you'll see that this is a blank file as of now. So this file is where you configure most of the application related properties. So now I'll just give you a simple demo. So in case you want to change the port of this for application now, say from 8080 to something else. So we can do it by here. So all you need to type is server.port equals to, and now you can type the value you want. So say for example, I want our port to run on say 4200. So that's all I need to do. Save this file. And now when you just run this application again, so just go on the package and just click on run as Java application, the same procedure. So now you will see that, the server will be running on a different port, which is 4200. You can see over here, and the application started. So if you come back to Chrome or Postman and you try running the same request which was earlier, you'll see that now it will be throwing you error that could not send a request. But whereas if I now just change this port to 4200 and again run it, you'll see that this request is running, and same for the other one as well. So if I just run it on 4200, you will see that hello scale link is also coming. So this was also just a short demo to show you how we can manage our application properties with this application.properties file. Over the course of time, there are also a ton of other configuration which will be adding over here in terms of logs and other stuff. So yeah, this was also another stuff which I wanted to show you guys. So with that, we have come to the end of this day one session. And as I said earlier, the assignment for you guys would be to create a new REST API similar to what we have created in the class that will be returning the current server date and time in the format which is given in the questionnaire, and you can just return it as a simple string. And now just let's come back to the slide. So just quickly summarize what we have learned in this week. So in this week, we have learned about the various application architectures, about the various advantages and challenges of application architectures. Then we saw how microservices helps us to build scalable and reliable applications. Then we also saw how Spring Framework helps us to implement microservices faster and efficiently. And finally, we created our first microservices using Spring Boot and Eclipse IDE. So with that, we'll be wrapping up the session for now. Thank you and have a good day. Hello everyone, and welcome to the second week of microservices using Java and Docker. Before proceeding further, now let's recap what we have learned so far in the previous week. So in the previous week, we have learned about the various application architectures and their advantages and challenges. We saw that how there are various other different architectural patterns which exist and how we can use them for various scenarios. Then we saw how microservices help us to build scalable and reliable applications quickly. We saw how by the nature of the design, microservices helps us to create modular services, which in turn helps us to speed up the application development and also kind of helps us to create the application quickly. Then we saw what is Spring Framework. We saw how Spring Framework helps us to create microservices, and we also saw what are the various projects which are available under the Spring Framework like Spring Boot, Spring Cloud and so on. So we just saw a quick introduction of Spring. The next, we also saw how we can create a sample microservices using Spring Boot and Eclipse IDE. We went to the Spring Initializer website, we downloaded our starter kit, and then we just made a few changes in our local and we got the microservice up and running. So that was pretty much about what we did in the last week. So let's quickly see what we are going to learn in this week. So in this week, we will understand what is cloud native applications. We'll try to understand what is the concept of a cloud native application. Next, we will see what is traditional versus cloud native application comparison. So we will understand that what is the main differences or the main points of differences between a traditional application versus a cloud native application. The third thing that we'll see is we'll understand what is the 12 factor for a cloud native application. So in order to build any microservices or cloud native application, it's important that we understand the 12 factor principle behind it. And also recently there have been 3 additional factors which have been proposed. So technically it is 12 plus 3 factors which you will be seeing today. Also, finally we'll understand the sizing and boundary identification for microservices. So what we mean by this is, since we understand that microservices is composed of multiple services, it is very important for you to understand how can we define or identify the services which has to be created. So this is very important step because before getting into any microservice development, we should understand the scope and know the number of microservices which we are going to create. So the learning objectives of this week is we are going to learn about what is cloud native application. We will understand the differences between the traditional and cloud native application. Then we'll understand the 12 factor for building cloud native application. And finally, we'll understand how can we size and identify the boundaries for microservices. So now let's start our discussion with the concept of cloud native application. So cloud native application, as the name implies, is an application that is created for the cloud, and it is resilient, manageable and observable. So let's try to just break it down and understand what we mean by this. So essentially, there are two kinds of application which is available. One is the traditional application and one is the cloud native application. So when we mean cloud native application, it means that this application is created from the scratch for the cloud. Okay. So when we say for the cloud, it means that, you are not kind of maintaining that application or deploying that application in a physical server or in a virtual server that is kind of present in your company or in your premises. Rather, you're creating it on the cloud, and by that definition or by that concept, it becomes resilient, manageable and observable. So what we mean by resilient is, when you deploy anything to the cloud, what happens is there are multiple instances that are spun up on the go, because as we saw in the last week, it is important that your application has to be scalable, meaning if 10 users use your application has to be up, and even if there are 10 lakh customers or users of your application, still your application should be able to handle the load. So it is important that the application is kind of resilient to these loads and any other resource demand that comes on it. So when we create a cloud native application, our application becomes resilient because we are using the benefits of cloud, and we can spun up new instances of application on the go. Second is manageable. This everything is on the cloud, and you're just going to configure the working parts of it or the configuration part of it and not actually manage the server infrastructure and other parts. The application becomes quite manageable. You will have various application properties and configuration properties by which you can easily manage and spin up new instances of application, change the properties and so on. The third is observable. So what we mean by observable is you can easily observe what is the status of your application. For example, you will have these various dashboards, logs and other mechanisms by which you can kind of understand how your application is performing and what is the current status of your entire application. So the next thing that we are going to understand is we'll see what are the major pillars for the success of cloud native application. So in order to create cloud native application, it's important that you have modern design. You have microservices, you have containers, you have backing services, and you have automations. So when you have all these 5 things in place, then you can say that you have created a cloud native application, right? And what is this cloud infrastructure over here is, because ultimately our cloud native application is going to be deployed in a cloud infrastructure. So that's why we say it is this is the cloud infrastructure. So meaning you could use any public cloud like Azure, Google, or AWS, or you can also have your private cloud, or you can also use a hybrid model. Let's understand each of these pillars now. So a microservice is an essential ingredient for building a cloud native application. So this is something we saw even in the last week. So we said that microservice is an essential ingredient for building cloud native application. So if you just go back to the previous slide, you see that when we say that we are creating a cloud native application, we say that it has to be composed of these 5 pillars. So one of this is microservice, the others being modern design, containers, backing service and automation. So what are each of this? We will be seeing it in detail. So as we saw, a microservice is an essential ingredient for building cloud native application. The next is modern design concepts make it simpler to construct and scale applications based on their requirement. So what we mean by a modern design concept? So traditionally what used to happen is your any application which used to be created used to be kind of monolithic in design. So wherein you had these multiple modules or multiple parts of the application being constructed together and just shipped as one single piece of code or software which used to be deployed. And also there weren't too many best practices around when the software development was actually done in the previous days. So by modern design concepts, it just means all the best practices which we have learned over the years, trying to make the application modular. You try to separate the concerns. You just ensure that you one function or one class is only doing one activity or one functionality at a time. So all these kind of the modern principles makes it easier for us to kind of scale and construct the application. Why? Because when we create modular classes or modular applications of functionalities, it becomes easy for us to compose an application of multiple independent units, which in turn can then be scaled up or down based on the requirement. The next is we have a concept called 12-factor methodology, which is a popular approach for developing cloud native application with the recent inclusion of 3 more components, and thus the name 12 plus 3. So what is this 12 factor is nothing but you can just say it is kind of a recipe or a guideline for you to create a cloud native applications, right? So it has a few methodologies or guidelines which is suggested in order to create any cloud native applications. The next pillar we saw is container for a cloud native application. So container is nothing but it helps in packaging of the code and dependencies into a runtime called container image, which can be run on any machine having a container runtime. So don't worry if you don't understand what is this container concept. So just to abstract it, we can just imagine it as, just imagine that you have your code is now bundled into a zip or whatever along with all its other dependencies. Now what we do is we just take this code and put it, just abstract it as like a container, which is kind of the runtime or the environment for this code to execute. So what happens is you can just ship this container to any environment. It could be like your Windows machine, Linux machine, any of the servers that you want to run. And what happens is this container then runs that application within that container such that the entire runtime and environment is standardized, and there is no differences between an application which is running in Windows server versus application which is running in a Linux server. And container helps us to achieve the portability and consistency across any environment and platform. So the advantage is, since you are going to package everything as a container and that container is going to run in a runtime environment, we achieve kind of portability and consistency. The same code behaves the same way across any server or any environment. The next concept which we are going to see is called as backing services. So backing services are nothing but the ancillary services to manage the application listed below. Basically, whenever we have any monitoring apps or message brokering apps or analytics, we use the concept of backing services. So what is backing service technically is they are the services which does not implement your business logic, but they are useful in kind of managing your applications by doing other backend activities monitoring work or messaging brokering work or analytics works. So the cloud native applications prefer managed backing services from cloud vendors. So what we mean by that is, so if you take any of these commercial cloud vendors like AWS or Azure or GCP, which is Google, so you will see that they already have a lot of services which they provide out of the box. For example, for analytics they have certain services. For monitoring your network they have certain services. If you want to scale up or down or do some setup and related configuration, they have certain services. So what happens is, generally when we create any cloud native application, we prefer to have these backing services from the cloud vendor itself rather than creating them by ourselves. So the advantage is we reduce the development time, and also since these are being maintained by the cloud vendors, the maintenance and operations from our end also gets reduced. The next part is automation. The next pillar of cloud native application is automation. So automation is nothing but it just refers to the automation of CI/CD process and infrastructure so that we consistently deliver the stable applications, updates, and we can quickly scale without any overheads. So what that means is, as the name suggests, automation, right? So it means that we are just reducing manual activities or manual work. So the first is automation of CI/CD process. So what is the CI/CD process? So assume that you or your team is creating an application and you have completed your code. So once you commit your code into a repository like GitHub, so automatically there should be automation in place that will directly now read this code, perform certain quality checks like SonarLint, SonarQube, there are certain industry best practices where we first check for the code quality, and then once the code quality passes, then we will do we'll check for the unit test cases result, wherein we will see whether if all the unit test cases are passing. And after that, once that is done, we jump into the CD part, wherein once the build file or the war file, jar file is created from the code, we then take those jar file and deploy it to the servers running these applications so that the entire deployment process is completed. So if you take any major enterprises like Amazon, Google, or any of those even enterprises like Uber, Ola and all that, so what happens is every minute there are tens and hundreds of deployments or CI/CD pipelines which are running. So the application that you use on a day-to-day basis, it could be IRCTC, it could be Uber, Ola, so on and so forth. So though you're using the application in the background, there are deployments and other stuff which are running. and but you don't feel it because your application is always up and running, and there are a lot of things that goes in the background to ensure that your application is staying constantly updated. And what does the automation of infrastructure means is there is a concept called as infrastructure as a code, IAC, wherein we script the entire infrastructure so that it can be used to consistently provision infrastructure across any environment. So in order to explain that, let me tell you a simple example. So assume that you want to have a DB server setup, a database server setup in your environment. Okay. So the normal way to do it, you will first download the exe or the installer of the DB server, then you install it, then you configure all the environment, class path and other stuff that is required, username, password, all that thing that is required. And finally, to start your server, you will either use a script or you would invoke certain batch script and all that stuff. But the problem is this is not end-to-end automated. Though you have certain script to start the server, stop the server and all, but there are also certain manual parts attached to it, downloading the installer, executing the installer, so on and so forth. So what infrastructure as code does is this entire process of right from installing the database server till the point the server is started up or shut down and all that stuff. We will code everything as a script and we'll just upload it to a container or a server. So on executing this entire end-to-end workflow gets executed, and that is what is the concept of infrastructure as a code. And to implement it, we have a lot of popular tool, like we have something called as Terraform, we have something called as Puppet, Ansible, Chef. So all these tools helps us to do it. So now we will just quickly go to the whiteboard and understand all these concepts that we have seen about cloud native application in a bit more detail. So far we have understood, we have discussed about what is a cloud native application, right? So just to quickly summarize, a cloud native application is nothing but it is an application that is designed from the scratch to be implemented in cloud infrastructure, right? And we also saw that there are certain pillars for cloud native applications. Like we saw, it has something called as a modern design. You should have microservices. It should have automation. It should have backing services. And finally, it should have containers. So using all this, we implement cloud native application, right? And also we saw that there are certain guidelines for implementing cloud native application, which is called as the 12-factor app. And also there are additional 3 factors which got recently proposed. So we can either say it as 15 factors or 12 plus 3, or generally it is called as 12 factors, right? So in this course, the reason why this course is developed is we are now interested in learning this part, the microservices part, where we'll try to understand how can we write microservices, how can we create microservices, and using that it will enable you to create the cloud native design. So the other part, like modern design, automation, backing services and containers, we'll also try to cover it in bits and pieces, which is required for us to implement our microservices. But largely your focus is now to understand how can we create microservices and how can we implement microservices, right? And also when we be doing it, we'll also be touching about the other pillars as and when we are creating our microservices. So that was a quick summary of what we have seen so far. And now what we'll do is we'll first try to understand how the application development has evolved over time. So this is just a quick kind of summary for you to understand. So in case you're not really aware of how application development used to happen in the previous days, in the older generation, without that you will not be able to appreciate what is the benefit of cloud native application. So we'll quickly try to summarize how the application development was done before the recent period. So in the older days, what used to happen is, so we can just kind of divide the application development phases into 3 eras, right? So one I would say is till the era of maybe early 2000s, okay? Then the era I would say around 2010s, okay? And after that, the recent period of say I would say after 2015s, okay? So I would say I would just divide this era into kind of this 3 eras, okay? This year is not kind of put in like, it's not kind of very strict sense of definition. But I'm just telling, like, it was around this period that, the new concepts came and the design philosophies changed a bit. Okay. So in the early, in the till the turn of the millennium, that is around 2000, generally the application development used to happen like in a waterfall life cycle. So for the people who are not aware of what is a waterfall life cycle, it is a software development life cycle mechanism wherein we follow a certain step kind of procedure in order to create the software. Like, it starts right from the requirement analysis, then you do kind of like, you try to understand the requirement gathering, then you do analysis, then kind of like, then you do the development, you do the testing, and finally you deploy the complete software. So here there was no concept of like, a minimal working software or like, delivering software in bits and pieces. It was always like, you deliver the entire software in one go. Say for example, you could just imagine like, if I had to develop IRCTC in the early 2000. So unless like, all my functionalities in place, like right from booking of my ticket to like, canceling my ticket to seeing what trains are available. So unless all these features are fully developed, tested and signed off by the end user, I would not be able to complete the software project. So that was the kind of a waterfall method which was used earlier for the software development. And generally what happened is whenever you developed any application, it was largely monolithic. So as we saw even in the week 1, most of the application that was developed in the earlier days, they were monolithic in nature. And what do you mean by monolithic? Is that, everything, all the software components like, your UI part, your API part, your database part, everything was kind of like, created in a very tightly coupled fashion, like wherein if you change anything on the UI or the front end, it will invariably affect the API. And changing anything in the API would invariably affect the database and or vice versa. And next, when this application was created, they were deployed into like, mostly into physical server. Okay. So what we mean by physical server is like there used to be this big servers or the data centers which the companies used to maintain. And all these applications were actually deployed in these physical servers. Okay. And finally, whenever like, since your company used to have like, tons of applications, then obviously you cannot have all the application deployed in one server. So that is why you had this concept of data center, as I just said. So what this data center used to do is, it is nothing but you can say a collection of multiple servers running in the center, wherein like, all your application used to be running there, right? So even today, like, you would have heard that, Google has the data center over here and, Microsoft has a data center over there, so on and so forth. So data center is nothing but it's just a center where all the servers are located and your applications are running, right? So this was the scenario that used to happen like, in the early 2000s till early 2000s, I would say. And by what I mean by this is largely, so like I would say like almost 90% of all the applications which were developed were following kind of this design. So from the period of, I would say like 2000s to like, late 2010s, what happens is there is this concept of agile development that took place. So what is agile concept is, rather than like, creating an entire software from the scratch and then like, waiting till every feature is completed and then deploying it, agile follows an incremental approach, iterative incremental approach. So what it means by that is, so I'll just give a simple example. So say assume that, you want to like, have create a vehicle for your transport purposes. Okay. So what waterfall said is, unless you had a car or like, you had a proper vehicle, you cannot ship that product. But rather in agile, the concept is, if you want to create a transport, you first start with something like a bicycle, right? So you create a bicycle, you test it, get the user feedback, and once the user tells, okay, cycle is good, but it is like, it takes me too much time to pedal. So in the next iteration, what I'll do is I'll create a motorbike or a scooter, right? So in this iteration, I will create a bike and I'll again deliver to the user. The user will test it. Then you will say, yes, now the effort part is less, but still like, I have this probability of falling down, or like, I have this probability of like, if there is rain or like, the weather is not good, I'm not able to reach the place comfortably. Then finally what you do, you create a car. Once you create a car, like, again you go back to the user, get their feedback, you refine the car, so on and so forth. And finally, after say some iterations, you will have a car that like, totally meets the user expectation. So here if you see, The focus is more on like, the user feedback and updating your application features step by step. So that is the concept of agile. So what happened is, like in the late 2010s, in the early 2010s, we kind of used the agile principles more and more in the software development. And once the agile development principle came, there also we started stressing more on modular development. What do you mean by modular development is, instead of like, having a strict monolithic application where only one team can work, we started to have multiple teams as per that agile methodology. So we started to prefer more like a n-tier architecture. So what is the n-tier architecture is, like you have a separate server component, you have a separate front-end component, you have a separate DB component, and all of them were kind of acting in layers, right? And later what we did is, instead of like deploying each and every application into a physical server, there was this concept of virtual machine. So what happened is, on top of physical server, we installed virtual machines, like we had softwares like VMware, in which we again had like, multiple OS, basically like, it's just like virtualization of operating system. So what we did is, inside one physical server, we created 10 different operating systems or virtual operating systems, inside which we can deploy 10 different applications. Okay, so the advantage was like, earlier we had a like kind of like a limitations that, we can only deploy a fixed number of application in a physical server. But once you had virtual machine in place in the same physical server, now you could have or isolate multiple applications which could run in parallel, right? And since we were using this concept of virtual machine, now instead of data center, we moved it into a concept called as hosted platform or a hosted infrastructure. So what that means is, so instead of like, you kind of owning the physical server or managing the physical server, we could now like outsource that part to someone who could do that for us. Like, there were vendors who would be like, giving you the infrastructure, and you could then use that infrastructure to kind of like, create your virtual machine and host it. Then later what happened is, from the mid 2015s onwards, what happened is like, there was this change in the entire software development industry. So what happened is, then we had this software development cycle called as DevOps. So what DevOps basically means is, the developer basically does both the development as well as the operation part. By operation part, we mean the deployment part, maintenance of part, like the unit testing and all that stuff. So everything the developer used to manage, or we could say that, there was kind of a continuous link between the developer and the operation team. That is the concept of DevOps. And since DevOps came into place, it automated a lot of mundane or repeated tasks. And right from this n-tier and monolithic kind of architectures, we moved into the microservices. Okay. And when I mean n-tier in this 2010s, it does not mean that we only had n-tiers. We also had other concepts like SOA, which we saw in the last week. So the other architectures which promoted this modular kind of architecture, like, the n-tier, SOA, event-driven. So all these kind of architectures were kind of embraced in the early 2010s. But from the 2015s, what happened is, since we had this concept of DevOps in place, and we could automate a lot of mundane tasks, we then moved into this concept of architecture of microservices, where we created like, a lot of modular microservices. And instead of like, deploying them into VM or physical servers, we now started shipping them as containers. Okay, so this is where the containers boom came into picture. And now since we have them as container, we started to directly kind of deploy them over cloud. Okay. So if you see, like, due to one thing, the other thing started getting developed. And this is how, like, we now moved into a cloud native architecture or a cloud native applications. So this was just a quick introduction for you to understand how software development came into picture, and how it got evolved over time, and how we reached a spot right now where we could create microservice and automate the end-to-end lifecycle of a application, right from the development till the deployment into cloud. And with that, we have reached the end of this first part. Thank you. Hello all. Welcome to the second session of week 2 of microservices using Java and Docker. So now let's try to understand what is the comparison between traditional and cloud native application. In the previous session demo, we just saw how the application development and infrastructure evolved over time. So now let's build on that discussion. So traditional applications are basically less agile, dependent on infrastructure, less frequently updated, and generally more resource intensive to develop, test, and maintain. So in the last discussion or demo, we saw that traditional applications generally follow the waterfall model, and they are kind of monolithic in nature and architecture, and they are usually deployed or packaged in physical server, and they just exist in the data center. So due to that, the issue is they are very less agile, meaning they can't adapt, or if there is any change in requirement. So what happens is in traditional application or in the waterfall world, what happens is once your requirement is given by the customer and you start the application development, there is no scope for you to change the requirement midway. Okay, so that is the kind of principle in waterfall where you freeze your requirement before the application development starts. But what happens in real world is in the agile world or even in the real world, what happens is the requirement are quite fluid. I'll give you a simple example. So say assume that you wanted to build a food ordering application, right? And you decided that you're going to allow your customers to book food from the nearby restaurants. But over the time, you also see that there is demand from the customer to also kind of order groceries, or have some delivery mechanism where they can quickly send certain items to their friends or relatives who are living nearby. So if you want to also add those kind of functionalities in a traditional water cycle, that is not possible until you create the entire application and again go back to the requirement gathering phase. Whereas in Agile, since we are just breaking down the application into small chunks and iterating over time, it is quite easy for us to implement all these changes in the next cycle or the next iteration. And if you just contrast that with cloud native application, so by principle we can say the cloud native application is agile, independent of underlying infrastructure. It is frequently updated, more secure, and good at managing resources efficiently. So as you saw in the demo of the last session, we saw that agile, once the evolution happened of the software development world, we slowly moved from this waterfall mechanism to agile and DevOps. So what happened is, since it is agile now, being agile, the advantage is you can quickly develop your application in bits and pieces, like in small chunks of minimal viable product or iterations. And as I gave you the example of transport, you start first with a bicycle, then upgrade it to a bike, then upgrade it to a car, and then make it a super luxury car, and so on and so forth. So using the same concept, the agile works on the customer feedback. So you just develop a quick working software prototype, get the feedback from the customer, and keep on improving it. The second point, we also saw that it is independent of underlying infrastructure. So as we saw that instead of directly deploying our application on the physical server or virtual servers, we are now shipping our microservices as part of containers, which is getting deployed into cloud. So the cloud vendors are the person who are going to manage all these physical hardwares and data centers for us. We don't have to worry anything about it. So in simple word, if tomorrow you get a startup idea and you want to kind of develop your own application, so you don't have to really bother about what is going to be my server or where I'm going to keep my server, how I'm going to host it, and all that stuff. All you need is a subscription from any of the cloud vendors like Azure or Google or AWS, depending on who you like. And once you have it and the pipeline set up, you can directly deploy and get your application up and running in no time. The third is it is frequently updated. So as we saw even in the previous demo discussion, that any application these days that you use frequently, it could be Google, Facebook, it could be Uber, Ola, Swiggy, Zomato, whatever it may be. So all these are kind of frequently updated. There are tens and thousands of deployments that are running every day in the backend. And your application is frequently updated just to ensure that you get the latest updates, all the security vulnerabilities are fixed, any bugs that are reported that are fixed, any new features that are required are added, so on and so forth. And why that is possible, again it goes back to this agile principle. Since we have modular teams, we have small iterations, it is easy for us to kind of deliver frequent updates. And also it is more secure. Why it is more secure? Because since you are developing a cloud native application following all the modern best practices, you are creating modular classes or components, you aren't mixing too many logic in one class, and also you are keeping them securely in a container which gets deployed in this specific tenant in the cloud. So it makes your application more secure. And finally, we also see that it is good at managing resources efficiently. And why that is the case? Because unlike the earlier software development life cycles or principles, wherein you just had one application which used to run in the physical server and consume all the resources. Here the concept is you just develop modular services, each of which is now running in its own container, which is again deployed in cloud. So what happens is if you just take a real world example, I'll just give you a real world example. So assume that you have created an application or microservice application or a cloud native application and you are deployed in the cloud. So normally how these cloud vendors charge you is they charge you for the time that particular container is up. So say for example, I have developed say maybe a clone of IRCTC, or you assume that I have created a travel book agency like makemytrip.com. So what happens is assume I have now 10 instances of my application running. So what the cloud vendor will charge me is for the time these 10 instances are up, or these 10 servers, the server instances are up, right? And in case in the future, there is less demand on my server. So say I am it's a non-peak season, or there's some COVID related lockdown that came in. So I don't really require 10 instances of my server running to handle all the server load. I can just have maybe 1 or 2 servers running, which can handle the minimal load that is coming. So in that case, what happens is the 8 of my servers will be just shut down, and the cloud vendor is not going to charge me for those 8 instances. Similarly, vice versa, assume that there's a summer vacation coming up, and there's quite a load on my application. So instead of having 10 instances, I could have 100 instances running. And what happens is dynamically, since I have 100 instances running, the cloud vendor will charge me for the 100 instances running time which is coming for that particular month. So that the advantage of that is we can manage the resource efficiently. We don't have to keep the server running up all the time. We don't have to keep it off at all the time. So based on the load, we can dynamically adjust it. So now let's get into a quick demo and understand how this traditional and cloud native application works. So we just again come back to the same evolution that we saw in the last demo. So just to a quick recap for you, as we just saw. So right from this waterfall model till this DevOps model, we have kind of evolved iteratively over the time. And as you can see, the underlying architecture and the way we design it is what determines the entire ecosystem. So if you see in the waterfall model, as I said, the requirements are really kind of frozen before the development starts, and that's the reason what happens is you also had this architecture like Monolithic, where we packaged all these components together as one single component, and then we kind of deployed it into a physical server, and then we had the data center which kind of hosted all these physical servers. And as the time evolved, what happened is we realized deploying a application directly into physical server is not really efficient or cost friendly. So that is why we invented this concept of virtual machines, wherein we had one large physical server inside which we created a lot of virtual machines inside which our applications were deployed, right? And here we also had this concept of hosted. So instead of having our own data centers, we could also kind of lease or take on rent physical servers from any third-party vendors and have the virtual machines inside it for us. And finally, this got evolved into the cloud, wherein we had this third-party vendors like Amazon, Google, who gave us this infrastructure, and all we needed to do was just create our application and create pipelines which would directly deploy our application into them. So before going any further, now let's just try to understand quickly, since we have been talking a lot about cloud native application, okay? So I just want to quickly kind of summarize the benefits of cloud native applications. So it kind of becomes clear to you what is the advantage or what is the end result of doing all this, why we create microservices, containers, backing services and all this stuff. So what is the end result of it? So the first thing that we get is resiliency, as we saw, right? So what do we mean by resiliency is it can't stay online at all times. Okay, so it means that, as I gave you the example, so even if the traffic is less, the traffic is more, your application should be up and running at all time. That means it is resilient, right? So that is the meaning of resilient. The second thing we saw is the advantage of having cloud native application is it's quite independent. So what do you mean by independent is since we are creating different modules or say different services, right? So it can be possible that each of the services can be created with its own architecture or underlying technology. So say for example, this service I could create with Java, this service I could create with .NET, this service I could create with Python, and even the database could be different. For example, I could use MySQL, here I could use NoSQL, here I could use something like a GraphQL, so on and so forth. So the concept is I could mix and match multiple technologies to create my different services. At the end of the day, I could still ship all of them together as a microservice because the interaction between them is minimal or zero. This is quite independent, it runs on its own. This is independent, runs on its own. This is independent, runs on its own. And also all of these follow a common API pattern, which means that they expose certain APIs and they expect to have that contract between them, where they expect the request to be in certain format and they will give the response in certain format, mostly in a JSON format, right, which is object key value object pair. So that is the reason what happens is your cloud native is quite independent. So it doesn't really have to have a tight binding between multiple services or worry about technologies. So what used to happen in the previous days is, so say example, if you are a large organization, so say maybe say you are a organization as large as say Facebook. What used to happen is if you decided at the enterprise level that we are going to go with Java or .NET or Python or C or whatever, it becomes important that all your departments are following the same technology. So if tomorrow some new technology comes in, again at the enterprise level, you have to do that direction change and rewrite or do all that stuff. Else what happens is, because before the microservices era, we didn't really had this independence, or before this REST concepts came into play, we really didn't have the standard concepts of you give me this request and I'll give you this response. So that all those concepts only started when the SOA was initially implemented. So that's where this this concept of decoupling first came into picture. And once the microservice came, these concepts really stuck along, right? So this was the second advantage. The third advantage is it became quite manageable to have all the services here. So what that means is, since we had automation in place, we had concepts like DevOps and all that stuff, it became very easy for us to manage our application. If you want to do a deployment, all you need to do is just commit your code and the deployment just happened in the background using the CI/CD pipeline, right? If you wanted to test your code for quality, once you committed your code, automatically the unit test cases, all that unit testing and all that stuff, the quality linting and all that things can be run in the background automatically. So the advantage is you just focused only on the application core functionality. The rest of the part became easily manageable because you had the necessary automation in the place, right? And the third is, it also became kind of observable. So what you mean by observable is, so in the earlier days when we had the applications I'm talking before the microservices and cloud and all this stuff. So usually what used to happen is, there used to be an application, you deployed it in a server, and again in that server you used to have a ton of monitoring software which again gave you certain data with which you developed a dashboard and you used to see the running status of all the application and the servers which are doing, right? So this involved certain manual efforts. But now, thanks to the cloud native application, what happened is all this stuff became quite easy, because since you're using vendor, you're using third-party vendors like Google, Amazon, and all that stuff. Once you deploy your application in these cloud server premises, what happens is they by themselves kind of give you or expose you certain APIs and dashboard, through which it becomes easy for you to quickly monitor what is your application load, which server is performing well, which instance is not performing well, and what is the load, throughput, and all that stuff. So it becomes quite easy for us to observe what the application is doing, what is the real-time status, so on and so forth. So this is the kind of the advantage which cloud native application provides us. And before we end, I also want to quickly just give a conceptual overview of how can we get into a cloud native application mode. So this is just for your understanding. It's not related to the course, but I felt this will be a better way for you to understand how can we really adopt cloud native concepts, right? So there are basically kind of 4 stages how you develop any cloud native application. Okay. The first stage is you adopt the principles of cloud native. That is the first stage. The second stage is you actually build and develop. So once the second step is you build and develop your application. The third is you deploy the application. And the final step is you operate, right? Or rather you can say you maintain it. Okay. So these are the 4 major steps on how you create a cloud native application. Okay. So let's quickly see one by one what we mean. Okay. So just have this in mind. So whenever you want to get into the concept of creating, so this can also be an important interview question for you. So if someone asks you, okay, you say a lot about cloud native application. Can you tell me if I have to implement cloud native application, what are the steps for it? So you can say that, there are 4 basic concepts or basic steps. So first is you have to first adopt the principles of cloud native application. Using that principles, you develop and build your application. Once you have built and developed your application, you go ahead and deploy it. And once you deploy it, you maintain or operate it. And what we will also see now, what goes inside each of these steps. So the first step that we saw is the adopt part, right? So in adopt part, basically what happens is we have to first get into the concept of the cloud native mindset, right? So the first thing is, since it is a cloud, right? So what we basically do is we need to have a cloud account, right? So basically we need to have a cloud account in place where we can use the infrastructure for us to create it. The next, we have to ensure that we follow this API concept wherein any services that we are going to create is going to follow the API pattern wherein it will accept request in a certain pattern and it will give the response in a certain pattern, right? So we have to follow that. The next concept is we will be having certain architecture principles in place, which is basically the microservice architecture. So wherein we would be creating the application architecture and all that stuff. And also we would also follow the modern design best practices. Like we would keep it modular, we would have it only do one class do one function at a time, so on and so forth. We won't unnecessarily repeat the code and all that stuff. So this is the first phase where we first adopt the cloud native part and we get into the mindset. Obviously we will also have the agile methodology and also the DevOps lifecycle in the place, right? So this is the first part. In the second part, which is the actual build or develop part, right? So this is a part where we actually going to implement our API designs. So whatever designs we have created earlier, we are going to implement it, right? And along with that, we will also have the other parts of the application which gets built. We will have this DevOps setup, pipeline setup in place, right? So in the adopt phase, we only just decided that we will be getting into the the DevOps and all that stuff. So this is a phase where we actually going to implement it, right? And along with that, any of the SDK, software development kit, or CLI, command line interface, or any of those stuff which will be required for you to develop and create your application will be used over here. And finally, we'll also be using some of the cloud services or concepts which will be implemented. As we saw, backing services are provided by the cloud vendors. So if there are certain services which you need to use, analytics or monitoring, message brokers, so we'll also be using the cloud managed services over in this phase, right? So this was about the build and develop phase. The third phase, the third step is we deploy it. So deploy, as we saw that it is going to be deployed in the cloud, and since we are going to use microservices, majorly what we will be concerned is the first is the API gateway. So what is the API gateway basically is, so in a real world, what happens is when I expose my service, right? Just understand that whenever you expose your service, internally your service would be mapped to a particular port, and it will be having its own name and all that stuff. But when you expose it to a real world or a third-party world, you will be just exposing it in a simple name. So say something like, I'm just giving an example, bank.in/accounts. Okay. So what happens is, internally, when this bank.in request comes to your server, it will first get into the API gateway. Your API gateway will have a mapping. So it will first check out that, what is the server or the service that is actually hosting this bank.in/account. So then from this registry, it will find out that, there is a server container which is running at port maybe 8081, and it is exposing this bank account. So what it will do is, it will take that request, take it to the container or the server which is running on the port 8081 accounts API, and forward the service, right? And similarly, we will also have functions in the deployment step. So what is functions is nothing but, you can just say these are certain I would say functionalities or certain activities which are carried out during the deployment process. Probably it could be like converting the packages, or transpiling the code, so on and so forth. And then you would have something like your Docker container, or basically the orchestration part. So what is the orchestration part is the way all your containers are now deployed into the server and how they are managed. So that part is called as the orchestration. And usually to do this, we have certain tool like Kubernetes. We also have a section on Kubernetes down the line. So you'll understand how you kind of manage your entire application using Kubernetes, right? And finally, you also have concept like service mesh. So service mesh, as the name suggests, is nothing but it's just a mesh, or you can say a grid of different services which are running, or which will be used for your deployment of your application, right? So basically, why we use service meshes to enable service to service communication, right? It is a infrastructure concept. And finally, we saw that we have the step of operate or maintain. So what the operate or maintain step does is, as the name suggests, it is once your application is deployed. So we are here, from here we kind of maintain our application. So here the concepts that you implement are you implement the monitoring part, which is a backing service, right? You do logging, so you want to check how your application is doing, so you use logging. Then you have analytics, right? Probably you would have periodic email alerts. So say if you want to notify your end users or your administrators that something is up, down and all that, you'll be doing that. And after that, you'd also have something like maybe security services or security stuff, patching and all that stuff. So if there is certain security patches which has to be updated or all that stuff, you'll be doing over here. And also you'll be monitoring the events in your application, so on and so forth. So this is the operate part. So with that, I hope you guys understood that how we can adopt the cloud native application concepts and implement our own application. So what we are going to do is basically I'll just give you a quick overview of what we are going to do in our course. So in our course, as I said, the focus is on creating the microservices, right? So microservices is nothing but it is just a API, right? Which will expect certain request and it will give you certain response. Okay, we are not concerned with the front end part, the UI part, and we are also not concerned with the back end part with regards to this course. Why? Because these itself are a course on their own, they will take a lot of time to create and understand. But rather what we are more under focused is are concerned to understand is interested to understand rather, I would say, is the API part, wherein we will understand how can we create this API to specification, how can we interface it with the backend, and how can we expose the responses which can be then used by UI, so on and so forth. Okay. And in order to create this microservices, we would be using all this concept that we have seen so far. So say for example, first we'll create a basic microservice, then we will migrate it into a Docker image. Then we will then take it into a Kubernetes. Then we will also try use certain Docker related commands like Docker compose, build packs and all that stuff to automate the build image and configuration and all that stuff. And finally, at the end of the course, we also have a short introduction into the UI part, wherein we'll create a UI layer of the application using the Spring MVC and connect it with the database and create a sample application, right? And for the purpose of microservices, you'll be focusing on a bank application, wherein we'll try to understand how can we create a simple bank application. So that will be part of the week 3 discussion. So with that, we have come to the end of this comparison between the traditional and cloud native application. See you in the next session. Bye. Welcome back to this third session of the second week of microservices using Java and Spring, Docker. So in this session, now we'll understand what are the 12 factors which are required for cloud native application. So the 12-factor application methodology is an industry-wide accepted principle to implement cloud native applications. Over time, 3 more factors were added to this to further modernize and update its application design. So basically what it means is, in the industry, they have adopted a principle which is called as 12-factor application methodology. So what happens is, whenever you have to develop any cloud native application, it is recommended that we follow these principles in order to develop it. And since, as we know, that world is updating, so over the time what happened is 3 more factors were proposed or added to this. So now it becomes kind of 12 plus 3. So what are the 12 factors? So the 12 factors are code base, dependencies, config, backing services, build, release, run, processes, port binding, concurrency, disposability, dev, prod, parity, logs, admin processes. So these are kind of the 12 factors. Don't worry if you really can't kind of memorize it. What we'll do is we'll just try to understand what are the basic concepts behind it, so it becomes easy for you to remember it over the time. So the additional 3 factors which were proposed by Kevin Hoffman are as follows. The first is API first, the second is telemetry, and the third is authentication and authorization. So based on the updating technologies, these 3 factors got added later. So now it is 12 plus 3, which is 15. So now we'll quickly understand, just go through each of these principles and quickly understand what they mean, right? So the first is code base. So code base tracks a single code base in the version control system and has multiple deployments. So what it means is, assume that you have a taxi ordering app. So you kind of commit your code and maintain this code in a single code base in the version control system. So what is a version control system? Is any repository which you use to commit or store your code. So it could be GitHub, it could be Bitbucket, so on and so forth. And what happens is, any commit or any change that you do to your code will trigger a deployment. So as we saw that you can create automated CI/CD pipeline, continuous integration and continuous deployment pipeline. What that does is, whenever you commit any code into your repository, automatically it will monitor the repository, and if it finds a new change or new commit, it will then trigger the build cycle, wherein it will first check the code for quality and all that, consistency and all that stuff. And once it passes all that checks, it will build the code, war file or jar file, the deployable artifact of the application, and finally it will deploy it to the servers. Okay. The second is the dependencies. So the dependencies of the code should be explicitly called out and isolated. So what it means that, if your code is depending on any third-party libraries, it could depend on some DB drivers, it could depend on some third-party libraries. So all that dependencies of the code should be explicitly called out and isolated. The third is configuration. So what it means is, configuration should be stored in an environment. This is an important part, because later in the week 4, we will be understanding how can we separate the configuration out of our application. So what it basically means is, whenever you have an application, definitely it will have certain configurations, right? Say for example, if you're connecting to a database, then obviously the parameters for your database, like what is the database address, what is the type of database, what is the user ID password which we use to connect to the database server. So all these kind of configurations should not be kept inside your application. It should be kind of separate from the application. And what is the advantage of that is, if tomorrow you have to change any configuration, you don't have to redeploy your entire application. Since this configuration is sitting outside your application, just making the change to the configuration will automatically update the application. The next is backing services. So all the backing services should be considered as attached resources. So what it means is, any backing services which you have, monitoring, your logging, analytics, so on, it should be considered as a attached services. Okay. The next is build, release, run. what it means is separation of build and run stages should be maintained. Meaning, like when you build your application, that stage is different, and when you actually execute or run your application, that stage should be different. Like each one should have its own stages. The next is processes. So the application should be executed as stateless process. What we mean by stateless processes is nothing but, you can say, it's the implementation of REST API, right? So what is the REST or representational state transfer API protocol is? Your application should not have its own state. So given a particular set of input, it should give you a same set of output, right? So earlier in the monolithic world, what used to happen is the application can also have its own internal states. So wherein, for example, if you had a session running, the application used to store that session within the application, and all that stuff used to happen. But in the REST world, what happens is it should be a stateless process. So it will not have its own state, or it will not maintain its own parameters. Depending on the given request, it will give you the same output. Okay. The next is port binding. So what is port binding is, your microservices should be available via port binding, meaning there will be a single server. So say, assume that, for the purpose of our demo, or even for when you actually deploy your microservices, what happens is the microservices will be running in certain containers which on a certain particular port. So say, for example, in our local computer, we could expose one microservices on 8080 port, the other microservice on 8081 port, so on and so forth. The advantage of that is, since we are binding each microservice to a single port of the server, we can run multiple microservices in parallel. The next factor is concurrency. So this is again building on what we saw earlier. Like since we can bind different microservices to different port, we can also run multiple processes in parallel to scale. Meaning, we can run multiple copies of our application depending on the requirement of the application. So remember, in the previous discussion we said, if the the resource requirement of the application is less, we could have maybe one or two server or instances running. If the demand is more, we could even have like hundreds and thousands of servers or instances running. So that is the concept of concurrency, where you can have parallel copies or parallel instances of the application running in order to meet the resource requirement. The next is disposability. So what disposability means is, any microservices should be easily able to start up and shut down, and it should be smooth and fast. So as we said, the advantage of cloud is, depending on the load, you can easily start or stop any new microservices instance. So this is to ensure that that happens as quickly as possible. The next is dev and prod parity. So what that means is, usually in the development world, like before the microservices or cloud native application concepts were in play, usually what used to happen is your development and the lower environments. So what we mean by lower environments is any environment which is not production or actually used by end user. The environment where the developers used to develop and test the application. The configuration and the data in that environment used to be different from the production. So we just used to have a small set of test data, and the server were not really that powerful as the production server, so on and so forth, because this was mainly done to reduce the cost. But now, thanks due to the cloud native cloud infrastructure and other stuff, we say that the differences between this environment should be minimal, or rather as close to zero as possible. So which means that even in the lower environment like dev, test, QA, UAT and those kind of environments, the data and the configuration and the infrastructure should be as similar to the prod as possible. So the advantage of that is, you kind of reduce any differences between multiple environments, and due to container, now this is possible. The next is logs. So what is logs is the principle here is, we say that we should separate the concept of log generation from log processing. So log generation means that any event or any trigger that creates the log, that should be separate from log processing. So log processing is the part where you actually do the analytics on the log, where you say, okay, how long is my application running, what is the error, what is the type of error, so on and so forth. The next, we also say that we should have admin processes, and we should execute admin task as one-off scripts and keep them as part of code base. So what does this mean is, so say for example, whenever my application run, I also want to start a few other background scripts, or I want to perform certain administrative tasks, maybe inserting a few records to the database and so on. So what the 12 factor says is that all these admin task related stuff should be written as a one-off script that can be executed during the runtime, and they should also be kept as part of the code base. So the advantage is we can have all this as in a single repository. The next is API first. So we say that we make everything as part of the 12-factor application. We say that we make everything as a microservice instead of monolithic application. So we create only APIs, which is like application programming interface, which expects certain request and format and gives you output in a certain request format, right? The next, this three are what was introduced by Kevin Hoffman after the 12 factors. So the latest one is called as the telemetry. So what is telemetry is, I'll give you a very simple example. So assume that you are now using your mobile phone. So every second, what happens is your mobile phone is sending certain data to the Google servers automatically, even without you asking it or they asking it. So for example, it would send the Google servers data about what is your phone current position of your current phone, like is it lying in a horizontal manner or in a vertical manner, is what is the network status, is your signal full or you have a weak signal, what is your battery status, so on and so forth. So this is called as telemetry. So what telemetry does is, whatever is the environment related information for your application, you should collect that and you should use it for future analysis. So where this is useful is, so say assume that you see that your application kind of gets down every now and then, right? So using telemetry, then you would be able to find out it was getting down because the DB server at that particular instance also had a load, or it was not able to process the incoming request. So that is the kind of analytics which we can do when we have telemetry. The next is authentication and authorization. So what this means is, we should implement identity or role-based access control from the start. Meaning, if our application is going to be secure or only going to be used by certain subset of user, then we should be creating this role-based access control or identity from the scratch. Meaning, if say only the managers would be able to hit certain kind of APIs or certain kind of functionality, then from the scratch I should ensure that I have this necessary authentication authorization in place. And with this, we'll just quickly get into the whiteboard and understand a quick summary of what the 12 factors are. So just to quickly summarize what we have learned, okay. So what I'll do is, I'll just paraphrase or rephrase what we have learned so far, okay. So the 12 factors, we'll just quickly see them one by one. The first thing that we saw is the code base. So what that means is, for every one application that you have, you should have one code base attached to it, okay. So this application will be directly tied to this code base. So that is the concept. So microservices need separate release schedules, and they need to upgrade, deploy without impacting others. So we should ensure that each application has its own code base. The second stuff that we saw, so this is not in the same order that we saw in the slide. We are just taking it one by one quickly. So we say that we should also have kind of the API approach. So where we say that the microservice ecosystem requires a contract, or where we expect a request to be in certain format and the response will be in the certain format, okay. So the advantage of that is, we kind of create independent APIs which are not tightly coupled with other APIs. The third is dependency management. So what we say in the dependency is we have to explicitly declare the dependencies in our application, and we have to include all the dependencies with the application release. And we kind of or rather, to put it another way, we have to say that the application cannot rely on your host or your system for any other dependencies. We have to ensure that we explicitly call out all these dependencies, and all of these are kind of packaged in the same container where your application is residing, okay. The next, we saw this concept of build, release and run, right? So what it means is, it is a iterative cycle, right? First you kind of build your application, then you kind of release your deploy or build your actual code and all that stuff, and then you actually kind of run as nothing but you kind of actually execute it or deploy it to the environment where it is executed and being used by your application users. So it's kind of a iterative cycle that keeps on running. So the next is, we saw that you should have everything as configuration. configuration management. So what it means is your configuration should be external to the application. You should not hard code all your configuration within your application, but we should keep it outside, and we should keep it external to the application, so that even in the case where the application is kind of we need to update some configuration, we don't need to redeploy the application. The next concept that we saw was logging. So what we saw in that is we have to have the log generation and log analytics separately, wherein you generate the logs and also you kind of analyze the logs in a separate fashion. The next is disposability. So disposability was we saw that the application should be designed in such a way that your microservices can be quickly started up, and at the same time it should be able to gracefully shut down. Okay, there should not be much time lag between that, because as we saw, whenever there is scalability into picture, we need to start new instances of the server, or we need to bring down certain instances, that should be as quick as possible. Next, we saw backing services. So what that means is we assume that all the resources will be provided directly by the backing services. So say for example you are using certain backing services like say monitoring or logging, which is coming from say the cloud vendor itself, then the resources has to be provided by the backing services itself, right? Then next we saw the parity between the environments. So we say that all the environments, right from the dev till the prod, they should be as consistent as possible, so that our development, testing and the real world application are working in the same kind of constraints, right? The next we saw is on the admin process. So what we said is any administration process like your database migrations and all that stuff, it should be like a one-off script or run one script, and it should be part of your application code base itself. So the 11th one we saw was port binding. So what is port binding is, we saw that every microservice that runs, right, it should be bound, or it should be bound to a particular port in that server. So say for example, if I have a microservice running, so on 8080 I could have one microservice running, on 9091 I could have another microservice running, so on and so forth. So all these ports are exposed in your containers, which kind of then used by external applications to access your microservice. Then the 12th concept we saw was the stateless process. So what we said over there is there is no state which is handled directly or kept in your application itself. Your microservice will not have any state, and in case if you need to have any state, then you have to create a cross-cutting backing service which will kind of have a general state. But otherwise your application by itself will not have any in-memory state. So you give it a request and every time it will give you the same response. It's not the first request will give you cert. For the same request you cannot have multiple response coming over the time. And the next we saw something as concurrency. So what is concurrency is we can scale up and down, or have multiple instances of the same services running across multiple containers as and when the demand requires, right? So the advantage of this is as I said, if the load is less, you just have maybe 2 copies running, but if the load is more, you could also have 100 of copies running in parallel. The next is telemetry. So what telemetry says is collect as much as information as possible from the environment of the container, it could be the container RAM, the status of all other services which is running, what is the application log or the data that is passing, so on and so forth. The advantages over the time when you do analytics, this data will be helpful. And finally, we saw something called as authentication and authorization. So what authentication and authorization talks about is security. So the security should be built in your application. So this is nothing but end of the day you can say it's as security, right? So any resource access which is required, you have from the day one, you have to ensure that it is tied to a particular role or particular identity, and only those people should be able to access it. Okay, and to implement it, we have a lot of concepts like bearer tokens, OAuth, and all that stuff. So, and also one more thing is once you are implementing this, it's also important that you also audit how it is happening. So say You should have logs of how can you logs of understand who are the users of your services, was there any intrusion access, any intrusion that was detected, so on and so forth. So with that, we have now understood what is this 12 factors, or there are various way to call it. General rule is to call it as 12 factors, or you can say as 15 factors because now the 3 factors got added, or you can also say it as 12 plus 3 factors, right? So now we have understood how these 12 factors work. So with that, we have come to end of this session. Thank you and looking forward to see you in the next session. Bye. Hello all. Welcome to this fourth session of week 2. In this session, now we'll understand the sizing and boundary identification for microservices. So when starting to design any microservice-based application, it is important that we determine the number of microservices that must be created and which are appropriately sized. Combining too many functionalities in an API or microservice makes the application too monolithic and tightly bound, whereas creating too many services will make the system fragmented and resource intensive. So what it basically means is, since we understand that microservices are nothing but, they are kind of modular representation of the entire application, and we create number of microservices based on the functionality. It is important that we create the right size and identify the boundaries for each of the microservice. What we mean by boundary is we should identify what is the functionality, or the expected functionality of each of these services, and sizing means what is the total number of microservices which we have to create. Hence, it is important that to ensure that we only create the appropriate number of services that are easily scalable and maintainable and suits the purpose at hand. We will see this with an example with a banking and e-commerce application in the next demo. So now let's get into the demo of seeing how the sizing and boundary identification for microservices actually work. So coming back to the whiteboard, before getting into the actual process of the creating the microservices, let's first try to understand how does a typical application requirement comes. This is important, especially if you don't have any industry experience of software development. So what first happens is, there are people who are called as the business owners, or you can say product owners. Okay. So what these people do is, they will envision a product or an application for their particular business, depending on the domain, right? If it is a banking application, or it could be a retail application, it could be any health related application, so on and so forth. So what these people generally do is, they first give you a requirement. So what this requirement is, they would say that, I want an application, or say, let's take a simple example of bank, for example. So they would say that, I'm starting a new bank, maybe I'm starting a new bank in India, and I'm expecting my bank to have these 4 functionalities. So say for example, it could have deposit accounts, it could be saving account, fixed deposit, so on and so forth. It could also have a cards department where I can issue debit card and credit card. I would, being a bank, I'll also definitely give loans to my customer, and maybe I could also have a department that deals with insurance, for example, right? So I want to have an application that helps me enable or manage all these 4 departments. So this would be kind of a high level requirement which will be given by the business owners. And again, inside each of these, they would have certain kind of requirements. So say for accounts, they would say that my accounts could be of 2 type. Either it could be a saving account, or it could be a fixed deposit. For credit card, I could have a debit card or credit card. For loan, I could have a number of loans, I could have gold loans, education loans, house loans, vehicle loans. And insurance, again, I could have life insurance, health insurance, so on and so forth. So, and then again, inside each of these, you could have a lot of requirements. So say for example, you could say for my saving bank, I need to follow these following rules. When a customer opens an account, these are the minimum documents which is required, so on and so forth. So these are kind of the requirements which gets kind of documented by the product owners or the business owners, and they get entered into your agile board, or the storyboard as say epics, or backlog items. So this is how it works in the agile world. So what happens is in agile world, you will have a tracking tool. It could be Jira or any of those tools which we use for tracking the stories. So what happens is all these requirements gets logged here as a backlog item. So backlog item is these are something which has not yet come for the entire team discussion. So what happens is why we are discussing all this is just to give you a background of how this actually happens in the industry, right? So you can appreciate how these things are actually going in the industry. So first thing that happens is all these business owners or product owners, they give you the requirements in a backlog. So backlog is nothing but these are the stories which is required. But as of now, it has not come up for the entire team discussion, right? So all these things will enter the backlog. So this is step 1. So the step 2 is you have these sessions in your agile principles called as the backlog grooming. And once the backlog grooming is done, you also have this PI planning sessions, right? So what happens in these sessions is any stories which are taken which are there in the backlog, it is taken up by the scrum master for an entire review with the team. So the team here means everyone. It starts right from the product owner. So product owner is nothing but the primary Spock who would be responsible for the functionality of the application. Then also the technical architect of the application and the developers, testers, QA and all that people who are going to implement the application. So this entire team would be now sitting with the product owner and scrum master to understand what is each and every requirement and what is the priority. So say for example the product owner says now in this week, in this month we need to ensure that the account department is completed. Or maybe the product owner says that we can have 2 teams and one team can work on accounts and one team can work on cards and we need to get it done by end of the month. So those kind of prioritization happens in the backlog grooming and the PI planning. So PI planning means what is the specific set of tasks which we are going to take for the current iteration, right? So once this is done, the next part is this is where actually once the PI planning and the the story grooming is happening, that is when the architect work comes into the play, the technical architect works comes into play. So what he or she will do is based on the functional requirement given by the business owner. So say for example in our case, we'll just kind of try to make it a simple one for you to understand. So here our architect understands that we need to create a banking application, right? And this application predominantly has 3 departments. So one is your accounts or deposits, whatever you want to call it. The second is the cards and the third is the loans department. Okay. And again, inside this, we can have multiple things like, you can have a savings, you could have FD, cards, you could have debit and credit. For loans, you could have maybe like gold loan, education loan, so on and so forth. So the work of architect now as part of your microservices design is to now ensure how are we going to create this microservices. So if you understand, if it was a monolithic application, everything would be kind of bundled into this one single bank application and delivered. But since this is going to be microservices, we have to kind of compose it or create different microservices for each functionality. So one aspect could be I could create one individual microservices for each of these departments separately. Okay, so I could have one independent SB like savings bank microservice, one for FD, one for debit card, one for credit card, so on and so forth. So that could be one approach. The second approach could be, or it's I could have one big microservice which would take care of all the 3 functionalities. Like it would take care of accounts, it would take care of cards, it could take care of loans. So what happens is if you just understand, see both of this approach, this is where the fallacy comes in. If you have too many microservices, then maintenance and management of your microservice is a concern because you really have too much fragmented microservice around. And similarly, if you have too less or very a single microservice handling multiple things, even here the problem is you then create kind of a monolithic architecture where everything is now bundled into one service. And if you have to change anything, then the entire microservice collapses. So this is a kind of a a fallacy which the architect will try to avoid. And in order to do that, in our case, what is the best approach is we can use the domain based microservice sizing approach. So what happens in that is, so let's assume that I am a bank. So this is my application and I have 3 departments, right? So I have accounts, I have cards, and I have loans, right? So based on the domain, what I can do is I can create high level microservices for each of these department. So I can have one independent microservices called accounts, right? Which will handle all account related work. Say for example, I could have account like microservice for handling SB, which is part of this accounts microservice. I could have a microservice for handling any FD related queries, which could be part of these accounts. And also I could have some administration kind of microservice. Maybe I want to do some reporting, I want to know what is the average balance, those kind of stuff. So that could be also be part of my accounts microservice. So what I have basically done is, based on the domain, I have created a microservice which is accounts. Similarly, I could create one separate microservice for card, and inside this I could now have multiple sub services. Like I could have functionality for debit card, I could have functionality for credit card, or maybe I could have a functionality for virtual cards. So all this would be bundled inside my cards microservice. And similarly, I could have a major microservice for loans, and inside this loan now I could have multiple section categories of functionalities. Like I could have a one sub-service for home loan, one for education loan, one for vehicle loan, so on and so forth, right? So this is how now I can kind of categorize my microservices, wherein I have a major microservice called accounts, inside which I can have the any functionalities associated with accounts. I could have a microservice which for cards, inside which I could have any subservice related to cards. And similarly, I could have one microservice for loans, inside which I could handle the functionalities for the loans department, right? So similarly, even if you take a e-commerce application. So in an e-commerce application, again, we can divide it based on the domain. So what I can do is, so if I have to just kind of logically divide it, right? So assume that, I'm maybe say I'm a retailer, okay? I sell maybe online clothes or apparels. So what I can do is I can create microservices based on the domain of it. So say for example, I could have one microservice which just deals with maybe shirts. I'm just giving a small example, right? And within this, I could have functionalities it could be maybe a cotton based shirt, or it could be something it's a formal shirt or it's a casual shirt, so on and so forth. Or for all this functionality, I could have different microservices which handles this. Similarly, I could have a microservice which just deals with, say, trousers. So within this trousers, again, I could have different functionalities like based on the material, or based on the style of it, so on and so forth, right? So similarly, I could have n number of microservices created, and assume that now I'm creating a microservice for a company like Amazon, right? So it deals with hell number of departments. So in those kind of scenarios, what I can do is I could also functionally define my microservice. So wherein I could create one microservice which will only do all the search related work. So this microservice could search for a product, it could maybe search for an order, it could maybe search for a customer, so on and so forth, right? And similarly, I could have one microservices which only does all the entries, the inventory stuff. So say for example, this microservice could give me the list of items which is there in the apparel section, which is there in the book section, so far and so forth. And similarly, I could have one microservices which only deals with the payment part. If it can take the payment from the customer, it can check for the existing payment, it can handle the refund, so on and so forth. So this is how I kind of divide my application into microservices. So the concept of microservices is that you ensure that you are not creating two tightly coupled microservices. Like you just have one microservice which does all the work. At the same time, it should not be like you're creating too many microservices, wherein you end up creating so many microservices that the management of microservices becomes a pain for you. So in order to summarize what we have learned so far, it is important. I will just say that if you have to create the sizing of the microservice, you just need to focus on two parts, right? So the first part is, based on what we have learned so far, you first create a context for your microservices. So what we mean by this, you start with a bounded context. So in general, the functionality in a microservices should not span more than one bounded context, right? So as we saw in the example of Amazon, or even in the example of bank. So when we create a account microservice, the account microservice should only deal anything related to account and nothing outside that. It should not get into loans or credit cards and all that stuff, right? And by definition, a bounded context marks the boundary of a particular domain model, right? So as I said, like if it's accounts or apparels, it should only talk about that, nothing outside it. And if you find that, a microservices mixes different domain models together, that's a sign that, you may need to go back and refine your domain analysis, right? So for example, you have a scenario wherein like, you are creating a microservice which is kind of like, having a little bits of accounts but also a little bits of cards. So that is the case like, where you may have to go back and refine the domain analysis. You have to create a boundary clearly stating that, which domain does this belong to. Is it account or is it a cards, or like, if there is any cross-cutting concerns, how to handle it. So don't worry, we also have a section where we'll be talking about the cross-cutting concerns down the line in the further weeks. So where you will get a flavor of how can we handle these kind of cross-cutting concerns, right? And the next part is like, to create or size your microservices, you just kind of aggregate your domain model, okay? So if you just visualize the tree that we created, right? So what aggregation means is, so if you take go back to the example that we saw. So what we saw is like, we have saving bank account and we have fixed deposits, which these are nothing but part of your accounts, and this is nothing but is a department in your bank, right? And similarly, you could have like something like a gold loan or a education loan, housing loan, vehicle loan. So all these functionalities are nothing but part of the home loan department. The loan department is nothing but again a major department of your bank. So what this aggregate domain helps us is like it is derived from various business requirement, and it's not anything that is related to the technical part of it, right? It is purely business related. So account is a business, loan is a business, right? So what the aggregate does is it kind of helps us to create a like, mind map or a tree which helps us to determine how each of these department helps in creation of your bank, right? And also like if there are any interdependencies. So there could be a case like, not in this case, but there could also be some interdependencies between different departments. So we can help to like, visualize all this thing when we create the aggregate domain. And also one more thing which you have to consider while creating a microservices is that not all microservices will only help you to create the business requirement. There could also be microservices which could be used for technical requirement or non-functional requirement. So say for example, from a business perspective, all they require is like, the user should be able to create the saving bank account, or like, should be able to get alerts when the saving bank account balance is below certain amount and so on and so forth. But you would be invariably creating microservices which would be helping you to achieve it. So say for example, I could have a microservice inside my account microservice which would be monitoring my account balance. So in case at any point of time my balance is say below 5,000 rupees, right? So what I can do is using this microservice, I could then directly trigger the alerts to this particular user stating that, my saving bank is like, getting below 5,000 rupees. Or I could have a microservices which could just be kind of like, monitoring the transactions in my account. If I feel there are too many transactions that is going on, I could probably like, raise a flag to RBI or my bank management stating that, this particular user is having too many transactions for the account. So all these are kind of the non-functional requirements, like, they are not technically the business requirement, but a few of them are also required for maybe like, the technical usages. So even those microservices we have to consider while creating the microservices boundary. And finally, before we just wrap up this week's session, I also want to like, quickly highlight you that, whenever you create any microservice, what are the criteria which you have to ensure that you satisfy. So this is kind of a guideline for you to ensure that, you are creating the right kind of microservices. Okay. So the first thing is ensure that, your service has only one responsibility. So say for example, if I create a microservice for accounts, like, fetching my accounts detail, then my service should only be able to fetch my account detail and nothing else. It should not give me details about my loan account, right? So that is the concept of one service, one responsibility. The second thing is keep the interaction between services as low as possible or without any interaction. So what it means is, if I have microservice say A and I have microservice say B, right? The interaction between them should be, ideally should not be there, but even if it is there, keep it very minimal. Okay. Why? Because if you keep it very tightly bound, like, say for example, you're calling microservice B inside microservice A to perform some operation, and you are tightly dependent on microservice B. So again, this kind of creates a dependency or a monolithic kind of architecture where both of these are tightly coupled with each other. Remember that, whenever you create microservices, they should be decoupled. This should be different and this should be different. Okay. And the next thing that you should keep in mind is, whenever you create a service, ensure that it is small in size, right? And it is independently creatable by a team. So what it means is, so if I create a microservice for say accounts and I create a microservice for say loans, I should be able to do both of this in parallel independently by two separate teams without any interdependency between them. So that is the concept. Okay. And always ensure that, whenever you are creating microservices, there should not be interdependencies such a way that both of them have to be deployed together, right? So say for example, I am creating microservice for account and you are creating microservice for loans. Your architecture should not be such that, whenever I am trying to deploy accounts, also I have to update or deploy the loans as well. So this interdependency should be avoided. And how it can be avoided is, if you kind of ensure you do this, so automatically this also is taken care of. So if you see that, all of these criteria are kind of interdependent. And the next thing is, always ensure that, your services can evolve independently. So this is also a related concept. So what we mean by that is, if I have a service A and a service B, both of this should be able to update independent of each other. So if say I create accounts microservice, and tomorrow now my bank is adding a new department for account, like a new type of account, maybe say mutual funds for example, then that should have no impact on the loans department even if they add a new type of loans, right? Both of this should be able to evolve independently. And the final criteria which we should be aware is, whenever you create any service boundary like between these two departments, like say accounts and loans, then the data which is being used to store these services, right, they should not have any issues with their consistency or integrity. Okay. Because sometimes it is important to maintain the data consistency by putting functionality into a single microservice, right? So what it means is, if I have my accounts database and I have my loans database, so since I am functionally separating accounts and loans, I should not have any issues maintaining the data of accounts or loans separately from one another just because I've created the microservice of them differently, right? So you have to ensure that any microservice you create also has ensures that the data which is stored in their respective databases are consistent across. They should not be conflicting or have any issues with one another. And with that, we have understood that what are the criteria for creating the microservices, right? So now let's quickly summarize what we have learned in this week. So in this week, we have learned about what is cloud native applications. We have understood the differences between the traditional and cloud native applications. Then we saw the 12 factors or the 12 plus 3 factors for building the cloud native applications. And finally, we saw the sizing and the identification of the boundaries for the microservices. So in short, it is also important that you create your microservices based on the domain that you are working on and try to rightly size your microservices from the scratch so that later you don't really have to go back and rework the entire architecture. So with that, we have reached the end of this week. Thank you. Hello everyone, and welcome to this third week of microservices using Java and Docker course. In this week, we'll be creating a bank application using microservices and get started with the world of microservices development. Let's quickly recap what we have learned so far in the previous week. So in the previous week, we have learned about cloud native application, the differences between the traditional and cloud native application, the 12 factors for building cloud native application, and finally, we also saw the sizing and identification of boundaries for the microservices. So in this week, let's understand what are the things we are going to learn. So the first, we will be understanding the overview of banking application. Next, we will create the microservices for the accounts department. Next, we will create the microservices for credits and credit and debit card, or in short we can say for cards department. And finally, we'll be creating the microservices for the loans department. So the learning objective of this week is we are going to learn about how application requirements are given and how can we develop architecture of the microservices from it. And finally, we'll be understanding how to create microservices for our banking application. So now let's understand the overview of the banking application. So let's now assume that you have been approached by a bank and you have been asked to create a simple banking application for them, and let's try to understand how we can do it by using microservices and Spring. So in this case, let's assume that the bank requires us to create an application for their customers to enable online banking services, and the following are the major departments of the functions of the bank. So the first we have the deposit account department, we have the card departments, and we have the loan departments. So first we need to understand and create the architecture of our application that depicts what function each department will perform and the interaction between them, if any. And also it is important for us to determine the number of services required for each functions and how to organize the services. So now let's quickly jump into the demo of how we can create the architecture of a banking application. So as we discussed earlier in the previous week as well, so in this case as well, we are going to go with the same approach. So let's try to understand what are the various things that our bank requires. So as per the requirement given by the bank, they have 3 departments. So one is your accounts, the second is your cards, and the third is your loans. And internally this again have multiple things, it could have a savings, it could have a FD, so on and so forth. This could have a credit, this could have a debit, so on and so forth. And loans also, you could have house loan, you could have education loan, so on and so forth, right? So the first thing that we have to understand is, we have to first, as we discussed earlier, we need to understand the domain of the application which we are building, and we have to isolate the microservices based on the domain and functionality. So in this case, if you just logically think about it, since our bank is having 3 departments for the simplicity's sake, so we can kind of artificially or divide the boundaries on this aspect. So wherein we can say that the accounts can be one microservice, cards can be one microservice, and loans can be one microservice. And within this accounts, we can have further functionalities where there could be a service exposed for the saving bank, there could be a service exposed for FD, there could be a service based in the cards microservice for credit, debit, so on and so forth. So logically, what would happen is, when we develop our microservices for this banking application, we would have one application or one container for accounts, we would have one container or one microservice for cards, and we would have one container or one application for loans. Each of these would be deployed independently. So say maybe in our local host, we could deploy this in 8080. This we could deploy in 8081, and this we could deploy in 8082. So all these 3 departments or 3 applications would be independently hosted on different ports, right? As we saw earlier, that each microservice has to be hosted to a port. And then internally we could then have different many services which could be giving us different functionalities, right? So this is how we go about creating the architecture of our application. So just to recap, it is important for us that we rightly size our application, our microservices, and also identify the proper boundaries, because without that we either risk creating too many microservices, or we risk creating a single monolithic or minimal monolithic microservices combining too many features. So it is very important that whatever microservices you create, they are able to do only one functionality at a time. That is that they should be only be created for one functionality, and they should be able to do it well independent of the other departments. So here if you see, the accounts has minimal to no interaction with card department, the card has minimal to no interaction with the loans department. And again, we can have our own independent database for each of these microservices, and we can independently use them. Okay. So in the ideal world, obviously you would have different departments as well, but for the sake of simplicity in this course, we are just only concerned with the 3 departments. So I hope it is clear till now. So what will happen in an ideal world is you will have a banking website. So say let's name our bank bank.in. So this is the website of a bank. Okay. So what will happen is this bank.in would have a website where you would have links for maybe accounts, cards, loans, so on and so forth. And when the user clicks on this account, then from the backend, this account's microservices is called, and based on whatever is there in the database, that is like fetched and showed on the UI. Similarly, when the user clicks on card, you would kind of click on the invoke the card microservice API, get the data from the database and show it on the UI. Similarly, when you have loans, you kind of call the loans microservice, fetch the data from the database, and you kind of show it back on the UI. And this is how it will be happening in the real world. So on demand, based on the the functionality access, that particular microservice is called and the data is shown on the UI. So if you see from an architectural perspective, ideally it can be like we have a single UI, okay, and that single UI is in turn calling individual microservices. So we would have the API or the microservices which then interacts with the database, right? So we have the card API or the microservice which interacts with the database. We have this which interacts with the database. So this is for the accounts, this is for cards, and this is for loans. So this is how ideally a architecture for microservices would be created in a real world, and we also would have something called a backing services created over here or managed services. So what that will do is, so it can be called as backing or managed services. So this will be kind of a cross-cutting concern, which would be kind of handling all your logging, analytics, shared data, all that kind of things would be handled by this backing services. So this is one way of creating the entire application architecture. The second way of creating the architecture would be that you just have kind of one website, but the UI for this website itself is kind of part of the microservice architecture. So what happens is, when I have an accounts microservice, I would have the UI developed for it, I would have the API for it, I would have the DB for it. So what happens is, in my website, dynamically when I load my website, so say for example the central part is my accounts page. So dynamically this UI will get embedded over here, and internally it will be calling the API and DB of this particular microservice. So similarly, when I have I go and access the cards department, so the UI for the cards will be loaded, which in turn will be talking with the API and the database of that particular microservice. So similarly, if I have something like loans, so here also my UI will be loaded on the go, followed by the API and followed by the database. So this is how kind of this is another way of creating the microservice architecture, wherein even the UI is part of the UI is independently created for each department and then loaded on the website. Okay. So the advantage of here is that even the UI is kind of decoupled from the main application and we'll just load it on demand. But this is easier said than done. The complexity of creating separate micro front-end UI is also kind of a bit challenging in the real world. So generally what the application tend to do is what we saw earlier, that the website is common, and internally we just have a common UI, and internally you kind of call the different microservices to invoke the different functionality that you want, and each of these would be talking to its different databases, right? So this is what we follow. And before we go any further, it's also important to understand that what we are going to do in this course. As I said earlier, we are not going to focus on the UI part for now, because that itself is a different course altogether. But what we will do, however, is in the week 30, we will create a simple UI using Spring MVC concepts and Spring Boot. So just to let you know how we can also create UI on the Spring framework. But the core focus of us is going to be on the API part, and database, though we are going to use for simple kind of CRUD operations, where we will be creating, reading, updating and deleting information. but the major focus of us is going to be on creating the APIs. Okay, so that's the reason you'll see that we are not going to focus much on UI and much on the database. Okay, so even in the real world, when you create microservices or like you are going to become a Java developer, the core stress initially during your learning phase will be on the API part. And once you have mastered the API part, then would you be getting into the database and the UI part to become a full stack engineer. So with that said, so I hope the concept is clear that what we are going to do basically now is in this week is we are going to create 3 different microservices for our banking application. So first we will create the account microservice. The second we'll create is the cards microservice. And the third we'll create is the loans microservice. And all we are going to create is the API for this, right? So wherein once we give it a certain request, it will give us a certain response, right? And in order for us to create these services, we are going to also use a sample database. So in our case, we are going to use the H2 sample database, which is provided by the Spring itself. So what is the advantage of H2 is it is an in-memory database, which also gives you certain automations, like it can create certain test data when you start your server and all that stuff. So there's very minimal setup required. So why we are using H2 database instead of a traditional MySQL or NoSQL or other databases? Because we want to reduce our time in setting up all these databases and associated work with it. So because, as I said, our focus is not on the database part, but it's rather on understanding how we create the API. So for that perspective, we are going to use with H2 database. But remember that H2 database is an in-memory database, meaning that when you stop your server or restart your application, all the data that you had used during your application will get lost. So that's the reason usually H2 is not used in the production setup, and normally we go for SQL kind of databases. But however, the concept is same. So like once you understand how we are doing things with H2, it is also easier to do it with SQL as well. So the focus is like on this week, we are just going to, as I said, we are going to create the API, and we will be trying to understand how we can use the Spring framework, or specifically the Spring Boot along with Spring JPA, in order to like create APIs which will be interacting with the database. So what we will do is we will perform a simple CRUD operations on the database. So wherein the concept is we will have certain data in the database, and that data we'll try to read from the API when we try to pass it some parameters. So this is what we are going to do in this week. So with that said, now let's get started with the creation of the accounts microservices in the next session. Thank you. Hello all, and welcome back to the second session of the third week of microservices using Java and Docker course. So in this section, we will be now creating the microservices for the accounts. So at the most basic level, the accounts department is expected to keep the client information such as name, customer ID, account type, balance. So this is kind of just for the sake of simplicity, we are just taking the minimal data that is required. And the microservices can be created for accounts using the Spring Boot, and then they can be connected to an H2 database. So as we saw in the previous session, that we are going to use the Spring Boot and Spring Framework for creation of our microservices. And for the database operations, we are going to use the H2 database, which is an in-memory database provided by the Spring Framework itself. But however, remember that you should not be using H2 in a production environment. So it's only for the test purpose we are using a H2 database. But just also remember that whether it's H2 or SQL, the code is going to remain the same, because since Spring internally uses JPA, Java Persistence API. So what happens is irrespective of the database that is used in the backend, the code remains the same, and the Spring framework will be dynamically updating the the connection details and doing the transformation as required based on the database that is given. And finally, we'll also perform a simple CRUD operations as well on our H2 database. So now let's get started and create the microservices for the account. So in order to create the microservices, as we saw in the first week, we have to go to the Spring Initializer website. The website for that is start.spring.io. So we go to this. As we saw earlier, just keep the default to Maven. That is fine. Just keep the Spring Boot to whatever is the default selected option. So in our case, at the time of recording, it is 2.7.2. And even if it is a higher version, when you are recording like maybe 2.8 or 2.9, you can go ahead and select it. and the language is going to be Java since you're going to work with the Java. And now in the project metadata, here is we are going to give the details of our application. So in our case, assume that the bank website which we are going to create is maybe like www.bank.in. So the group name of this project should be the opposite or the inverse of that. So in our case, it will be in.bank. Okay, so this is the group name. So group name you can say is kind of the topmost hierarchy of our project, right? So all the microservices in this course will be having the group name of in.bank. Okay. The next is the artifact name. So the artifact name will define the high level, the name of your project which you're creating, the artifact which you're creating. So in our case, it is accounts. So we'll give it as accounts, and the name of the project can also be accounts. That is fine. And in the description, you can just put it as account microservices, and the package name will automatically be populated as in.bank.accounts, right? So this is the thing you have to give. The packaging will be jar, and Java, you can choose the version as 11. And in the dependencies, this is important. So since now, if you remember the earlier week, we added Spring Web. So that was added by default because this is required for us to create any modern Spring application. So Spring Web will come by default. And after this, we will also require a few other dependencies. So the first dependency that we require is the H2 database. So what is the H2 database? This is going to be the in-memory database which we are going to use for storing our data. And since we are going to use our data right now, we also need two more dependencies. So the first dependency would be the Spring Data JPA. So what this JPA, the Spring Data JPA does is, it will persist the data in the SQL store using the Java Persistence API. So what happens is internally it will use an ORM called Hibernate. So you don't really have to write SQL queries in order to fetch and write the data. So all you need to do is just invoke a few methods, and automatically the SQL commands will get generated and your data will be manipulated. And also we would require something called as Lombok. So what is this Lombok is nothing but it just helps us to reduce the boilerplate code or writing excessive code. So what happens is, say for example, you want to fetch maybe some ID or some value from the table. So you don't really have to write a lot of getters and setters. So in order to reduce those things, we are going to use the project Lombok, right? The Lombok dependency. And apart from that, these are the minimal dependencies which we require in order to start our application. But there are also a few other dependencies which you may also add. So for example, we have something called as the actuator. So what is the actuator is it is just going to help you to kind of monitor the application. So as we said earlier, so one of the trait of developing a cloud native application is that we should also be observable or monitorable. So how we can do that in Spring is actually by using this dependency called Spring Boot Actuator. So what it does is it will kind of give you a real-time report of how your application health is, what are the sessions that is active, so on and so forth. So these are the dependencies which we require. And now once you have selected all this, you just click on generate. You'll see here that the accounts.zip is generated. So you just click on here and show and just open the folder and just unzip this file for now. So once you have unzipped the accounts.zip file folder, so you'll see a folder like this called accounts. So what you need to do next is open the Eclipse. So we have already installed the Eclipse ID and other stuff in our first week. So you just need to kind of open the same Eclipse, and what we did in the first week is what we are going to do right now, and slowly build our application. So now what we'll do is, you can see that we already had the demo created last time. So we don't require the demo project right now. So all you can do is just right click on this demo folder if it is open for you. If not, it is fine. Just click on delete. Just ensure you don't check on this checkbox, because if you check on this, it will get deleted from hard disk as well. We just want to remove it from here. So you just give OK. And that will just remove the project from here. Now, in order to add these accounts into our Eclipse, we are going to follow the same concept. So you just go to File, go to Imports, or you can directly click on Import Project over here. Come to Maven over here, click on Existing Maven Project, click Next. Next, in this Browse button, click over here. And now what you do is just go to the Downloads folder, go to this Accounts folder where your accounts got unzipped. So just give select folder, then automatically you'll see this pom.xml selected over here. So this pom.xml is nothing but it just has the details about your project and what are the dependencies installed. And now when you click on finish, so automatically on the right hand bottom side you'll see that importing, you'll see a message called importing Maven projects and it will be running. So wait till this importing is completed. So only after that you'll be able to use our project. So meanwhile, what you can do is you can just click on this accounts. You'll see that, there's a src main java in bank accounts and accounts application.java. So if you click on this, you'll see that, automatically this @Spring Boot application annotation is present as we saw in the first week. So this tells the Java project that this is the main class of our class file of our application, and the Spring Boot application will scan all other entities from here. Okay, so that's pretty much it. So you see that it's quite easy for us to create the application from the startup project. And if you now just click on the POM XML, you'll see that whatever dependencies we had selected, those are added. So here if you see, we have this startup boot starter actuator, then we have the data JPA, we have the starter web, we have the S2 database, project Lombok, and starter test. So test is nothing but the testing framework which gets automatically added by the Spring. So yeah, that's pretty much it about the project. So we'll just wait for a couple of minutes for this importing to get over. So once the importing is done, we can start with our project. So now you see that the status is changed from importing to download sources and Java doc. So now actually what it will do is it will download all the dependencies. So you'll see over here that a folder is created called Maven dependencies. So whatever is the dependencies of our project, everything will get downloaded right now. So that is the beauty of Spring, right? We don't manually have to give each and every dependencies. So internally, based on the dependencies of each of these projects, so the Maven will automatically kind of download it everything in the background. So we'll just wait for a couple of minutes for this to get over. So now you see that all the Maven dependencies are installed. And before we proceed, there's only a one-time activity which we have to do, that is installing the Lombok jar into our Eclipse. So this is just a one-time activity which we'll do. We'll understand why we use Lombok again when coding, but just follow along and do it with me. So for this, what you need to do is go to your Windows Explorer and come to your C drive. So in the C drive, go to Users. Inside users, click on your username. So whatever is the current user which is accessing your computer. So here what you need to do is just go, there will be a folder called .m2. So just click on this .m2. Then go into repository. Then click on org. Then click on project Lombok. You'll see over here. Then click on Lombok. Click on this version. Even this version is slightly different, that is fine. Just click on this version folder. And inside here, you will have a file called as lombok1.18.24.jar. Okay. So you don't need to do anything over here. Just go back to this Windows Explorer address bar at the top and copy this path. Okay. So this is step number 1. Step number 2 is, just the way you came into the .m2 directory inside your user folder, there is another directory called as .p2 folder. So what you need to do is, you just go to this folder path, which is .p2. Inside p2 pool plugins org eclipse, just open JDK and come to JRE bin. So I'll just redo that step for you. So come to my computer, go to C drive. Come to your user folder, click on the username for which who is currently using the computer. Then go to this P2 folder. Inside P2 folder, there is something called as repository. sorry. So inside the P2 folder, there's something called as core. Sorry. So inside the P2 folder, there is a folder called pool. So inside pool, you have something called as plugins. Go inside plugins and you'll see a folder called as org.eclipse justj.openjdk hotspot jre. So this folder, just click on that and now click on this jre. Now click on this bin folder. So you'll get something like this. So this is the path where your Java is installed right now. Okay. So what you do is right click over here, or what you can do rather is just like, go to the command prompt. Okay. The command prompt will open like this. Copy this address bar over here for the Java JRE bin which you have opened right now. Go back to the command prompt, just give cd space and paste that path, press enter. Now you will be coming into this OpenJDK path already. Okay. So now what you need to do is just type dot slash Java. So you can also use autocomplete. So you can just use java.exe, just type that space hyphen jar. Okay, space. Now we have to paste the path of the Lombok jar which we had copied in the previous example. So what you'll do is come back to the window where you had opened this .m2 repository path. So this path is simple. Under your user folder, you will have something called m2. Inside that repository, inside that org, inside that project Lombok and the version number. So just copy this, come back here, paste it, and after this, now you have to give the Lombok jar. So what you need to type is just type Lombok, and automatically this lombok.jar will come when you autocomplete, right? Just press tab key. So just after you do that, press enter. So it will open a window for you like this, which will say Lombok works out of the box with Java C, and it will automatically have the Eclipse installation folder here for you. So all you need to do is click on this install, and here it will then say install successful. That's it. So now you are done installing the Lombok jar in your Eclipse. So this is just a one-time activity. You don't kind of need to do it again and again. And once you have done this, the next step you have to do is right click on this accounts over here. This accounts folder that you see over here in your Eclipse, right click on that, go to Maven, and here in the Maven, you will see something called as update project. Click on that, and here there'll be an option called clean project. Ensure it is checked. So ensure that all these three, the bottom three options are checked. Okay, and then you give OK. So you see at the bottom the update has started. So what this basically does is it since you have installed the Lombok after the Eclipse has started, so it is basically recommended that we just clean the Maven dependencies and reinstall it. So that way what happens is all the latest packages will be installed. So now it is done. So we are good to start our coding and get the account set up. So the first thing that we'll do is if you just open the src main Java in-bank account and accounts application.java. So as I said, this is the main class path of our application. Sorry, the main class of our application. And here you will see that this is having the Spring Boot application. So now you can see that if you open the accounts application.java, which is the part of in-bank accounts package inside your src main folder of accounts, you see that we have this Spring Boot annotation and the basic main class setup. So first we'll start with this, and we'll just update the application. So there are a few annotations which you have to add here. So we'll also see what they do as we type it. So just come to this line over here, Spring Boot application, and press enter. So the first package that we'll add is component scans. And inside that, again, we'll add another annotation called component scan. So just see the difference. One is scans and other is scan. So what this does, we just see it in a minute. First, let's just complete the typing. So inside this component scan annotation at the end, put a package name. So here we have to give a package name, controller name. So what we'll do is, here we have to specify the controller with which we have to be, the components have to be scanned. So remember in the first week we created a REST controller where we just had all the API mapping done. So similarly here we have to do the same. And how to create the controller is, first we'll type the name and then we'll come back and create the controller. So in our case, as I said, everything will start with the same name, that is in.bank.accounts. So this is going to be common for all. And here we are saying you scan for the controllers. Okay. So the controller is not yet created. And also remember that whenever you create any annotations, you have to import the corresponding packages. So here, if you just click on here, you will get an option called import component scan. Click on that. So that is first thing. So how to create the controller is, always remember that whenever we create any new parts of our application, it's better that we create a package first for that and then add it inside it. So the first step is just go to this src main Java over here, right click on that, click on new, then click on package. Over here now we have to give the package name, so it will be the same, in.bank.accounts.controller. So here we are going to create the REST controller, right? Just give finish. So you'll see over here that this has been created like in.bank.accounts. So now what we do is just right click on this controller that we created and create a new class inside it, right? So the name of this class is going to be accounts controller, and just give finish. So now this has been created as a package, right? So that is step 1. So that is the reason why we had this component scan over here. There was a slight typo. Replace the round bracket with the curly braces over here, and after that you'll see the error that component scan is not imported. So just click on this red mark and give import. So now this error will be resolved. The next annotation which we have to add is enable JPA repositories. So again here you have to give the name of the repository which we are going to create. So in our case it will be the same nomenclature, in.accounts.repository. Okay. Now this repository package is not yet created. So first we'll create that, and before that, to just resolve this error, we'll just import this enable GPA repository, and that error will be gone. How to create the repository is, you just the same thing, src main Java, right click, new, package. So here just give the name as in.bank.accounts.repository. So what is this repository is? So this is going to be the file or the package that is going to have the methods which is going to fetch the data from your GPA entities. Okay. So what is this? You'll see it in action when everything is ready. For now, just play along with me. So what we'll do right now is, inside this repository package which we created, I also see that there's an extra package called bank accounts created. This is not required. So we can just go and delete it if this shows in your project. Yeah. So in this repository, what we can do is just go to new, go to class, and give the name as account repository. Give finish, and that's it. So this has now enabled, we have enabled the JPA repository, And finally, we also have to do an entity scan. And why we have to do entity scanners? Since this JPA repository is going to use the JPA entities for kind of storing and transforming your data. So that's the reason we have to enable entity scan. So the annotation for that is @entity scan. And here we are going to scan the models which are going to use for this JPA entities. So in our case, it's going to be in.bank.accounts.model. So this model is nothing but it's going to have the structure of our database which we are going to create, right? So again, just go over here on this red mark and click on it, click import, and this entity scan will now be imported. So this is step number 1, where we have added the requisite annotation. And since we are going to have this model, we also have to create a package for this model. So the same concept, right click on the Java, new, package, in dot. Always remember that, any package that you create for your account following the Java naming convention, it's going to have the same name, package name, starting name as the other packages. So this in.bank.accounts is going to be common. And now, since you're going to create it for model, we'll be appending the name .model. So once you complete that, you'll see a model is created. Now inside this package, right click, go to new, go to class, and here just give the name as accounts. So basically for our project or our microservices, we are going to create 2 tables. So one table will have all the details of the accounts with that particular department, and the second table is going to have the customer information. Okay, so we'll have 2 classes over here. So one we have created for accounts. So again, just click on this models package again, go to new, go to class, and now give the name as customers. Okay, so just understand this. From a database perspective, we require 2 databases. So one database will have the detail of all the accounts which is maintained in that by that department, and second database will have the data of all the customers who are holding the account. Okay, so that's why we have 2 database. So that's why we require 2 models over here. So I hope this is clear till here. So the next thing that we are going to do right now is we'll first quickly create this accounts model, right? We'll first try to understand how this account model look like. So what we'll do is just above this accounts public class, we are going to add a few annotations of Spring. So the first is we'll give the entity. So what is entity? As I said, so this is going to be the Java persistence entity that is like, going to ensure that, you just create the database objects as a POJO, and internally the Spring JPA using Hibernate will be kind of like, converting it into actual SQL queries. Okay, so this is first. And the second is, this is where the beauty of Lombok comes into play. We'll give getter, setter, and toString. Okay, so all these 3 annotations are coming from Lombok. So just import all of these together. Just click on this error, import getter, import setter, and import toString. Yeah. So what this basically does is, whenever we want to get any data or set any data value, we don't have to define all that method manually. Instead, Lombok will directly do that based on the method name we pass. So we'll see it in action in some time. And this toString will help us to ensure that whatever data we are getting from the database, it is converted into a string. Okay. So with that said, now let's quickly define our accounts database model. Okay. So the way we do it in this Spring is quite simple. So first we will define the column name that is going to be present in the database. So we will say @column. So this means that it is going to define the column. So here we would say name equals to. So say the first column that we want to create is the customer ID. Okay. So which is mapping which customer belongs to which ID, which accounts belong to which ID. So just import this @column. So just click on this error over here. And once you have defined this @column, now you define the corresponding POJO value, right? So here you'll just give it as private. The type is going to be an integer, so it's going to be int, since customer ID is normally integer. And now you define the key name. So here in our case, it's going to be customer type, so customer ID. So once you have clicked and imported this column and added this private int, now these two are bound together. So what happens is, internally, since this is an JPA entity, you have defined an internal key value called customer ID, which will be mapped to this customer-ID of the database. And whenever you want to get any data or set any data, this logbok will do for you automatically based on the name you pass to it. How this happens also we will see. So this is the first the table column which we have mapped. The second similarly could be the account number. So the same concept, what I'll do is I'll just quickly type @column name equals to account type. So in the table, normally we don't use hyphen or camel case, we just use the underscore. So that's why I've given account underscore type. And here we'll just define it as private. And account number is also, like, account type is usually string. So we'll just give the type of this string, a variable as string. And here we'll give the name. So once you do that, this has defined the bindings for this column to this particular value. The next, once we have the account type, we can also have maybe the branch, right? So what we can do is @column name, then branch is again going to be the string value, so branch. And after branch, probably you could also have something like the created date, when this account got created. So you could have something like column. And since this is going to be a date format, we are going to use the local date type and give the name as created date. And since this local date is not imported, just click on this error over here and give import date. So automatically that error will be resolved. So this is step number 1, where we have defined the POJO of the accounts entity, and internally the Spring will now take care of mapping it from the database and also while writing it back to the database. So this is step 1. Step 2, for the customers.java file. So similarly, we are now going to define the model for the customers database. So for the customers database, similarly like what we did in the previous account, the same way we are going to define it over here. So here what we'll do is, so we'll start with column annotation. So the name, so every customer will have a ID, so we'll put it as customer ID. And this is going to be of an integer variable, so we give it as private int. And since this is a POJO, we are just giving it as customer ID. And now just import this column, and that's it. And one more important concept to know is, you may also have this concept of primary key in database, right? Where you say that this particular column is going to have unique values across all customers. Say for example like ID, no two customers will have the same ID. So in order to denote that which column is a primary key, you can have something called as the @ID annotation. So what @ID annotation does is, it says that this particular column is a primary key. And when you have that, when you define a primary key, you also have to give a annotation called as generated value. And inside this, you give the strategy. Where we say generation type dot auto. So what this basically is like, since this is going to be a primary key, right? So just before we proceed, just click on this and just import this. So whenever you see an error, just click on this error icon before the line number and click on it, import. Automatically that imports that particular package for you, and this error gets resolved. So what the generated value basically does is, so it is the kind of annotation which is applied to this primary key. So if you just hover over the generated value, you'll see this message over here, right? So it says that, we use the generated value only for simple primary keys, where if the values is not there, it will kind of generate some auto values and put it. Okay. So here, that's why we are given the strategy as auto. Okay. So this was about the customer ID column. So the next column which we want is, since this is going to be a customer table, we want to have the name of the customer. So just to save some time, I'll just copy the same line, paste it again, and now I'll just make the quick changes. So here I would say name. Here I would set the type as string, because the customer name is going to be of string, and here I will set it as name. That's it. So now we have defined name. So similarly, what I'll do is, I will also probably define maybe another data, like a customer can also have like mobile number. So I can define mobile, or maybe just to make it descriptive, I can give it as mobile number. And a mobile number is always an integer, so I'll give it as int. If you're going to have international ISD plus and all that, safer side, you can also give it as string as well. So that is up to you. And similarly, we can also have an email ID for our customer. So what I'll do is, I'll just copy paste the same thing. Email ID. As this email ID is also going to be a string, I have just kept the type as string. And finally, what we can do is, we can also have a created date, like when this customer got added into our system. So for that, the same thing. The column name is created date, and here the Pojo value is created date. And since this is going to be a date, the string is going to be converted into a local date. So you'll get the error. Click on this icon over here and click on local date. That's it. So now you see the error is gone. Save this file. So just to summarize what we have done so far, inside the model file, we have created the Pojo representation of the data or the model which you are going to use. So since we are using JPA, the Java Persistence API, so what happens is, internally the Spring will be converting all this into the corresponding SQL queries and giving us the response. And similarly, since we are using Lombok, what happens is, we don't require to set or create the separate getter setters for each of these column values. So automatically, when you invoke that method name with the column value, automatically that gets invoked. Okay. So for our customers, we have the column as customer ID, name, mobile number, email, and created date. And similarly for accounts, we have customer ID, account type, branch, and created date. So with that, now we have created the model. So once we have created the model, it's time for us to get into the repository and also create the corresponding repository for our model. So what we'll do is, just open the account repository.java file. So, and at just above this public class line, press enter, and you have to decorate it with the entity of repository. And in order to import the package, just click on this error that you see here on this line number 3 and click on this repository. And once you do that, hover over the repository and you'll see what is the use of it. So it indicates that, this is kind of like, the mechanism to encapsulate the storage retrieval and search behavior. So in simple words, what it means is, This allows you to kind of encapsulate or abstract the actual storage, the CRUD operations that happens on a database. CRUD stands for CRUD, create, replace, update and delete. So whenever you have to create any of those operations, you don't actually have to write the lot of the SQL statements, but rather you can just write simple methods which in turns will automatically be converted by Lombok into the corresponding getters and setters. Okay. So now what we will do is, inside this repository now, we will just kind of slightly manipulate this file now and make it into a interface. So instead of class, we'll make it an interface, and now we will extend this interface to use the CRUD repository dot account. Okay, so we'll just write CRUD repository, and inside this first we'll define the database or the model which we are going to use, which is accounts, and what is the data type. So this is going to be a long, and now there's a typo over here, it's extends. Yeah, and so you see that this error over here is not yet kind of resolved. So what we need to do over here is, so just come back to this line number 3 that has added this import statement for repository, and over here just give it as dot CRUD repository. You see that this error over here is coming, that it is telling that this error is there. So what you need to do is just click on this, first import the CRUD repository, and after that again click on this. You'll see that now it tells to import the accounts. Do that, and that you are done, right? So what we have basically done is, we have extended this CRUD repository, which gives us a generic CRUD representation, and on that we have now imported the accounts model which we have created, and the type of this is long class, which kind of wraps the primitive value of this to long data type. So inside this we just create a simple method. So we'll say accounts, so that is the name of the model, accounts, and we say find by customer ID. Okay, and here the parameter which we are going to pass is the customer ID. So let's quickly understand what we have done. So we have just basically created a method wherein, when on passing it any customer ID, we want it to search the database with that customer ID and return us the value. So I hope now you understand what is the benefit of using Lombok and Spring JPM. We are not writing any SQL statements by hand. If this was a traditional JavaScript application, we have to write a traditional SQL statement like select star from the table name where customer ID is equal to XYZ. But here all we are telling is just defining the method name, and since in the method name we have this by customer ID, so the Lombok will automatically internally go to this customer.java and set a getter here, where it will automatically fetch the customer ID which is matching the particular input and return us. So that is the advantage of using Lombok, where you are avoiding the creation of multiple getters and setters and complicating your code. So this was it. So far we have created all the basic setup, and before we proceed, finally we also have to do a few setup on the application properties and data.sql file. So for that, what we need to do is, just need to close this src main java folder on the top over here and come to the resources folder over here. You'll see that there's a file called application.properties. So over here we have to define a few properties. So by default these properties are pre-configured, but just for your understanding I'm just doing it again. So the first property is spring dot data source dot URL, and over here we define the the JDBC address for our S2 database. So in our case it's going to be JDBC :S2 : mem test database, test DB. So this is a default H2 database URL which we are going to use. The second is we have to define the driver class name. Since we are using the H2 driver, so we have to give the H2 driver name. So spring dot driver class name, and for this it's going to be org.h2.driver with a capital D. The next we have to give the user ID and password for this H2 database. So you can define your own user ID and password as well, that is fine. So it is going to be spring dot data source dot username. So in our case we'll just keep it simple. We would just give it like say admin, and password we'll just give it as say maybe password, just for the simplicity. Okay, or you can also give it as pass. Okay, so this is the user ID and password which is required to access our database. And after that we have to give a few JPA related configuration. So we'll say spring dot JPA dot database platform org dot hibernate, because JPA internally uses hibernate for writing the SQL queries. So we give this hibernate dialect dot h2 dialect, and next we have to give spring dot JPA dot defer data source initialization equals to true. So what this basically does is till your Spring is totally initialized, the data source will not be initialized. So your S2 data source will not get activated till all your Spring JP and everything has been initialized. So the advantage of that is that case our S2 database table and everything will be ready. The final thing is we also can have just enable the S2 console so that we get some nice commands like nice console logging. So we can just give spring dot h2 dot maybe console dot enabled equals to true. And since we are going to create multiple microservices, so now for this service we can have it to be running at the port 8080. Okay, save it. So we'll just quickly recap what we have done so far. So we are telling Spring, first we are telling the Spring that our data source URL is this, then our driver is this, then the username and password to connect to our database is this, and since we are going to use the Hibernate JPA which internally uses Hibernate, we are telling it to follow the H2 Hibernate strategies. And since we are using H2 database, we are telling Spring to defer the data source initialization till the application is totally up and running. And finally we have enabled the console for S2 so that in console we get the S2 related message, and the port is 8080. So one more beauty of Spring is irrespective of the database you use. So in this case, instead of S2 you are using SQL, our code is not going to change. All you are going to change is this 5 lines, right? So instead of this S2, if you are using SQL or any other database which you are going to connect, you will just change the property values according to that, and the rest of the code is going to remain as it is. So that is the beauty of using this Spring JPA. So with that being said, we are now ready. So most of the setup which is required is ready. The final thing that we need to do is, since I told you that H2 is an in-memory database and it we need to have some data whenever the data is lost whenever the application is restarted. So in order to have some test data when the application started, the H2 database provides us with a utility called data.sql. So what it does is it automatically adds certain value data to the databases whenever the application starts. So the advantage of that is you don't always start with an empty database, but you can also have some test data running when the application is started. So in order to create that data.sql file, just come to the SRC main resources, right click on this, go to new, click on a SQL file, and here just give the name as data. and give finish. So now you'll see that inside SRC main resources, you have this, you made a typo, just let me rename it. It should be like data.sql. No other name is allowed because this is the default file which S2 uses in order to create the data. So now in this, what we'll do is we'll just add a few SQL queries. So this is purely an optional step. Why we are doing it is because since our database data will be wiped whenever the application is restarted. So we are just adding a few SQL queries to ensure that our data has some table if whenever the application restarts. So the first thing that we'll do is we'll just do drop table. So drop table basically means that we are going to delete the table if it exists. So this is just as a optional step. So we'll say drop table if exists customer and drop table if exists accounts. So first we'll drop the table. And second, now we'll create a table. So we'll say create. So these are all basic SQL commands. So here we'll give the name of all the columns that we have created. So in our case, it is customer ID, int, and instead of manually adding 1 we can just give it as auto increment, and it is also a primary key. And why we are giving auto increment is since it's a primary key, every new row can automatically just add the number to the previous row and it can get the new ID. The next is name. So we can just go quickly to this customer model to see what are the table column names which we have given. Right. So the second name is name, mobile number, email ID, and created date. So I will do is I'll create name. Name, I'll just give it a varchar of maybe 100 letters. So, and we'll just add it a condition that it should not be null, because normally name is never null for any customer. So this type over here. And similarly, we can also have, I'll just copy the same thing, put it over here. So the email or mobile number. So for mobile number, if you see in the customer's model, here we are giving it as string. So here also we'll keep it the same. So we'll say the varchar, but we know that mobile maximum letters is 10, or maybe even if you add international ISD and plus, it should not be more than 13, right? And again, this will not be null. Why we are saying not null? Because these are kind of the mandatory fields which the customer has to, like the customer account has to hold. The next is email ID. So ensure that you're using the same column name which you are given over here. That's why I'm referring both the files parallelly. So email ID, again, it's going to be varchar. Just keep it 100 for safe side and not null. And finally is created date. So let's come back, put this created date, and the data type is going to be date, and this by default you can have null, that is fine. So this is just for demo purpose, I'm keeping it as null. Okay, so what we have done is we have basically just created a table. So whenever the application starts, it will first create this table. So similarly, just like similar to account customer table, we can also create an accounts table. So what I'll do is I'll just copy paste the same information and quickly just kind of change the things. So in the accounts, you'll see that we have customer ID. So here we have given customer ID. But here the primary key is not required because the customer ID is coming from the customer ID table. So this primary key is not required over here. We can give it rather like of the type integer, and this should be not null. The next is account number. So if you see in the accounts.java, so it is account type. Actually, we can also have another column over here called as account number. So logically, if you see, every account has a number as well. So what we can do is in the accounts.java file in the model, we can also have a account number model created. So what we can do is just go back here and add a account number as well. So coming back to the data.sql file, you can now have this as account number. This can be also be an integer. So just make it a integer, and account number is always unique. So you can make it as a primary key, and also you can auto increment it because normally that's how account numbers are generated, right? So you can just auto increment it and keep it as primary key. The next column that we have is account type. So account type, we can have maybe the maximum characters as 100, and it is important that it's also not null. The next we had was the branch. If you see over here, so branch and created it. So the next is branch column. Branch is again varchar 100, and this is fine. And finally for created date, it is same. So now we have added the columns for both the tables, right? So the next is very simple work. We just need to add some test data into our database table, so just to ensure that whenever we make some query, we are able to get the data. So the simple insert command is insert into first we'll enter for customers. So insert into customer, and now we'll give all the values. So first we'll give name. So here first you have to enter all the column values. So we'll give name, so just ensure that for the column names it's the tilde character which you find below the escape key, and when you enter the values it's going to be the normal inverted commas. So the name I can give a skill link, mobile number I can give the mobile number, email I'll just give some test email ID, and created date, what I'll do is I'll just give the current date. So the SQL command for that is CURDAT, and that's it. So similarly for accounts, I'll just have a dummy entry. So I'll just put into account. First give all the column names. So one is customer ID, name, mobile number, email ID, created it, and now values. So just give some dummy values. So 1, 2, 3. Always remember that when you give number, you don't need to give double quotes. You can directly give it as the number. So in the accounts, we have to give the same column names which we are defined over here. So there's a slight typo over here. So we have to give accounts, account number, then we have account type, then we have branch, and we have created it. And in the values, always remember that whenever you have the type as integer, you don't need to give the double quotes. You can directly give the number. So customer ID, we are just give it as 1, 2, 3. Account number, we can just give it as maybe 98656. Then account type, we can just give it as savings. Branch, we can just give it as Chennai. And created it, again we'll just use the current date method. So that's it. We have just added. So what this will do now is whenever our server is started, automatically in our H2 database, it will first create this table structure and add this value, because normally in the real world what happens is we will just do this setup once using any SQL server, and after that it works. But here we have to, since we are using in-memory database, so we are just doing it once, so that every time the server starts, this automatically gets created in the memory. So now with this, we just save this, ensure to save this file, and now we can go ahead and start our application to see how it works. So to do that, just locate your in.bank.accounts package, that is your main class. Click on that, right click on that, click on run as, click on Java application, and once you see the console, you'll see that the Spring message will come. And once it is started, just wait for a few minutes. So now we see that the server is started of Spring. We had a few errors earlier with the server that was just due to some minor typos. So we just the typos were just like we had a curly braces instead of the round brackets over here, which was resolved right now. And one more thing is we have not yet defined the accounts controller over here. So in order for us to kind of access the service, we also need to define the controller. So that's what we are going to do right now. So as we saw in the week 1, defining the controller is very simple. So you just need to have the @REST controller annotation. So just import this REST controller, and now you have this REST controller. After that, you need to also import AutoWire inside the accounts controller. So W is small over here. So just define the variable over here. So what we'll do is just do a accounts repository. And now we'll just go and see if this import. Yeah, so now you see this AutoWire is also imported, and we have to also import this account repository. So we just stop the server till we complete the work. So in order to resolve this error, we have to import this accounts repository over here. So what we can do is we can also manually import it if it is not coming over here. So on clicking this, as of now it is not coming. So if it doesn't come, that's fine. You can also manually type it out. So just put import.in. bank.accounts.repository.account repository. So once you add that and fix the typo over here, that takes care of that. So once you add this accounts repository, so now we have to do the REST API call. So we'll make a post API call. So why post? Because we use pass certain query parameters to search for a particular customer. So what we'll do is we'll add a post call, and the name of the API which we'll create is accounts, and so we'll just create a method over here called get account details, and here we will just fetch the request body. So that's the reason we are using annotation request body. So we'll just quickly also import the other stuff like post mapping, and we also kind of have to import this accounts over here. So just give accounts, that will import that. And we also need to have the customer. So just follow along. I will explain this code once we are done with the typing part of it. So import this customer. So what you can do is just, if that import is not working, you can just change this to customers and type it over here. So in this, what we'll do is say accounts account repository, the same name that you use over here, dot find by customer ID. So you see this name automatically comes up as you type. Then give customer dot get customer ID. Fix the small typos, customer and customer ID. So if you see that you get an error called get customer ID, which means that the Lombok that we installed earlier is not yet reflected in the Eclipse. So a quick way to fix it is to just close the Eclipse, just ensure to save all the files, and just restart your Eclipse now. Once the Eclipse is started, just right click on this accounts over here, go to Maven, update project, ensure the last three options are checked. Okay. So this will just rebuild the Maven project. So it seems that we missed to add this entity and getter setter and toString annotation to our file. So that's the reason we are getting the error. So just add all this. So just click on it, import on all this getter setter, save it. So why this is required, as I said, so the Lombok is able to create those methods automatically. So now if we come back to our controller class and save it, you see that this is gone. Now let's try to understand what is happening over here. So what is happening basically is when we say @autowired account repository. So what this does is it automatically kinds of injects this repository into our controller. So we have the access to this JPA or the POJO of account repository. And now we are creating the post API call with the name of accounts, and the request body or the request that the customer or the end user will send to us will be in this customer format. That is, they will send one of the key of this customers table. So as you see in the customers table, we have customer ID, name, mobile number, email ID or created date. So they would send us one of that as the request ID as a request. And once that is done, all we are doing is we are just initializing this account repository and we are saying find by customer ID. So if you remember, in the repository we have created this method called find by customer ID, to which we are passing the input as customer ID. So here what we are doing is we are just invoking that find by customer ID and sending the customer ID which the end user is sending us. So if you see, what is the beauty of this is, we are just telling that get customer ID over here. We have not defined this get customer ID in the accounts model, but automatically what happens is the Lombok will be creating this getter method for us and automatically getting this customer ID from this customer model and passing it to this. So that is the beauty of this controller. So now once we save all this and run it, so just right click on this Java in.bank.account, run as and run on server. So just come to this accounts application, run as, run on server. So once you click on run as and run on server, you'll see that the Spring is starting up right now. And once it is fully started, you'll see this message that started accounts application so and so. So if you just scroll up a little bit, you'll see that you'll also see a message that S2 console is now available at S2 console. So first let's see the database that got created. So what we'll do is just go to the new tab and just open, and since we have given the port as 8080, so we'll just go to 8080/S2-console. So this is the S2 database console, and the password and user ID which we have given is admin, password is pass, and ensure that this JDBC URL over here matches the JDBC URL which we have given in the application properties file, which is this one, the first line. So just ensure that these two are matching, and once you give connect, it will now show you all this details. So now you see that automatically this accounts and customer is created. So when you do select star from accounts and run, you'll see that automatically whatever we give in that SQL is created. And similarly, when you just select star from customer, you'll see that even this is created. So this is the use of that data.sql file, so that whenever this application starts any number of time, so we will have certain data already inserted for us, so we can test whether it is working fine or not. Okay. And also we can combine both the tables like this and give a run, so you'll get all the data of both the tables over here. Okay. So that was about the H2 console. Now let's go ahead and test the API if it is working fine. So what I'll do is I'll just open our Postman console over here. I will change the get call into a post call because we are doing a post call. The local host over here is running on 8080 port and the service name is accounts. And in the body, I will just change this to raw. And here I will just change it to JSON. Here I'll just add a object, and now we are going to pass the customer ID. So let's assume that I'm passing the customer ID of 1 and just ensure that the customer ID is put in double braces. And when I now test it, you see that I'm getting the result now. So this result is nothing but, if you just come back to the H2 console and do this, so see, this is the same data that you are now getting. And in case you want to add a couple more data to check, what we can do is just go to the data.sql page, and here you can just kind of copy this, add it like and just change some two data. So I can put as, say, scaling 2, scaling 3, and maybe just change the number something like this. So just to give it make it feel that these are all different data. So similarly, even the accounts, I can do the same stuff. So I can just say this as 2, 3. The account number I can just put as 1, 2, 3, 5. City I can just put it as New Delhi. This can be Bangalore. And now once I stop my server and just run it again. So to run the server, always go to the in.bank account, that is your main class, and then run it. So now when I run my application again, now this time there will be 3 records created in my table. So we can also test it now. Yeah, so now you see that our database is getting created, and yeah, the application started. So if I just go back to the same H2 console, that is localhost H2 console, refresh this page once, and just give the user ID and password. This is what we gave, admin and pass as password. So if I just come to accounts right now and just click here, it will automatically give the select star from accounts, give run. You will see now 3 records have been created, right? So what I can do is in my Postman, so I just come to Postman, instead of customer ID 1, if I give customer ID 2 and send, you'll see that now the data is getting changed. Similarly, if I give customer ID 3, you'll see that the data is getting changed. And similarly, if I give some invalid number and I give send, you'll see that nothing is returned. So this means that we have successfully created our first microservice for accounts. And that's pretty much about this session. In the next session, we'll quickly again summarize what we have done so far and also look into the cards microservice. Thank you. Hello everyone, and welcome back to this third session of creating microservices. So in the last session, we saw how we created the microservices for account, and let's just quickly kind of go through it once again to ensure that we fully understand the concepts before going further. So I'll just quickly explain you in a nutshell what we did so far. So the first step was we went to the official Spring Initializer website, which is start.spring.io. We selected Maven project Java 2.7.2 or whatever is the latest version that you see over here, auto selected. And then in the group, we gave the name of our website in the reverse order. So if it is bank.in, we give it as in.bank. Then the artifact name will be the name of the microservice which we are creating. So in our case, since it's accounts, we are giving it as accounts. And the name again will be accounts, whatever we gave above, that's fine. description can just give a short description of what it is, and the package name will get automatically populated as in.bank.accounts, and the packaging is jar and the version is 11. And in the dependencies, we just clicked on add dependencies, and you see that we have selected Spring Web. This is default, which is required for creating any Spring based REST application. Then we selected H2 database. We selected Spring Data JPA because that is required for us to kind of write the auto create the SQL statements. Then we had the Lombok, Project Lombok, which is required for kind of reducing the boilerplate code in terms of getting and setting the data which is required. And just for testing, we also added Spring Boot Actuator, which is nothing but just a kind of a library which is used for monitoring and managing the application. So with that, and next we did a generate and we got this accounts.zip file. And then later what we did, we just opened it in the Eclipse, sorry. We opened it in the Eclipse, and we then created a bunch of different packages. So the first thing that we did is in the in.bank.account, that's the main package. Inside the accounts application, we saw that it had already had this @Spring Boot application annotation because we are creating it Spring Boot. On top of it, we added 3 more annotations. So for the first one is @component scan. Scans basically means that it's nothing but a collection of different components can put together. So what component scan basically does is, whichever packages you're giving, your Spring Boot will kind of automatically configure the component scanning for that in order for it to pick up all the configurations present inside this package that is given. So the next is enable JPA repository. So this ensures that we are using the JPA entities in order to deal with the SQL and databases. And since we are dealing with entity now, we also need the entity scan so that it automatically scans the entity and picks up all the JPA entities that is created. So in the JPA repository, we give the repository package, and in the entity scan, we give the model package, right? And that's it. So that's what we did pretty much in the main file. Next, we created a package called in.bank.accounts.controller. So in the accounts.controller, let's see this at the last because first we'll see the other things that we created. So the next thing that we created was the models package. So in the models is nothing but just the data related column related stuff which we added. Basically the mapping between the POJO and the data column. So we had something called the model package inside which we had accounts and customers. So the accounts.java file basically had the column names and the mapping for the accounts database. So we had this customer ID, we had this account number, account type, branch, and created date. So whichever is the primary key or the unique number, we kind of annotate that with @ID. Column basically says that this is a column name for that particular POJO model. And generated value basically means that whenever this account, like a new entry of this account number is created, you just kind of auto increment it with a other set of unique value, right? And in the accounts, we had these columns. So first was customer ID, second is number, third is account type, fourth is branch, and fifth is created date. So the data type also we have given over here. So these two are integer, account type is string, branch is string, and created date is a local date, right? And since we are using Project Lombok, we have also kind of annotated it with getter, setter, and toString, and annotated with entity. So what this basically means is that this is a POJO representation of our database. That's what this @entity means. And getter, setter, toString ensures that we don't need to create additional methods over here in order to get the data for our particular column. So say for example, if Lombok was not there, then we would have been doing something like this. So we would have created something like private get customer ID and return some value over here, so on and so forth. So what Lombok basically does for us is it reduces the boilerplate code for us, so that only based on the method name, it automatically gets and sets the value for us. Similarly for customers, we did the same stuff. We annotated it with the entity getter setter, and here we annotated the customer ID as the primary key. That's why we have the @ID, and generated value is again set to auto, so that every new element entry is getting added. And we had @column and private int as customer ID. And after that, we had all these columns which were kind of like, similar to the accounts where we had the name, mobile number, email ID, and created it. So once this was over, the next package we created here over here is called as our bank accounts repository. So in the bank accounts repository, basically what we have done is we have just annotated it with the word of repository. So which is, it means that, this is nothing but the DAO layer where, like, data access to object layer, where we are going to kind of just find or retrieve the data based on certain parameters. So in this case, what we have done is we have extended the CRUD repository for this accounts model, and the long class is kind of nothing but the data type of it, of the long type. So here we are saying for this accounts model, find by customer ID, and here we are passing the ID. So what happens is internally Lombok will just kind of map it and find us the customer ID which is matching this incoming ID. So that is the beauty of Lombok. We don't need to write getters and setters. So finally, now coming back to accounts controller. So you'll see here now that we have added this annotation of REST controller, meaning that this entire class is acting as a REST controller, meaning it will be performing any REST API action. Then we have this auto-wired annotation over here, which means that this automatically kind of gets injected into this class whenever this is started, this account repository. Next, we are creating a post API call this accounts, wherein what we are basically telling is we are just calling this get accounts details, uh, for which the request body which the end user client will be sending us will be one of the key of this customer model. So either they can send us like customer ID or name or whatever, but since we are using a method of find by customer ID, so customer ID is expected in the customer's request. So here what we are basically now doing is inside this account repository we are calling this find by customer method, which we have defined over here, right? And the input of that is customer ID. So inside our controller we are just saying repository.find by customer ID and customer.get customer ID. So whatever is the request, in that we are getting the customer ID. So this is again internally being mapped by Project Lombok, and that is now kind of getting the customer ID. And once this SQL statement is executed by the JPA, we'll get a result, and that result is nothing but accounts, which is now returned back. And to now see it in action, and before that, a few more items. So since we know that we are using H2 database, we have created this data.sql file over here under resources folder with having some basic SQL commands. This is not mandatory for a real-time project. This is just added so that we have some data to test when the application is started. So here basically we have created the customer and accounts table and added a few values. And for the application property files, as I said, this is nothing but just we are configuring our application to let the Spring know that we are using H2 database for all our data related, like all our entity related operations. And we also have kind of enabled the server at port 8080. So always remember that even in case of H2 you use a different database like SQL or DB2 or whatever, only this configuration over here changes. Rest all the configuration in your code remains as it is, and you don't require to change anything, right? And here you have also defined the user ID and password. This you can give anything that you want, but ensure that you don't change all these other parameters. Okay. So once this is done and the server is started, we went back and first we checked into this ID, into this URL, which is localhost h2 console. So here just ensure that this JDBC URL that you give over here is same as the one that you give over here, and the administration, the user ID and password is same as what you give in the properties file. So if you give a different one, it will throw error. So just give the same one which is given in the application properties file. So once you do that, just you'll see that automatically these two tables are created, accounts and customer. So once you click on accounts, and you'll see that automatically the select star from accounts is auto created. So when you give run, you'll see that these three entries that we gave in the data SQL file is generated. Similarly for customer, if you just kind of click on customer, you'll see that select star is coming now. Give run, and automatically you'll see that those three entries are also created. You can also combine both the tables by just giving customers and accounts, and now you run it. So you see all the data. So you see all the columns are now generated over here, right? So that's pretty much about H2 database. And if you want to test the application, all you need to do is open the postman, give the URL as localhost 8080 accounts. Why accounts? Because in the REST controller, in the accounts controller, we have given the post mapping here as /accounts. So once you give that, and here next what you have to do is select the type as post, then come to body. In the body, you select raw option over here, and in the drop down over here, select JSON. And here now you create a JSON object. So JSON object is just like you open and close a curly braces and give the customer ID, because that's what we are passing. And here you pass some value. So in our case, if I pass 1, 2, 3 and I send, it will return me. It will not return me any data because there's no data in the database. But if I just select a valid data, so you see that it is now returning me a valid data from the database. So instead of 1, if I select 2, so now we have see that earlier the branch was Chennai, but now if I make the call with 2, it will now return the branch as New Delhi. And similarly, if I make a call with number 3, it will now send me the branch as Bangalore. So this is pretty much about how we can create a simple REST based microservices using Spring. So that's pretty much about this session. We just wanted to quickly recap what we have done. So in the next session, we'll be creating the cards microservices, and then the loans microservices will be given as part of your assignment. Thank you, and see you in the next session. Hello everyone, and welcome to this final session of the week 3 of microservices course. So in this section, we'll see about creating microservices for our cards department that deals with credit card and debit card. So the credit card and debit card department, or the cards department in short, is expected to retain client information such as name, customer ID, card type, card number, card initialization date, due amount, and the card expiry date, right? So let's try to now create our microservices for this cards department based on the idea that we have so far. So the first thing that we have to do is we have to create a new project, because remember that each of this department is going to be a separate microservices. So we have to create a different starter kit for this first. So the only change that we are going to do is just go back to the same start.spring.io site. The rest of the options remain same. So instead of this artifact as account, I'm just going to change it as cards, and here the description, I'm going to make it as cards. And the rest of the details remains as it is, like packaging is Java version is 11, Maven, Java, and here the dependencies are also same. So you should have Spring Web, you should have selected H2 database, Spring Data JPA, Lombok, and Actuator. Actuators are optional, but these 4 are mandatory. Okay. So now you just click on generate. It would generate this cards zip for you. Just go to this folder, downloads folder where it is generated. Just right click it and extract it. So you will get this cards folder over here. So come back to Eclipse. So now once you come back to Eclipse, what you can do is just minimize this accounts over here and go back to file, import, inside Maven, existing Maven project. So here just browse and add that folder which you had extracted right now, which is the cards folder. So just go and click on this cards. You'll see that it shows a pom.xml is automatically selected. Give finish. So now you'll see that inside this account, so now this cards is also coming up. So what we need to do right now is the same stuff that we did for accounts is what we are going to follow for cards as well. Okay. So the first step before we proceed, just check in the cards application, you are seeing this @ Spring Boot and all this thing is set up. That is fine. So let's quickly set up the application properties of this file of the cards. So what I'm going to do is inside the cards project, I will go into src main resources. I will go to the application properties. You'll see by default this is blank. Just to save some time, what I'll do is I'll just go to the application properties of accounts, copy this entire thing. Since the data is more or less the same except the port number, I'll just paste it as it is, and instead of port number 8080, I'll give it the port number as 8081. Why? Because in one port only one application can run, so it's important that each of our microservices is bound to a different port. Okay, so that's the only change I'm doing for application properties. This is step number 1. Step 2, we also need to create a data.sql file inside this resources. So what I'll do is right click on this resources folder, new, and SQL file, and the name is data, finish, right? So now I also need to add certain SQL queries which will kind of help me with the data manipulation. So this SQL queries we'll write it last. Okay. So first we will go ahead and set up our application first. So what I'll do is I'll come back to this Java folder over here. So similar to how we did for the accounts, like we created the controller, model, and repository. So let's quickly first create the packages. So step 1, get inside this Java folder, src main Java folder of cards, right click, new, package. So the first package we'll create is in dot bank dot cards dot controller, finish, and inside this controller I'll give new class. The name of this would be cards controller, give finish. So this takes care of our controller package. Again, go back on the Java, click on new, click on package. Now we need to create the repository package. So just give the same name, in dot bank dot cards dot repository, and inside now right click on this repository, new class, the name is cards repository, finish. Again click on this new package. Here now we have to create the model repository, so just give the same name. Just ensure that you're giving the same name for all the packages, which is in dot bank dot. Since now it's a card microservice, you're going to give it as cards dot the model. Okay, so this part is going to be common for all the packages, like be it accounts, loans, cards, whatever. And this part will be based on which microservice it is. So if it's accounts, it will be accounts.model. If it is cards, it will be cards.model, loans.model, so on and so forth. Give finish. So it has created the model package. So and the next, right click on the model package, click on new new class. Right click on the model package, give on new class. So inside the model, now we require two databases, right? So one is for the cards and one is for the customers. So the first model we'll create is called cards. Ensure the C is capital, finish. And similarly, right click again on the model, new class, and this time the name is customer, and again give finish, and that's it. So this is the what we have done is we have just created the high level of kind of the structures of the files. Now let's start with the creating the models. Okay, so this is the fundamental stuff. So let's start with the model part. So as we saw earlier, right, so the first step is first let's annotate this. So since this is a model, we have to annotate it with the entity, and then you have to import it. So just click on this import entity. The next is you have to also import the getter setters. So @getter. So either you can annotate multiple annotation in the same line, or a better practice would be you can also do it on the multiple lines. So next is @setter, and @toString. So toString ensures that whatever data you're getting back, it is all converted into string, right? So now with this done, let's define the model. So for the cards, let's start with the primary key, which can be your card ID. So I'll just give @ID. Then since this is a primary key, I have to also give generated value. The generation type, we can keep it as auto. And let's quickly just import the necessary stuff. So after that, we just give @column, and the Pojo name for this would be card ID. So whenever we have to manipulate or call this column name, we'll indirectly call it with this name of card ID in our code. So let's quickly just import all this stuff. So in case you don't get it in first attempt, just wait for some time. Your Eclipse will update and then you'll get this option to import all the columns, as you can see now over here. This is a typo. Use the double quotes. Yes. So we have created the first column. Similarly, you can also create the other column, like you can create customer ID. So this customer ID will be mapping to the customer model which we'll create. The Pojo object for that is customer ID. Next, we'll have the card number, so which is a normal 16-digit card number that we all see. So column. So card number is normally numbers, so we'll just give it as card number. The next, we also need to tell whether this is a debit card or a credit card. So let's have the type. And just to save some time, instead of creating a ton of columns, we'll just add one more column which says name is equal to. So what we have done is we just created and here you have to import this date. So just click on this and import the date. That's it. So what we have basically done is we have created a high level database model which has the card ID, customer ID, card number, card type and expiry date. Okay. So we just have created this 5 columns. Similarly for the customer, we'll just create the same like what we did earlier. So what we'll do is, so instead of just to save some time, I'll just quickly do it. So the same stuff that we did earlier. So we have to first set the getter, then setter, and import all this. So import getter, import setter, import to string. And just like how you did it in the accounts, we'll also create a basic customer model over here. So there's one more thing. Either you can create the entire customer model or the customer table just the way you did it over here. So just the way you created over here in the accounts, you can create this entire table and kind of map it. That is one way of doing it. Or to save time, or just to make it simple, or just to repeat, or to save time and just to make it simple, what we can do is in this model of customer, instead of defining it as an entity, we can just define it as a local object and we can do it. So how to do that is, so just come to this public class customer, and here we are not defining any entities as such. All we are doing is we are just creating a private integer, a private pojo with just a customer ID. That's it. Save it. So just remember what we have done. So unlike the other customer, we have not added the @ entity because we are not going to create again a customer data table. So just to save some time and complexity. So rather what we are doing is we are just creating a private pojo of a customer ID, and using Lombok we'll automatically get the getter, setters and toString of this. Okay. So now we have, what we have done is we have created the model of this cards section. The next thing, let's define the repository. So the repository, all we need to do is we have to just define a fetch method which will just go and query the database for the ID that we pass. So this is also similar to the cards repository that we did. So first you have to decorate this class with the repository annotation. So just import the repository annotation. Then here you give extends CRUD repository. The model which we are going to use is cards, and the data type is going to be log. So now let's import all this. So the CRUD repository, just click on this, and in case you don't get it like the way I'm not getting it, so what you can do is you can just manually kind of import it. So how to import it is, just go on the top, import org spring framework dot data dot repository dot CRUD repository. That's it. And similarly for the cards, you just need to import the cards model as well. So just come over here, import. So here we'll give our package name. So now what we'll do is, the idea is like the query is like, let's assume that one customer can have multiple cards. So the idea is we will first send the customer ID to this particular method, and we'll get the list of card which the customer is holding. So for that, what we'll do is we'll use the list data type. So the type over here is going to be list, and the data type of that is going to be card, and here the same concept, find by customer ID, and over here what we are going to pass is the customer ID. So in this file name, there's a small typo. Instead of repository, it is written as repository. So let's quickly just rename it. So how to rename it is just go to refactor, right click refactor, and instead of repository, just give it repository. And in case if you get all these errors, one ideal way to just quickly troubleshoot is to directly just like right click on this cards, go to Maven, go to update project and just clean it. So sometimes it happens that your dependencies are not updated and you may get the error. So that is one way of doing it. And the other typo that we did over here is, remember, this repository has to be an interface. So just rename this class to an interface. So the next time, when we create a repository instead of class, please choose interface. So this gets automatically created for you, right? So now you see the errors are gone. So finally, now let's go back and create the controllers. So if you go back to this cards controller.java, so this is very simple, the same way we did earlier. So first, decorate this with a REST controller. Right click here, click on this, import the REST controller. Next, we are going to put the auto wire. Here we will define the cards repository and define the variable name as same. So just remember that when you define the type, it's going to be capital, and when you define the variable name, it will start with a small letter, camel case, right? So just import this card repository, import the auto wired. So this ensures that all the auto wired related stuffs are automatically kind of initialized into your dependency injection. The next step, we are going to create our API call, which is post. So we'll give the annotation as post mapping, and now we'll give it as, and now give the service name, which is cards. So you can give any name that you want, but I'm just giving the name as cards over here. So this is the name of your API, and after this, we will now kind of define the methods. So what we can do is we can just make it public list, because we are going to return a list of cards. So cards, and here we can just give get cards, or maybe get card details, something like this, @request body. Why we require this @request body is to get the data from the request which the end customer is sending. So here again we'll send the same thing, customer, and now just import all this post mapping. Right click here, import the list. So this list has to be imported from the java.util. Import the cards from the model and the request body of the Spring. That's it. So this is step 1. So after this, so just open the cards repository dot. So automatically when you give dot, you will find this find by customer ID. So that is what we have already defined in the method over there. So inside that, what you need to do is just give customer dot get customer ID. So you see that Lombok has already created that setup for you of get customer ID. So once you get that, just return the cards list as it is. That's it. So with that, save the file, and we are done with the cards controller as well. So with that done, the final step for us is to kind of just populate this sample data in the data.sql. So remember that here, this time we are just creating a cards database and not the customer database. So we just need to populate the cards table. So we can quickly first do drop table. So this is just a failback statement in case if the table exists, we are just dropping it. Most 99% won't be there when the application starts, but just for safety purpose. So next we say create table. The name of that is cards, round brackets. Inside that, just give a few ID like, so whatever basically you defined inside this cards, right? The same thing is now going to come over here. So just give save all just to ensure everything is saved. So what I'm going to do now is I'm going to just have this cards and data SQL open side by side so I can just refer to the column names quickly. So one is card ID. Card ID is a integer. So I would say integer not null, or rather I could also say it as primary key and auto increment. Next I have my card number. So if you see here, you will see that, sorry, next I have is my customer ID. My customer ID again is an integer. And again I can say that this should not be null. The next I can have my card number, card type and expiry date, right? So I can have my card number. Card number is again a integer and this should not be null. Then I have my card type. Always remember that don't give camel casing over here. So you only follow underscore here to separate the words for the column names. So next is the card type. So card underscore type. This is going to be a varchar. Since it's a string, is equal, we define it as varchar, and maximum we can keep it as maybe 50. So if you have like credit card or debit card, I don't think, or maybe safer side, you can just keep it as 20. And this also will not be null. And finally we have the expiry date. So the data type is date, and the default we can just put it as null, meaning that all our cards are not going to expire for now, just for like demo purpose. So this is our SQL which we'll be executing, and for test purpose we can just have a few values inserted. So we'll say customer. First we'll give the name of all the column names. So customer ID, card number, card type, and expiry date. So customer ID, since it is a number, I'll just give it as 123. Card number, you can just give any random number. So I'll just give 4000, 5000, 2000, 6000. Card type, I'll just give it as credit card. And expiry date, again I'll use the current date just as sample. So the same thing I'll just copy and add a couple of times. And now I'll just change a few numbers. So instead of 1, 2, 3, I'll just give it as 3, 4, 5, 6, 7, 8, 9, 0, 1. And instead of 4000, I'll just give it as 6000. And here I'll give it as 8000. Here I'll give it as 1000. And probably here I'll change it as debit card. Or maybe what I'll do is I'll just create for the same customer ID different cards. So customer 123 has a credit card and debit card, and customer ID 2 has a credit card and a debit card. So that way it becomes easy for us to even test it. Okay, so all we have done is we have just created 4 entries. Like one customer has a credit card and debit card, the other customer has a credit card and debit card, right? So with this, I think we are done with the cards microservice. So now we can quickly start the application and see whether it works fine or not. So to start the application, all you need to do is just ensure in the application.properties you have given a different port number for card, or else it will create a conflict with your accounts. So now just go back to the in.bank.cards package, go to run as Java application. So you see that in the console there are a few errors. Let's just quickly try to see what are the errors and fix it. So it seems that in the SQL commands we have some errors. So just let's quickly run it one more time and see if that works. And also a small typo here in the cards.java model file, we have given the column name as capital E, whereas as per the convention it should always be in a small letters. Okay, so let's just quickly go back to the SQL and check if there are any quick typos. So in the application properties, we see that it is executing, there's error executing DDL. So what we can do is we can add another property over here called as Spring. So what happens is, like, at times we will not be able to kind of do this DDL property updates. DDL is nothing but data definition language, which means like any operation where you create or drop or validate, update your tables. So what happens is, like, So it's better that we add the statement over here so that whenever there's any similar errors, it gets resolved. So let's quickly go and try it now. So if I just go over here, run as and Java application. So it seems there's some typo with the SQL. So let's quickly do other way and try to see if it works. So what I'll do is for now, I'll just kind of comment out all the SQL statement. And now let's try to start our application, right? So we'll just give it as run as Java. So let's see if the server starts now. Okay, it seems the file was not saved. That's why we're getting the error. Just quickly clean this project once before. So I'll just go to this cards, Maven, update, clean it. And now I will just go ahead and start my project. So one thing over here is in our cards.java file, we have missed a typo. We have missed an underscore. That is the issue. So it should be like expiry e small underscore date with d small. So now I think we can give it a shot. Just go back to the sequels, uncomment it. So to uncomment it, just press Control and the forward slash, the one next to the shift on the right hand shift. Now just go back and give it run as Java application. Okay, it seems there's some issue with the insert command. So what we'll do is for the time moment, we'll just comment out the insert. Since the data is getting created, we can manually also insert it later. So what you do is just comment out this insert. We'll come back to that and again start your server. So it's telling that application failed to start, the web server port 8081 was already in the use. So it seems that the earlier time we closed the application, the port was not fully killed. So one way to resolve it is you just go back to your application properties, like just restart your computer, that will be all right. But if you want to just quickly do it, just what you can do is you can just take another port, maybe like something like 9000, save it, and now you can just start the application again. So just give run as Java application on cards. Yes, so now you see that it has started the application. So now what you do is just go to the console. So now our application is running on 9000. So first we'll go to the H2 console, which is our database console. Just give password. You see that now the cards table is created but no entries added. So how to troubleshoot our insert, like the typo in our insert is like we just copy this from here and paste it over here, and we'll try to run it. So it's telling that the column credit card is not found. So it means there is some issue. Just a minute. Okay. The issue is resume. So the issue is like since we are given the card number of the type integer, we cannot enter really wrong numbers. So what we can do is, just for the demo purpose, we'll just enter smaller numbers, and when you run it, you'll see that now it's inserting. So just come back to the SQL, our data.sql file, uncomment all this, and we'll just quickly reduce the number. If you want to really use the long numbers, you can use like long or long numbers, that should be fine. But just for the sake of this demo, we are just using the smaller version of the card number. So just save it, stop it, and now just restart your application. Just give run as Java application. So meanwhile, we can also go to Postman and get our URLs ready. So what I'll do is I just create 9000/cards. So if you see in the Eclipse, under cards controller, we see that we have given the URL as cards. So that's why even here it will be /cards. And if you see in the data SQL, the customer ID that we have entered is 123 or 678. So we can give here as, first we'll give 123. And we'll also, there's also a small typo, we should not be using double quotes. So it should be a single quote. So let me just quickly change it up. The data.sql. Save the data.sql file, and we are good to start. Just go back to this main file, cards application, and just run it again. So now if everything runs fine, we'll have a database with this 4 entries, and we are good to start. So what we'll do is, there's still some error, so just directly paste it from here. So it just updated the SQL file, and now we are just starting the application again. So now we just have one customer, each having like both the debit card as well as the credit card. The numbers are given. So now let's see if the SQL works. There was some minor typo issues, so that's why we are just restarting the server now. Yeah, so now you see that the cards application is started. So if I just come back to my H2 console, which is localhost :9000 H2 console, I'll just do a quick refresh. It'll ask me for the password, connect. There's a typo with the password. So the password is pass. So once you give that, and if I do select star from cards, you see that no, now there are 2 entries added. So now if I go back to my Postman and I give customer ID as 123 with this as slash cards, you see that now I got a list of array with 2 objects, right? So one is having my credit card and one is having my debit card. So similarly, if I want to test for other data, all I need to do is just go to my data.sql file. I'll just copy this again, paste it again. So instead of 123, I'll just give it as 456. And here I'll give as 456, and probably I will also have one more customer who is just having a debit card, like he or she is not having the credit card. So here I'll just quickly just change the numbers to some random values. And that's it. So if I just restart my application, technically I don't need to restart because I can also like just execute this SQL statements over here. So since I just wanted to show you from the data.sql file, that's why I'm just restarting it. So now you see my server is already restarting. So how to know whether it's restarted is the last line, it will say started card application in this many seconds and running. So first step is just go to this S2 console and just give run. So here, since you have restarted last, you to re-log in. So just give run, you'll see all the data that is generated now. So come back to Postman. So now we gave is 123. So instead of 123, give 456. So now you'll see another set of data for these cards. And similarly, there was another customer is having only the debit card, which is 987. So if you give the query as 987, so now you'll just get the list having this customer who's having this debit card. So this is how you kind of like, write the data, search the data, and do all that using the Spring. So this is how now we have created a Spring microservice, which is fetching the data from the backend. So with that said, so now let's talk about the assignment which you guys are going to do for this week, which is creating the microservices for the loan department. So the loans department is expected to hold the information about the following items. So one could be the name of the loan, second could be the customer ID, third is the loan type, fourth is the account number, fifth is the EMI amount, then the due date and the interest rate. So what you can do is, based on what you have done so far in the cards and accounts, similarly you can create a model based on these values, and you can create the loans account which will just fetch the loan value given by when we query it with a given customer ID. So let's quickly summarize what we have learned. So in this week, we have learned that how can we take a real world application like a banking system and create microservices around its various department and functions. We saw how to configure the Spring Boot application in order to create various independent microservices for each department. And finally, we saw how to connect backend databases to perform CRUD operations or create, read, update, and delete operations. Thank you. And with that, we have ended this week's session. Have a good day. Bye. Hello, everyone, and welcome to this fourth week of microservices using Java, Spring, and Docker course. In this week, we will be studying about Docker and understand what is the benefit that Docker and containerization as a whole gives us. So let's quickly recap what we have learned so far in the previous week. So the previous week we learned about a real world banking application and created a microservice around various functions of the application. So if you remember, we created accounts and cards microservices using Eclipse and Spring Boot, and we also saw how we can create our own services or functionalities in those application, and also we tested it using the Postman application. We also saw how we can configure the Spring Boot application in order to create various independent microservices for each department, which was accounts and cards in our case. And finally, we saw how we can connect with the backend database to perform the CRUD operations. So CRUD operations is nothing but the operations where you just kind of create, read, update, or delete any of the records from the backend database. So in this week, we'll be predominantly focusing upon the following main topics. So first, we will understand what is containerization and understand what is the benefit that it offers. Next, we will be converting our account microservices into a Docker image. Then we will be looking into the concepts of build packs, and then we'll be pushing the images to the Docker Hub. And finally, we'll also understand what is Docker Compose and the advantage that it offers. The learning objectives for this week is we'll be understanding why we require containerization and what is containerization. How can we convert the account microservices and also card microservices to Docker images using Dockerfile. We'll be looking into the build packs and create Docker images for our microservices to publish them into Docker Hub. And finally, we'll be understanding what is Docker Compose. So first, now let's try to understand what is containerization. So for any large project, developing microservices involves creating a number of services that creates a few major issues as listed below. So when you have a large number of microservices created, managing the deployment of many microservices becomes a key challenge. And we also have a challenge of keeping the microservices platform independent across any machine. And finally, we also have to ensure that we minimize the cost and efforts while ensuring to scale our microservices based on demand. So if you just see this image on the right, this is just kind of a conceptual image. So just assume that each of these blocks over here are nothing but each functionality or department in your bank, okay, or any organization for that matter. It could be your retail online store, it could be your bank, it could be your food ordering app, so on and so forth. So any large application is nothing but we can logically divide it into different functionalities or different departments, which in turn can have a number of features. So over the time, as your company grows or as your app grows, the number of features that gets added to it will be increasing over the time. So a key concern that we have over here is how can we manage the deployment of each of these microservices? Because as you can understand, having a single microservice or a bunch of microservices, all right. But if you have like tens and thousands and lakhs of microservices that are being developed, how do you manage the deployment of all of these together? That becomes a key challenge. The second part is how can we keep this microservices independent across any platform? Meaning, if I develop my microservices on a Windows machine or maybe a MacBook or maybe a Linux, how can I ensure that this microservice can still run across any of the platforms without me having to reconfigure things? So as you may know, right, if you have a Windows machine, the way you install and configure things in a Windows is totally different on how you do it on a Mac or a Linux machine, or for that matter, any other operating system. So that also becomes a key challenge wherein we have to ensure that our microservices that we develop is kind of platform independent and we are able to quickly deploy it across any of the platforms. And finally, this is more from a project management perspective. We have to ensure that, we have to minimize the cost and efforts of our microservices development while also ensuring that we are able to scale our services on demand. A simple example of this would be, so say assume that you are running a e-commerce application or you're running a banking application, right? The demo app which we are creating. So as you can assume, the peak traffic or the key load on your application specifically increases during particular period of time. So say for example, if it's an e-commerce application, so usually the traffic to your application or to your site is normally more when there is a festival season around the corner. Maybe it could be Diwali, it could be Holi, it could be Dashera, Christmas, New Year, Eid, like any of those festivals. So people tend to kind of do the purchases around those period of time. And similarly, if you're a banking application, so typically the load on your application would be more whenever there is the time to pay the school fees or the time to kind of recharge your monthly broadband bills and pay other stuff, so on and so forth. So we also have to have this consideration that how can we ensure that we keep the cost low. Why I mean to say the cost low, because if you want to keep your application always up and running and ensure that the traffic is always taken care of, so one traditional approach of doing it is you always have like tens and thousands of servers running all the time. But as you can imagine, if you have like, tens and thousands of servers running with your application all the time, the cost to run that and cost to maintain that is also equally high. So when we are having the microservices architecture, we also have to ensure that, our application is able to dynamically scale. So what we mean by scale is if you have say 10 users, your application should be able to handle the load. Even if there are 1,000 users down the line, your applications should still be able to manage the load without any degradation of performance. So how we can do that, you see it over the course of this session. But we have to understand that this is also one of the key major issue or challenge that we will be facing while creating any microservices. So just before we proceed further, I also want to let you guys know that developing microservices is definitely the way to go forward for any organization or application. But as we create microservices, there are also a set of challenges which we'll encounter. So I would say these are just challenges and not any roadblocks or issues. So by challenges, I mean that these are a few considerations which you should have in mind while you're creating your application, so that you don't have any last minute surprises when your application is running in the production or when your end user is using them. So the challenges that we saw so far, right, in the previous slide. So in order to solve them, this concept of containerization was developed. So containers are nothing but the platforms which help us to develop and execute applications along with their dependencies across any supported operating system or machine by creating a container image. So as you can see on the images on the right? So this is a typical container that you can see in any of the ports or harbors where the goods are being shipped, right? So what is a container? If you just take the example from a physical container. So container is nothing but an enclosed space wherein you just dump or keep all the goods of a particular category together. And that container is kind of isolated from the other containers or the goods from other containers. And you can stack them like, separately and, group them together and do all those stuff. So when you take the same concept and apply it to the software world, so what containers are basically nothing but they are just your code, the application that you write, and along with them, we also keep all the dependencies together. So what I mean by dependencies is, so take the same example which we did in the previous week, right? We created a Spring Boot application and we developed the accounts and cards microservices. So in our case, when we put them in a container or we containerize them, so what happens is, along with the core code that you wrote, your container will also contain the Tomcat server which is required to run it. It will contain all the dependencies like your Spring Boot, your Maven, and other dependencies which are present in the pom.xml file. It will also package all those things together and it will create a complete runtime environment for it. So the advantage of this is I can take this container and I can execute it across any platform without having me to worry that every time I have to configure something or the other when I'm changing the machines or changing the operating system. And in order to do this containerization, there are many tools available in the market, but Docker is a very popular and industry-wide used tool which is used for process of containerization of an application. So this is a sample architecture of how a Docker application works. So basically on the left hand side, you see that you have this client. So the client is nothing but you as a developer who is going to use Docker to create a Docker image. So basically what you do is you kind of run a few of these commands. So for now, just try to understand what is happening. So when you kind of execute a command like say docker build or docker pull or docker run. So what this client does is it will be connecting to a Docker host, which is a remote host running on a cloud, wherein there will be Docker daemons, which Docker daemons are nothing but, kind of processes which keeps on running in the background. So what happens is your Docker host, right? You'll also be installing something called as a Docker desktop and Docker processes in your local machine, which you'll be seeing in the due course of time. But this Docker host is nothing but, it will be having a series of processes which will be running in the background and checking if you are executing any command. And once you run any command, what happens is it will then first check what are the images which are already pre-built or available. So what are this is nothing but I'll just give you a simple example. So we are already using a few of the commonly used libraries, right? Say for example, for operating system, we have Ubuntu. For maybe for Java, we are using OpenJDK or like the Oracle JDK and things like that. And maybe for database, you use SQL. So what these application vendors have done is each of these vendors have created their own official Docker images. So instead of you creating them every time by yourself, you can use this pre-built images and create your containers directly. So we'll be looking into this in practical, so it will be more clear to you. But for now, just understand that your Docker daemon will try to first read what are the available images, and then it will try to make a container of out of those images and the code that you have written into an individual standalone containers. And finally, we'll be pushing all of these containers into a registry called as the Docker Hub, which is nothing but, you can just say it is a centralized repository which will be maintaining all your images and containers. So this is kind of high level Docker architecture. Before we proceed, it's also important to know why we are using Docker. So understand this, right? So first I said that, when you're going to go with a microservice architecture, it is important that, you containerize your application. So what I mean by containerize is you take your application code, you take all the dependencies, all the like the other stuff which is required for your application to run, take them together and pack it together and make it a container. So that is the concept of containerization. And in order for you to do this process of containerization or make containerized app, there are many tools available. The most popular of them is called Docker. And why it is popular is it's kind of like, kind of become an industry standard right now. So any large organization that you take kind of use Docker in order to create their containerized application. So what happens is Docker, it will it builds your code, this code can be run anywhere without having to worry about platform specific dependencies. So even in the normal scenarios, right, there are cases where it happens that you and your friend might write the same piece of code, but sometimes the code will run on his or her PC, but not on your PC. Though, like, the environment and setup and everything is same, because there are a few things like a few libraries or a few dependencies which could be missing, or you could have a version which is higher than his or hers, so on and so forth. So in order to overcome all those challenges, we use this concept of Dockerization, I mean containerization. So wherein what we do is we specify everything from the scratch. Like, we specify what are the libraries, what are the versions to be installed, what are the servers to be installed, what is the environment setup. Everything is defined in the containerized app, so that the same app is kind of standardized and you just have to execute that app across any platform. And the way we execute it across any platform is we have this concept called as the Docker desktop or the Docker platform environment. So which we have to just install across any of the operating system. And once you install that, all you need to do is just import the image that you have created and you're good to run it in a container. So Docker, as I said, allows us to make the development and production environment consistent, thus increasing the speed and reliability of the application being developed. So what I mean by here, so basically what happens is if you take any application, right, it could be a Uber, like app like your Uber, Swiggy, or like, a banking application. So generally what happens in industry is the developers, when they create an application, they have an environment called as a development environment, which is kind of their test environment where they can play with the application, do any data manipulations they want, and, just create the application. But when the same application is being deployed and, like, the end users are actually using it, that environment is called as production environment, wherein the developers or any of the persons from the organizations are not really allowed to, like, just randomly run any code or do any changes as they require, because the data is the production data. So if you can imagine, if I, as a developer in a bank, and, if I have access to a production environment, I can just can't randomly go to a database and change balance of any customer. That would be a violation, and also that's not good. So that's why what generally happens is we have multiple environments. Like, the general standard system is we first have the development environment where the developer kind of develops the application, tests with the data, and do all the stuff. After that, we have the QA environment or the system integration test environment, wherein, like, the application is integrated with the rest of the components, and the testers or the QA team members kind of perform the test on that application in order to find out bugs. Once that is completed, it then goes into UAT or user acceptance test, wherein the business users or the section of the users who will be actually using the application, right? So say for example, if it's Uber, so what I could do is I could invite a few of the users to actually, like, try the same app as they would in a real life by giving them access to my application. So that is called as the UAT testing. So this is also similar to the beta testing and the alpha testing, which you might heard for some of the applications. Or even in Windows, you have this Windows experience or the Windows, like, early release stuff. So these are nothing but more like a user acceptance testing stuff. So once the user signs off and says that, this application is good to use, and finally it goes into production. So production is nothing where people like you and me would be downloading the application from Play Store or App Store, or, like, accessing the website and using it. So that is called as a production. So what happens is if you use Docker, we could kind of make all the environment consistent. By me consistent, I mean the same setting, the same library, the same dependencies, everything we could kind of mirror across each of the environment. So ensure that, we are testing and using the app consistently across different environments. And finally, a few of you would have heard about this term called as virtual machines or the VMs. Like, you could have also done a few of things in your college or, like, in your earlier projects. I also want to make it clear that containerization is quite different from the concept of virtual machines. So virtual machine is a concept wherein you install independent operating systems on top of your machine and, like, create different servers or different machines out of your base operating system. But containerization is a concept wherein we are not again creating the same virtual operating system, but we are rather just packaging the app and running it independently on the same base operating system of the machine. So VMs are more hardware dependent, and each VM has its own operating system, and also it is also resource intensive. As you can assume that, if I'm going to install more operating systems, virtual operating systems, on top of my server, like on top of my machine. Need to have more hardware dependencies. I also need to have more RAM, CPU, and all that stuff. But what Docker does is Docker shares the host underlying operating system and the necessary library dependencies, enabling quicker deployment, shorter boot up time, and simpler maintenance. So what Docker basically does behind the screen is it has something called as Docker file. It is a file which we create, and that has several commands and arguments which by which we kind of create this Docker image, and we go about containerization, and we go about containerizing our app. And finally, we have this concept of Docker Hub. So what is a Docker Hub is, so say for example, if I have created an image and I want to share with you. So what I will do is, instead of manually transferring the file, I will put it in a Docker Hub. So wherein you can just go and clone it or download it and run in your computer. So this is very similar to this concept of GitHub. So if I'm sure that you guys would have heard about GitHub if you have been active in the software development for some time. So GitHub is nothing but a central repository where you can post your source code of the application and where the other developers can just go and clone it and run in their own machine. So similar to that, Docker Hub, you can create your own Docker images, share over there, and any other developers who want can simply search with the name of your image and download and run it in their own computers. So now we have heard about a lot of theory part on what is it to be what is it to create a container, and what is Docker and all that stuff. So next, we will be now converting our accounts and cards microservices using Docker images and Docker file. So before we do that, I also want to quickly show you a quick demo about what is containerization, what is Docker, how Docker is different from VM and all that stuff. So the first thing, before we go any further, just want to quickly recap what we have done so far. So I hope this concept really stays in your head. So in the conventional method, how we create any application is first the developer will write the code, right? This code is nothing but if you just go back to this Eclipse, what we created last time, this is nothing but your code, right? This we created this accounts microservice, we created the cards microservice, and we just went here, right clicked, run as Java, and you can see here the server started for both of the application. And to test it, what we did is we just went to the Postman, we just gave localhost 8080 accounts. It was a post account, and we just gave a query ID of 1. We got certain data. And similarly for card, it was running on the port 9000. We here also we just did a post call and we got some data. So this is how you run your application in your local. And to run this application in your local, if you remember last week I said that this Spring Boot by default packages this Tomcat server. So that is why you see this Tomcat server is automatically running in the background, which is kind of serving your application. So what happens is generally when you write any code and you want to kind of deploy it or let your end users use it, you kind of deploy it on a server. Okay. So this server could be like your Tomcat server. It could be any other server like WebLogic server, so on and so forth. This is how generally it works. So you write a code and your code internally would be having a lot of dependencies, right? So this together makes your application, right? So this application gets deployed into your server. So what happens is, what is dependencies is, so if you just come to your Eclipse folder and to your Eclipse and you just come to the pom.xml of your accounts microservice, you see that here there is a section called as dependencies, and you see there's a bunch of dependencies added. So one, you see Spring Boot, you will see H2 database, you will see Project Lombok, you will see the other things like Maven and stuff like that. So what are these are nothing but dependencies. What dependencies means is, for your application to work properly and connect with third party services and use certain features out of the box, these external libraries or dependencies needs to be installed by the project first in order to use it. We are not explicitly installing them because, as I said in the last week, if you remember, when you kind of go to the start.spring.io website and select all these dependencies and install it, and generate the zip and open it in the Eclipse, in the background the Maven would be doing all that installation work for you. So that's why you don't really go and manually kind of install it, but you specify the dependencies over here. So what happens is, when I'm going to deploy the same application into my server, I need to ensure that all these dependencies along with their correct versions are getting installed properly, right? And for example, in this case, my Java version is 11. So I need to ensure that the server has the Java version 11. It has all these dependencies, Maven dependencies installed. before kind of running my application. And I need to also ensure that this is kind of consistent. It should not be like, in my machine it is installing Java 11, in your machine it is installing Java 12, so on and so forth. So that's why kind of we have this pom.xml file where we mention all these versions and dependencies properly. And this kind of gets automatically installed whenever you're running your application in Eclipse. So what happens is now when I take my code and my dependencies and I want to deploy it into a server, the general way of doing it is we just kind of use a build tool, like you could use ant or maven or any of those stuff. We just kind of create the jar or the war file, and that jar or war file we go and we deploy it into a server, right? So this is how normally the deployment does. And once it is deployed into your server, it is kind of exposed to the outer world in a IP and a port. So your server will have a IP, so like something like this 192.168.0.1, just a sample IP I'm telling. And your application will be running in a port maybe like 8080. And if you have developed say accounts microservice, I would be exposing this API as accounts. So this is how generally like any application is deployed, and this is what is available to the end user. So this again, we do a series of step like DNS mapping and all. So that's why like normally for the end user they don't really access like this. So what normally they access is something like this. So in our case, say the name of a bank is bank.in, example, right? So what we normally do is bank.in/accounts. So this is what we kind of expose to the end users. And internally, what happens is when this request reaches your server will then determine that this request has to be routed to this IP and this port and to this microservice thing. How this happens, we have a few technologies like Spring Gateway and all that stuff. For now, just understand that whenever you hit any API, internally it will be mapping it to certain IP and port and then routing your request. So this is how it normally happens in the real world. So what we are doing right now is we will be taking our code, right? We will be taking our dependencies and instead of directly like, converting into a jar and running into a server and like, doing all that stuff, what we'll be doing is we will also kind of take all the other environment related configuration, like, even in your server, what should be the heap size, what should be the port in which the server is running, all those kind of things. So we will take all of this together and we will package it as a single image. So this is nothing but the concept of containerization, or this is called a container, and the process of what you do with it is called is the process of containerization, right? And in order for you to do this containerization, there is a tool called Docker. So this is the tool by which we will be taking our code dependencies and all the environment configuration other stuff and creating containers out of it. So now what happens is once you have used Docker, you will be creating an image of your code and your environment, and that image will now be running in a container. Okay. And this container is nothing but it will be using the same resources as your base operating system or your base machine. So which is nothing but your machine. Our code that we have, we will be converting it to an image using Docker. And then this image will be then running in a container, and that would be nothing but running on our base machine or on our laptop, computer, desktop, whatever it is. So this is the entire process of how Docker works. So here this container is nothing but an isolated environment. So what basically happens is I'll just draw quickly a schematic diagram. So assume that this is your laptop or your desktop or whatever computer that you have. It could be a server as well, right? When you deploy it to actual server. So assume that this is your laptop server or whatever it is. On top of it, what you have installed is the operating system. Like it could be your Windows 11, it could be Linux, Mac, whatever, right? So it could be any of these operating systems. So similar to any other application that you install, right? Just the way how you install your Eclipse or how you install like Postman, like Notepad, any of those application, you would install something called as a Docker engine. Okay, this is the only thing which you will install. And don't worry, Docker engine is available for most of the common operating systems like Windows 11, Linux, Mac, and all the stuff. So you can just take that installation file and install it over your operating system. And once this is done, and we have created our images, and when you run those images, what Docker will do is it will create independent container environment. So where if I want to have a container for app 1, this will be a complete kind of isolated environment where my code plus all my dependencies will be packaged together and running independently. Similarly, if I want to have another app running, so I will have a separate environment created by Docker, which will have my code and all the dependencies running. And similarly, and also the other beauty is if I want to have two instances of the same app. So say for example, if the app one, I need to have two instances. So again, the second instance of app one will be running in a very different isolated environment with no connection to each other, right? These will be totally independently running of each other. So I hope now you get the advantage here, right? The normal scenario, what happens is if I were to have a server in my machine, right? So in that case, what happens is I will have an operating system. On top of it, I will install my server. And here what basically happens is my app will be running in different ports of this server, but kind of the environment is still the same, right? It will be still using the same environment config and all that stuff of my base operating system. So there is no kind of isolation over here, pure isolation, what I mean to say. But here what happens is I create a container which is kind of a mini world of its own. It does not interact with the outside world. It is not bothered what the configuration of the outside world is. Everything is packaged and everything is running in this container only. So any request that comes to app one will directly get hit this container. Any request coming to app two will hit this container. And if you have something like a load balancer or like a mechanism where you can route to different instances of the same app, you can also do that. So with that, I hope this concept is really clear about how the Docker works, how containerization works. And before we wrap up, I also want to quickly tell you the difference between a VM and a Docker. So what is a VM is virtual machine. So as I said, what happens is you have your base machine. So what is base machine is nothing but the hardware like your laptop or your server or whatever it is, right? On top of it, you have to install something called as a hypervisor. So this is kind of an engine which will be managing the communication between your VM and your base machine, right? And on top of this hypervisor, now we will create independent VMs. Okay. So this is VM1, this is VM2 example. Okay. Or you can also say like app1 and app2. Okay. So what is inside this is you will have your application code. Okay. Then you will have all the dependencies of that code, and you will also have a guest operating system. It could be Windows, it could be Linux, based on what you want. And similarly for app 2, the same stuff. You will have the code, you will have dependency, you will have guest OS operating system installed. So basically what happens is I will have a base operating system for my machine, on top of which, similar to the container, I'll be creating independent machines or independent applications on top of this, and each of them will have its own guest operating system. It'll have its dependencies, it'll have its code and all that stuff. So what happens is over the time here it is kind of more hardware dependent, wherein like based on the hardware like that I have, I will have the limitations of number of apps that I create, because as you can imagine, if I'm going to install an operating system, say like for example Windows or Linux or like all those kind of operating system, that itself will take some considerable space, and on top of it I have to install the dependencies, and then on top of it my code will run. So this, if you just understand, it is quite resource intensive. But in case of my Docker, as we saw earlier, so what happens is I have my base machine, that is your laptop or your underlying server. On top of it, I have my operating system, which is already installed. So I don't need a separate hypervisor over here. So here I don't require it, right? Just what I require is I just need to install a container engine. So which this is nothing but like like my Docker, which is nothing but it just provides me a way how I can like interact this container with my base machine. And after that, I don't have to install again the guest operating system and all that stuff. All I can do is I can just create containers. So for my app one, the container will just have the code and the dependencies. For my app two, the container will have the code and dependencies. So that's it, and each of them will be running isolated. So the advantage over here is we are eliminating this guest operating system altogether. Using my same base of machine operating system, I would be able to kind of run this in an isolated environment. So that is the beauty of like the Docker. So wherein I can just create isolated independent environments and run each of my applications separately as different processes inside the same base machine. So here the advantage is for the same server, for example, if you could run maybe 5 application over here you could maybe run 10 or 50. I'm just giving some hypothetical numbers, but this is just to make you understand because it is more resource efficient. So I hope with that you got some idea and clarity about what is Docker, what is containerization, how it is better, efficient. So in the next session, we would be like then working on converting our code which we have created over here. So in the previous week, we have created just our code and made it running. So now in the next lecture, we will be seeing that how we can convert this accounts into a Docker image using Docker file. And we will also be converting the cards microservices into a Docker image using different approaches. So this is just to let you know what are the different ways in which you can create the Docker image. So thank you and looking forward to see you in the next session. Bye. Hello everyone and welcome back to the second session of the week 4. So now, as we discussed in the previous session, we will start with our practical of how we can convert our accounts and cards microservices into Docker images. So as I said earlier, we would be following two approaches. The first would be the manual tedious approach where we will go through how it is to actually create the Docker image from the scratch. And in the second approach for the cards microservices, we'll be using a advanced method which will be less tedious, where you'll be able to appreciate what is the beauty of build packs and how we can create Docker images even easier. So we will be having two different approaches of creating the Docker images. So now let's head over to the Eclipse and get started. So we have come to our Eclipse right now. And in case if you have your server still running, how you can check that is if you just open your accounts, like, just open your Eclipse and your project, just come to the console and see if there is, like, you see this red button over here. So that means that your server is up. So if that is the case, I would recommend that you kind of kill your servers before proceeding. So this is just to ensure that, your system is not taking up too much CPU and RAM space while we are running the Docker stuff. So just click on this red. And similarly over here, you can see if there are any other servers running. So you see this screen icon over here, click on that. You would see this drop down. So also I would go to accounts and I would kill that as well. So this ensures that my server is killed, and I can also verify it through Postman. So now if I go to Postman and execute post API call to either my cards, it will throw me error connection refused. And similarly for my accounts, if I run and it is throwing me connection refused, right? So this means our server is stopped right now. So that was step 1. So if your service already stopped or you had restarted your machine in between, like, things like that, so that is fine. So this is just a optional step which is recommended just to ensure that, we don't run into any system slowness and things like that. So the first thing which we have to do, well, before starting our Docker conversion is we have to install Docker, right? And also create an account with Docker. So I've already installed it in my local machine. So you can see over here that the Docker desktop is running, and I've also signed in with my credentials, but I'll just quickly show you how you can do it. So for that, all you need to do is just go to Google. And so once you open Google, just type Docker. You see this docker.com website. So here you'll see a link that download Docker desktop. Just click on that, install it. And once you install it, the installation is pretty straightforward. There's not much of options to select. You just give next, 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 finish. Just the normal way how you install any of the application. And once you have installed it, the second thing that I would recommend is come back to the docker.com website. And there is a link over here which is says sign in. So click on that. And here you just create a new account if you don't already have a Docker Hub account. So I hope most of you would not have an account already. So I already have created my account and this is the ID. So you can just take a like, you can just create one account with some ID. Like your ID is just similar to your email ID. It has to be unique. You cannot have the same ID. So you can just give your name 123 or whatever you want, and you can create your own Docker account as well. So creating the account is quite simple. You just have to just give any account name that you like, and you have to give your email ID and password. And once you log in, in your email you'll get a verification link. Click on that link and you're good to go. So once you do that, you'll see that you're able to log in like this. And similarly in your Docker desktop application, over here you'll get an option to sign in where it will take you to this website. You complete your login formalities and it will allow you to log in right here. So that's it. So this is the step 1 which you have to do, which is installing the Docker desktop and creating your account in Docker. So once you are done with that, so now you'll notice that when I create my Docker account, it takes me to a website called as hub.docker.com. So as I said earlier, this hub.docker.com or the Docker Hub is the place where we actually kind of share the images. So as I said earlier, a few of the common libraries like, MongoDB is a NoSQL database, Nginx is a server, Alpine is a operating system, Node.js is a runtime environment for JavaScript, Redis is for caching, So all these popular applications have already created their own images. So what the advantage of this is, so say if you want to create a Docker application using Node.js, you can simply download this image and create your applications on top of it. So it will reduce some initial setup and all those time for you. And similarly, you can also have an official Ubuntu image and things like that. So this is the Docker Hub. And in order for us to kind of host and share our repository with the outer world, we have this link called as repository over here. And in the due course of time, we'll be creating our images and pushing into this repository. Okay. So that was pretty much about the Docker. And once you have installed Docker successfully, there is also a way where you can kind of verify if Docker is up and running and working fine. So the step one of that is if you come into your Docker desktop, you will see over here that you see this images and containers, which means that your Docker service is up and running. In case if you face any error like Docker is unable to start, or like Docker is starting but it's not starting, I would recommend that you kind of just reinstall the Docker application and restart your application, restart your computer once. So that will kind of resolve most of the issues which you may have. And in order to verify if your Docker is installed properly in your local system, you can just open command prompt, which is just type cmd. In the start, you will get this. So here, just type Docker and just give double hyphen version. So this will say that the current Docker version which I'm using is 20.10.17 and build is this. So this means that Docker is working fine. And similarly, if you just want to know what are the various Docker commands available, you can just hit Docker. So that will give you the list of all the commands which the Docker supports. And we will be using a few of these very regularly. So don't worry, we'll also be looking into what are the commonly used Docker commands which are there. So with that, I think now it is kind of a bit clear that we first need the Docker desktop. So this Docker desktop is nothing but the same Docker containerization engine which we saw in the architecture in the last session, right? So I told you guys that on top of your operating system you install a container engine. So this is Docker desktop is nothing but that is the same stuff. It gives you that environment for you to create your image and run your container. So now we come back to the Eclipse, and now first we will convert our accounts services or the accounts microservice into a Docker image. So before we do that, we also need to understand how do you typically create a jar file for your application in a normal setup. So assume that if I have to deploy these accounts in a server without Docker, right, in the normal way, without containerization, microservice and all that stuff. So how will I do that? How will I create the jar for any microservices or like jar for any Java application? So for that, normally what we do is we go into Maven, we just do clean install, and it kind of creates the jar for us inside the targets folder. So inside this target, you will get the jar file. So let's try to see how it works. So what I'll do is I'll just go to the accounts project, and inside that you will locate a target folder. So what I will do is I'll just open this target folder. So to do that, I can just right click, show in System Explorer. It will open a new Windows Explorer for me with this target. So for now, I see there are a few folders created. What we can do is we can just simply delete it. So this is an optional step. I'm just showing you how normally a jar is created for any Java application. So what happens is this jar is then taken and deployed into your Tomcat server or any of the server. And that's what even happens here when you kind of start your server. So first your Eclipse will create the jar out of this application and then deploy the jar into a Tomcat server which is locally hosted. So in order to create the jar file, we use a build tool called as Maven, Apache Maven. So and we can just execute Maven clean install. So easier way to do that is you can just right click on this accounts over here, right? And here you will see run as option. So just click on this Maven build. So this is taking some time. Yeah. So you will get a window like this, which tells you that, what do you want to run. So in the goals, you will have a field called as goal. So here you can just specify clean install. Okay. So what normally happens is if you have to directly create a jar, you can either go to command prompt and give mbn. So if you have to directly do it, the other way to do it is I first just go to the accounts folder. I just open the command prompt from here, and over here I can just execute mbn clean install. So instead of doing this and install, in order to run this mbn, you have to ensure that you download the Maven dependencies from Apache website and add it to your class path and all that stuff. So in order to avoid that, I'm also doing it easily through this Eclipse. So wherein if I just right click on the accounts, run as Maven build, I can just give clean install over here. MVN is added by default because it is a Maven build, right? So I just need to do that. And once I just give apply, so the next time when I do it, I just have this automatically. And now I just give run. So what happens is now the Apache Maven build will start and it will create the jar file for this account. So you'll see that this build process has started. At first it will download, and this is nothing but all the dependencies. Every time we say dependencies, right? So these are nothing but the dependencies. So the Maven will first download all the dependencies, plugins, and all the other libraries which is required, and then it will start compiling your application code, and then it will further do some testing. So if you observe, there is a folder called your test, so where we can also write test cases. So what is test cases is nothing but based on the functionalities you write, you could also simulate it and test whether it is working as expected. So your Maven, before doing the build, it will also kind of do test on this particular application to ensure that all the test cases are passing. And once everything is done, it will then compile it into a jar file and place it inside the target folder. So if you remember, we had cleared all the contents from the target folder. So now you see that the test cases are running. You see here the test is running, and now the test is done, and now it is kind of packing it up. So all the applications are libraries and everything is getting packed into a jar right now. So if you just come to the target folder right now, so it is again created a set of folders. You see that the folders are getting created, and finally now you see that a jar has been created. So if you just observe the name nomenclature, accounts is nothing but the name of this application, and 001 is nothing but the version of the build version, and snapshot means that it is just a build version or a release version, and that is a standard convention that we follow. So now what has happened is this Maven clean install process is now kind of building this jar file. So it is not yet done. You see that in the console it is still running. So it has started the creating the jar file, and once it is done completely, you will see in the console that it built success, and it will say like in what time it completed. So based on your system speed, it might take anywhere between a few seconds to couple of minutes and so on. So now you see that here in the target folder, a jar is created, and it is like almost of the size of like 40 MB or so, right? So this is how you create a jar file for any Java application, and now what happens is this jar is then deployed into a Tomcat server for your application to start running. So this is how we do it in the normal way. So now let's understand how we can now create a Docker image out of this. So for that, what I will do is first I will go into my pom.xml. So in my pom.xml, you see that here there is a tag called as version, right? So in this version, what I've defined is 0.0.1 snapshot. So that means that whenever a build is created, this will be the version of that particular build. So that's why you see in the jar file the 001 snapshot is getting added. So that is coming from here. So whatever you change over here, it will be coming over there. Okay. So why this version is important is if you have multiple features or multiple versions of your application created, you can easily differentiate which jar belongs to which version type. Okay. So is it 1, 2, 3, 4, so on and so forth. And below that, and also there will be another a property which we have to check over here. So just check if there is property called as packaging. I see that this packaging is not present in the pop.xml, so we need to add this packaging. So by default, like mostly we use jar as a packaging file for any Java application, so we need to add that. So what we need to do is just below versioning, just give enter and type packaging, and inside the packaging just type jar as like this. So what we are telling over here is we are specifically mentioning to the Apache Maven that anytime you compile this application, always ensure you do it in the jar format, because for Docker, we will be using jar packaging. Okay. Okay. So that is the step one. The step two, in case if people are interested, we have now created our jar file, right? So inside this target, you see that, the jar is created. What if we want to just test our application if it is working? We can just open the command prompt inside this target folder. So how you open it directly, command prompt is just go to the address bar and type cmd and press enter. So automatically a command prompt opens with the same folder location. So if I want to now execute and start my application server, right, all I need to do is I can just give Java. Okay. And after that, I just need to give -jar. And then I just specify the jar name which got created over here. Ensure that you give accounts -0.0.1 snapshot jar. Okay. And once I press enter, this will now deploy this jar into the Tomcat server, which is already provided by Spring. That's why you see the Spring over here. So what happens here is I'm not installing any server or things. Since my Spring already provides a Tomcat server by default, it will use that Tomcat server to start this application. And if you're doing it for the first time, you might get any Windows Defender alerts like this, which may say it has blocked some features and all that stuff. So what you can do is just give allow access. So that will ensure that your server is working fine. Okay. So without this, your server won't work properly. So just ensure you give allow access. And once you have done that, you will see over here at the last line, there is a line called started accounts application in this seconds, which means that it is successful. Your application is up and running. And how to test that is just come to Postman. So just come to Postman and just execute test this API 80 accounts. So if everything is working fine, you would be getting a response. So you see that we are getting a response now. So understand that we are not running our application from Eclipse this time. So our server is down. We are not running from here. But rather what we have done is we have first kind of built the jar package of our accounts application, and that jar application we are executing it or running it through the Tomcat server, which is provided by Spring default. And the command for that is java-jar- the jar package which we got created. So this is how your application works in a normal scenario. So this I just showed as a quick demo just for your understanding. So this is not required as part of the Docker image creation. So, and if you want to just kill the server, all you need to do is just give Control C a couple of times. So it will just say shutdown completed. That's it. So you have killed your server. And if you come back to the Postman and execute it, now you'll get an error because we have killed the server, right? Yeah. So that was just a quick detour just to show you how you can run your Java jar application directly in the server, right? So now coming back, so the first step which we did was to kind of just create the jar file which we have done for the Docker image. The second step is inside the accounts root folder, right? So now occasionally you might see this red icons over here, right? On the POM XML because we just recently updated the packaging. So I think it has not updated the configuration automatically, which might happen sometime. So in these kind of scenarios, what you need to do is if you see this red icon across red icon inside any of your project, anytime during the course, just right click on this, go to Maven, then go to update project, then just click on the project which has this red icon and just ensure you select all the three options below: update, refresh, and clean. Give OK. So what this will do is your Maven will just flush all the old cache and everything and will just update your refresh your application. So you see that it showed building and now you see the red icon is gone. So always ensure that there is no red icon in your projects. Okay. So now what I will do is, so I'll just minimize the cards for now, just to avoid any confusion. So in my accounts root directory, right? Root directory means in the top level. I'm just clicking on this accounts and I'm going to create a new file. Okay. So the name of this file is Docker file. So this is the standard convention name. So this is the same name which Docker uses, and ensure that there is no extension given and the F is small. D should be capital, F should be small, single word, Docker file. And I create it at the root of accounts project. So you see over here. So anytime it asks you for any editor and all, just give cancel. That is fine. We can just open it directly over here. So this is the the default Docker file, which kind of is required for us to kind of create our Docker image. Okay. So the next thing is we have to now define what is the base image or the environments or the other images, default images, which we need to use. And then we kind of create our Docker image. So remember when I showed you the Docker Hub website, I told you that there are a few pre-built stuff which is already available so that we don't have to really install and create them from the scratch. So say for example, since we are going to create a Java application, and to run any Java application, you need the Java JDK, right? Which is the base environment or the runtime environment on which your application runs. So you can click on this Open JDK, but remember that this Open JDK, which is normally used, is kind of now deprecated. So what it mean by deprecated is no longer maintained. New versions won't be released. So generally what we tend to do is here are the few alternatives, and the one which we normally use in the industry is called the Eclipse Temurin. So this is a Java JDK image. So what's the image is very simple. So when you want to install Java in your local computer, right, which I also kind of suggest that you do it. So what we normally do is we just go to sites we just search for like Oracle JDK or OpenJDK or any of those JDK softwares. So for example, if I just Google OpenJDK, so I can just come to OpenJDK and from here I can just install the OpenJDK stuff. But since the image for OpenJDK is kind of deprecated, so what we rather do is these days we install something called as the Eclipse Temurin. So this is an alternative open source Java runtime environment. So what you can do is in your local system, this is not required for your Docker image, but in case if you want to just execute any Java in your local system, what you can do is just go to this JDK, Eclipse Temurin, download Eclipse Temurin. And over here, you can just install the latest Java, which is 17, or you can also, for the sake of this course, if to be on the safer side, you can just select your operating system if it is Windows. And here in the version, you can just select the version as 11. So remember that we are working on Java 11 because still that is standard and supported by a lot of application. So we are working on Java 11. So you can download this JDK 11 dot whatever latest version it is. Just click on this, install in your local machine. So what is the benefit of that is if you want to just kind of check or run any Java commands from your local computer, you can do that. So if I just give Java, so here it is just showing me the list of all the Java commands, right? So for example, if I do Java version, so it is now showing the same stuff. So this is telling that this is OpenJDK version 11 and it is OpenJDK runtime environment. It is using Temurin. So I have basically installed the same JDK in my local computer. So this will ensure that you can run any of the Java commands from your local command prompt. Again, I'm repeating, this is not required for Docker installation process, but in case if you have not installed any JDK in your local computer yet, I would strongly recommend that you install this adoptm.net Eclipse Temurin. So which will ensure that you can run any Java application from your local computer. So coming back to the topic, so since we are going to use Java application, we have to have this official Eclipse Temurin image added into our image as well. So for that, the script or the command which we will type over here is from. So what from means is you just take this base image and then build your image on top of this image. Okay, basically it will install this OpenJDK from the image and then it will do the rest of the configurations on top of this. Okay, so from is the first word. After that, whatever is the name of the image. So in our case, Eclipse Temurin is the name, hyphen Temurin. So just copy it and paste it over here. And after that, we have to give which version number. So as I said, since we are going to use Java 11, so I'm going to take 11. Okay, so this will install the Eclipse Temurin version 11, right? So you might have a question that, how did you know that, I have to only install Eclipse Temurin and how will I know the name of all the packages? So don't worry, over the time as you gain experience, you will know that what are the various technologies you have to use for different things, right? So say for example, if we are going to use Python, just for example down the line, so all you need to do is just just search for Python libraries, and if this is the what you require, just you will give from and you will say Python. And after that, for versions, what you will do is you'll see what is the latest version that is required. So if you just need the latest version, you can just give the latest version. And if you need any specific version, you can also do that. Something like 3.9 or things like that. So this is step one, wherein we have now given Eclipse Temurin. Second thing, so this is more like a metadata. So wherein you can give who is the owner of this particular image and who is maintaining this image. So this is more from a versioning and metadata stuff. So for that we have a tag called or a script called as maintainer. Okay. And here you just give the name of the organization or the person who is owning this application. So in our case, the name of a bank is bank.in. So just a arbitrary name. So you just give bank.in, which means that this application is being maintained by bank.in. Okay. So the next thing, what we need to do is we have created now the application runtime, which is jar, right? So this is nothing but the application executable which we have created. So what we want to do now is we want to copy that jar which is present in the target folder into our container. So to do that, what we will do is we will write this command copy, then specify the path. So since it is in the root folder, first we'll get into the target folder, and from there we will mention the file name, which is accounts dot. And if you are not sure of the name, you can just expand this target and just do a right click on it and give copy qualified name. And now you can just delete this part. That's it. So this will ensure that you are giving the right name. So ensure that, after copy, you just give target slash this jar name as it is. Okay. After that, you have to tell what is the name of the file which you want to create in the container. And for that, we are just going to give the same name. Here, you don't need to give target because we are just placing the jar in the root folder of our container. Okay. So that is next step. So I hope it is clear. As I said earlier, our Docker image is nothing but it is our code plus all the runtime environment and dependencies which is required. So here first we have installed all the dependencies which is Temurin, which is the base. And after that, what we are doing is we are copying the jar file from our target folder into our container image. So that is the next step. The third step is we have to now execute this jar file, or rather bring up the server so that our application up and running, because your Docker won't know what to do with this jar. So you have to tell the Docker how to start the application. And as we saw in the command prompt, the way we start the application is we gave the command java -jar- this file name, right? So similarly, what we have to do is we have to tell the script, we have to execute this. The way we do that is there's a command called as entry point. So what entry point basically means is once your image is getting executed in a container, this is the command which you have to run. So here, instead of directly typing java -jar this thing, we have to basically segregate it into an array of commands. So first we will type java, ensure that it's all in lowercase. After that, a comma, again double quotes. Inside that you give -jar. Inside that, and after that again close that quotes and another comma and just give this name of this jar file. Okay. So what basically we have done now is we have done three things. So first thing is we have taking the Eclipse, the official Eclipse Temurin image from the Docker Hub. Then we are copying our jar file created in the target folder and pasting it inside our image. And then we are executing this command java jar accounts. And how it is executing this Java command is because we have installed this Eclipse Temurin in our container. Okay. So this is what we need to give at basic in our Docker file. Okay. So these are the three minimum steps. This maintainer is optional. I just wrote this here just to let you know, we can also define metadata. So metadata basically means that in simple terms, it is just like supplementary data about your project, right? So you can mention who is the owner of this application and all that stuff. So this is the basic information which you give inside your Docker file. And once you have given this, the next step, what we have to do is we have to again go back to the command prompt. So I will come back to my command prompt, or rather I will just go into my accounts folder. Okay. And inside my accounts folder, I will just open command prompt from here. Okay. So just ensure that you are in the root folder of the accounts project. Okay, you should not be inside target or any other folder. You should be in the root folder because that is where your Docker file is present. So ensure that you are present in the folder where your Docker file is present. Okay, so in this path, right, in your command prompt, now we have to execute a command called as Docker images. Okay, so what Docker images will tell you is it will say that what are the images which is already present in your computer. So far we have not created any image. That is why you see that this is empty right now. And same thing you can also verify it using your Docker desktop. So once you click on this image, you will see that this is empty over here. Why it is empty? Because so far we have not created any images. So that's why it is showing as empty. So this is just a verification, just to ensure that that now whatever you are going to create, this will be the first image, and you can also verify it that it actually got created, right? So the process to create a Docker images, it is simple. So just give Docker, then build, then dot means you create the image from the current folder. After that you give -t. T is nothing but the tag means that this image whatever you're creating, you're giving it or assigning it a specific name. Okay, and also ensure that after this the name that you give should be the same name as your username over here. Why? Because after this, when you push it or upload it into your repository, you'll be kind of hosting it in this name, right? So in my case, it is bankin123. So what I will do is bankin123 will be the name which I give over here. So in your case, just replace this with whatever user ID of Docker which you have created. So in case, for example, if your user ID is Charlie123, so you will, instead of bankin123, you will mention your Charlie123. And always ensure that, whenever in this course I have any command or any configuration having bankin123, replace it with your own user ID. Okay. And this will be unique for each of you. So once I give this user ID of Docker, after that, I will give the name of this application, which is accounts, right? So this, whatever name you give over here, accounts, same name you have to mention over here. Okay. And once I have done that, I just need to give enter. So now what Docker will do is it will start creating the Docker image. Okay, so now it is telling that it failed to solve the front end. Docker file cannot be empty. The issue is that we have not kind of saved the Docker file. So just ensure that you save Docker file, give Control S or go to file and save it. So once you do that, just come back and execute this command again. So now you see that, okay, so it is telling there's a error with this entry point. So for that, what we need to do is just give a space over here. There was a typo and just re-execute the command. Okay, so now you see that this command is executing, and you see that internally Docker is now creating the build image. So what is happening right now is Docker will be taking your jar file, it will be installing your Eclipse demo run, it will be setting up all the environment, and once all that is done, it will be like packaging all of it into a single container, and that is what is happening right now. And since we are doing it for the first time, it will be actually downloading the Eclipse demo package image from the hub.docker.com and doing all that stuff. So the first time when you are doing this, it will take some considerable amount of time. So you just wait for a few minutes. From the next time we build the image, it will be significantly faster because already you would have a few images locally cached. So it will only update the container with whatever changes you have, and it will be doing it. So meanwhile, as it is building the image, let's quickly recap what are the major steps that we have done so far. So the first step, if you have to create a Docker image in the traditional way, you first create the jar file. So how to create the jar file is you just right click on your project, just go to run as, just click on Maven build. Inside the Maven build, we gave the command of Maven clean install, right? We just gave the inside the goals, we just gave this clean install, right? So over here, we just gave clean install and we ran it. So once you run it, what happens is inside your target folder, you will get this jar file created. So that was step one. Step two, inside this accounts folder, we created a Docker file. So without any extension, just D capital F small, single word, we created this Docker file. Inside this Docker file, we gave this three important commands. So first we mentioned what is the JDK version which we are using, which is in our case Eclipse demo 11. Second, we said copy this jar file from the target folder into the container and give it the same name. Next, we said how to start our application. So for that, we use this command of entry point and gave our command. So I also showed you practically from the local command prompt that if you want to execute this jar, we just give java-jar-this. So same thing, we have just given it in the script format. So where we have given jar-jar and this jar name. That's it. And once you have done that, what you need to do is open the command prompt from the accounts root folder. And once you open the accounts root folder, you just execute this command, which is docker space build space dot, which means create the image from the current folder, -t, which is tag, and whatever image you create, give it this name. So backend123 is nothing but the hub.docker.com account name. So whatever name you see over here after you log in into Docker, give that. So why we do that, I will tell you, because once you upload this into Docker Hub, this will be the name of your repository going forward. So that's why just for standardization, I'm telling you to give this. And after that slash whatever is the project name. So in our case, it's accounts. So we are giving it as accounts. Okay. So now you see that this Docker image has been completed. So you see it is finished. So and in order to verify if Docker image is created, we just execute this command Docker images. And now you see earlier it was empty, and now you see that the accounts image has been created. Okay. So this is how you kind of create a Docker image. I hope it was simple. But for cards microservice, you'll also see a more simpler approach on how to create it. Okay. So now since we have our image created, the next question is how can we execute this image? Just like how we executed a jar and our server was up. So the next point now is how do we kind of create this, execute this Docker image? And even before we do that, right, I just want to quickly show you what is inside this image. Okay. So for that, the command is just give Docker image, okay, inspect, and after that, you have to give the image ID. So here you see that there's the image ID. You don't need to give the entire image ID. You can just give the initial few letters, like maybe first 2 or 3 characters, and your Docker will automatically find out which image are you talking about. So in our case, it is A03. In your case, it will be different. So just give the initial 2, 3 letters and give enter. So now you see that it has kind of given me a summary of what is my image all about. So if you just see over here, so first is ID, which is nothing but just a fingerprint of the build ID. The second is what is the tag name. So in my case, it is since it is accounts, and latest means it is the latest build. Okay. So if you keep on creating multiple builds, whatever is the last build will be having this tag of latest, and the rest of the builds will not have this latest tag. It will have none. Okay. And the next is you'll have this comment created and container config. So container config is like whatever is the container related configurations you have. And the one thing which I wanted to show you over here is like, it has now also having other things like, it is now having this entry point. Remember in the Docker file, we created that entry point. So it is having over here. And what basically it does is once kind of like, your application is up and running, like your container is up, it will execute this script. And similarly, as said, it also configures your environment variables. So you see over here, you have this env attribute and where it has configured all your path, Java home, lang. This is required for you in order to run your Java thing. So you see that, we have not done any of these stuff. Automatically, Docker has done all these things and now it has given you an isolated environment. So now the next step is we have to kind of execute this image in order to run our application. So how to do that is we just come to Docker, just type Docker. Okay. And now since we have to run the application, right? Run the image. So what I'll do is I'll give Docker space run space -p. P means which port I have to run. Okay. So here, normally we just specify one port, like, when it is running on your server, you just give one port. But in case of Docker, we have to give two ports. So I'll tell you why. So the first port that you want to specify, just give it as 8080. Okay. And the second port is also again 8080. And after that, we specify the build name. So in our case, what is the build name? You see over here, the image name rather. So in our case, it is backend123/accounts. So the same name you have to give over here. Okay. So now coming back, what is this two ports? So the first port that you see over here is the port which your clients or you would be requesting the server. Okay. So when I'll be hitting your server, I'll be hitting it with 8080 port. And internally, since I said Docker is again an isolated environment having its own setup and own ports and everything, inside that container, this application will be running in 8080 port again. Okay. So why we have two ports is, so to the external world, I can just expose one port which is 8080. But internally, I can have this application run on any port. So the advantage is like if say internally in this within the container, I don't want it to run on 8080, but rather maybe on say maybe 4040, I can do that. But to the external world, they will feel as if this application is running on 8080. So there are a few security aspects to it. So in case you don't want to really expose your internal servers, internal image port to the outer world and all that stuff, you probably have different port numbers over here. But generally for our demo, we will be having similar port on both the sides. So our application will be running 8080 port in your server or in your local machine. And inside the container also, it will be running on the 8080 port. Okay. So with that, now just give enter. So again, if you get any Defender notification, just check all the two thing and give allow access. So even if you don't get this, that is fine. But in case you get this, just ensure that you give allow access, or without that, your server won't run properly. Okay. So now you see that it has started the Spring boot server, and at the last line you see that started accounts application in 18 seconds. Okay. And to verify if my application is up and running, I just come back to Postman. Just go to this localhost 8080 post call, and I'm passing customer ID 1. And when I hit send, you see that it's returning me data. And also like if I give instead of customer ID 1, if I give customer ID 2, I get this, right? So, and before we proceed, I just want to quickly tell you one other thing. In the last week, we created a few dummy data, right? We kind of had a data.sql file where we inserted some dummy data so that like, when our server starts up, we have some data to test. So just one thing I wanted to tell you guys. So in the due course of time, we'll be testing a few combinations. So what I would suggest is in your data.sql file over here, earlier we had just given some random customer ID like 123 678 so on. I just want you to modify it as 11 and 22, just the way it is given over here. Why that is the case is in our accounts project, when we create the customer table, right? Customer ID is created sequentially, right? So it is auto incrementing. So the first time when you create, it will be for this customer, it will be 1, for this customer, it will be 2, and for this customer, it will be 3. Okay. And what we want to do is we want to have a mapping between this customer and card, because down the line in the project, like when we will be creating other functionalities, we will be having a scenario where we want to fetch the details of both accounts and cards for a single customer ID. So that's the reason I just recommend that, in the data.sql file, you just ensure that, you just have one, like for one customer ID, you have one credit card and debit card. For second customer ID, you have one credit card and debit card. So just ensure that, you have the same configuration. And in case if you have not like, done it earlier, I would recommend that, you just do this configuration and just repeat the process that we have done so far, which is first create the jar file, then add the Since you already have the Docker file, you don't need to recreate the Docker file. After that, just create the Docker image. So using this command, right? So we had this docker build hyphen dot hyphen t, just create the Docker image, and finally just run it again. So just do docker run hyphen p 8080. And so that is just for to ensure that you just revise this step one more time. Okay. So now you know that our server is running and it's also returning the data. So that's why you see that even if I change the parameters, so it is executing and giving me the data, which means the server is up and running. So to kill the server, what I can do is the same thing, Control C a few times, and it will just kill the server. And in case if it is not killing the server, or what you can do is you can just come to the Docker desktop over here. So if I come to Docker desktop, you see that in the image it is telling it is in use. Why it is telling in use is because now it is running in the background, right? And if you click on the container, you will see that it has created a new container. Don't worry about the name; it just assigns some random name. So the first one is kind of a adjective, and second is some name. So you see some crazy names coming over here. And now it says that the status is running and it's running on the port 8080, right? And if you want to stop the container, you just give stop over here, and now it will stop. That's it. So you can also kind of manage your Docker desktop, Docker images and container through the Docker desktop app or through the command prompt as well. Okay. So with that, what we have done now is we have just kind of stopped the container. And one more thing which I will strongly recommend is whenever you are done, using your applications and you don't require a container, I would recommend that you delete it. Why is that the case? Because now if we create a new version of this accounts, so what happens is you won't be able to delete the previous version unless the container which is it is using is not deleted. So what I would recommend is once you have used your kind of the Docker, you have tested your application and you are all good. So I would recommend that if you are not no longer going to use it or you are going to update it in the future, just ensure that you delete the container which got created automatically. So don't worry, your data and all will not get deleted because since we have created the image and the image is where all the things reside. So this is just a runtime environment that gets created. So how to delete it is you just select the container, either give delete or delete, anything works. So just give delete, delete forever, and that's it. So container got deleted. And now when you come back to the image, you will see that this in use tag is gone. So the advantage is if I want to delete it now, I can delete it. We won't delete it now because we still have to push it to the hub.docker.com. So how to do that, I will show you. So there are two ways on how you can push your kind of image to the hub.docker.com. So either you can do it through command prompt or you can directly do it from here as well. Okay. So this is a simpler way. So you don't really need to remember all the command docker push this that. You just directly give here push to hub. Okay. So now what happens is this image is now present in your local machine, right? And what if you want to share it with one of your friends? So in order to do that, what Docker Hub will do is it will push this image now into the hub.docker.com, wherein your friend can search with this name and he or she would be able to now download this image and run it in their local Docker desktop application, right? So that is the beauty of pushing any any images into the hub.docker.com. And the first time when you are doing it, your system might get a bit slow. I don't know, it might not show something because this is kind of a resource intensive task because it has to almost push 400 MB data something to the remote repository. So this might take some time. Okay. And before we proceed any further, I also want to show you a few commonly used Docker commands. So whatever we saw so far was Docker build, that was to create the image. Then we saw Docker run, which is kind of executing the image. And then we saw Docker inspect, which is to just to see what is your Docker image all about, right? And similarly, if you want to start this, you want to start a already existing container. So we have already deleted it from here, but if say assume you have a container which you want to start, you don't want to create a new container, but kind of just execute the existing container. So in that case, we have this command called as Docker start. So what you basically do is you just give Docker start space whatever is the container ID. So similar to your image ID, you will also have container ID. So just give that container ID and it will just show you all the things. And similarly, if you want to know what are the containers that are running currently, so we have a command called as docker ps. So this will tell you all the containers which are running right now. So here from here you can fetch the container ID. Since we have deleted the container, that's why it is not showing over here. And similarly, if you want to know the logs, you can also do docker logs. And from here, after this, you have to give a container ID name. So just like your how you see the logs in Eclipse, you can also see the logs in the Docker in real time. And if you want to see it in real time, you can just give tag of -f, so which will just kind of update the log as and when the log is getting created, right? And whenever if you want to stop any container, right? So you just give docker kill space the container ID. So this will just kill the container. And you just want to know, like, what are the stats of the doc, like how much memory it is using, how much CPU is using, all the stuff. So you can do this. So it will tell you like which container is using how much CPU, how much memory and all. So for now, we don't have anything running. That's why it is seeing is that empty. To kill it, just give Control C. That's it. Okay. So to clear the screen, just give CLS. In Windows, for Linux, it is clear. Yeah. So now you see that, this Docker image has been pushed. On the top, you see a notification that latest digest in red color. So if you see it in green color, it means that, the image has been pushed successfully. How to verify it is you just click on this remote repository over here. So now you will see this accounts created. And similarly, if you just go to the hub.docker.com, so initially there was no repository when you clicked on repositories, right? So now when you refresh it, you will see that, your account image is now present. So if your friend or anyone wants to, like, now use this image, all they need to do is just go into this address, which is hub.docker.com repository docker backend, or search from here as well. If they just search for backend123/accounts, they will get this image. And now they can kind of download it and use it, okay, because it is public. And if you come down, you'll see that, this is the latest version and it is running on Linux. And you may have this question, why it is running on Linux? Because as I said, your Docker container is a virtualized environment. It is a system on its own, right? Though it is sharing the resources with the base computer, it is a very isolated environment of its own. So that's why it uses its own Linux operating system internally. And it is kind of setting up the image and creating your application, doing all that stuff. And yeah, so that's pretty much about it. So this is how we kind of create a Docker image using a Docker file. So for cards, I will show you another approach which is quite easier. So instead of doing, like, creating a Docker file and giving all the script, we will see another approach using build packs, where we can just, using a few series of commands, we can quickly create this image and get our cards application up and running. So both of these approaches are fine. The one which we just saw using Docker file is kind of slightly outdated because it involves a bit of manual work. So the more modern approach of doing it is using build packs. So I hope you understood how you create a Docker image using Docker file. So what I will strongly recommend is, just as I said, just ensure that, in your data.sql file, you have, like, you have the data as it is shown over here. So say for cards microservice, just have the value as 1122. And in your accounts data SQL, just ensure, like, the test data that you have entered is similar to what it is shown over here. So just ensure that and just recreate the image of your accounts once again, right? So this is just for your own testing purpose. So what you can do is, if in case your Docker is running, just stop it and just follow the same steps again, right? First create the jar file, and then you already have the Docker file, no need to recreate it. The third step is just give docker build -t the tag name and just execute it. And once it is done, just push the Docker image into the remote repository. Okay, so just do that, and in the next session we'll be seeing how we can create the image for cards, and we'll just revisit the Docker push pull and everything once again, so that the concept becomes very clear for you. Thank you, and looking forward to see you in the next session. Bye, and welcome to this third session of the week 4. So far we have looked on how to create a Docker file, rather a Docker image, using the Docker file, and how we can, once we create the Docker image, how do we run it, and also how can we push it into the Docker Hub. So in this session, we'll understand how we can optimize that approach rather than writing all this Docker file content and creating the jar files ourselves and doing all that. Is there a way by which we can better optimize it? And the answer to that is yes, we can do that by using build pack. So what is a build pack? A build pack is nothing but it's a tool which converts an application source code into an executable container image directly. So it does not require any intervention from you in terms of writing a Docker file, or manually you first creating the jar file and then doing the Docker build and so on. So the greatest advantage of this is, like, it does all that heavy lifting for you automatically. And there are many build packs which are available in market today. So earlier it was kind of introduced by Heroku, but now we have, like, a lot of vendors or a lot of tools which are doing this build pack for us, offer different programming languages. Like we have build packs for Java, Python, so on and so forth. And also build packs can be grouped together to form a builder which is independently looks for a specific file in the code and based on the configuration decides whether to participate in the building process or not. So an example of this would be, so say like, you are developing a very big application and it has a lot of separate independent parts. Maybe one part is using Java, one part is using Python, one part is in Node, so on and so forth. So all these build packs can be like, it can have its own build pack, and you can also group all this build pack together to form a builder. So what happens is, if there is a specific release or a specific update which you want to do, wherein you just want to build the image for Python and ignore Node.js example. So in those kind of scenarios, you can also do that using this builder concept, where you can decide which parts of your build pack will be participating in the build process and which you can ignore. So for the purpose of this demo, we'll be using Paketo build pack, because Paketo is an open source build pack implementing cloud native build pack specification, and it is backed by Cloud Foundry Foundation with the active involvement and support of VMware. And also Spring Boot supports Paketo build pack. So that's why we'll be using Paketo build pack for generating a Docker image. Okay. So what we'll do now is we will convert our cards microservices into a Docker image by build pack. So remember that for accounts, yeah. So remember that for the accounts, we had created the Docker image using the Docker file. So I'm not going to convert that. We will still keep it as it is. So, and also in the future, whenever we will be creating the Docker images, for account, we will be following the Docker file approach, and for cards, we will be following the build pack approach. Okay. So how do we create a image using build pack? It's very simple. So before we proceed any further, I just want you to quickly take you to the buildpack.io site and show you what buildpack is all about. So this is the homepage of buildpack. So this is the cloud native buildpacks, wherein like, it just talks what is the thing. So as I said, Heroku was first the pioneer of buildpack. So Heroku is one of the cloud providers, right? And after that, they partnered with Pivotal, and from there on, it kind of like, they started giving cloud native build packs. So basically, in simple words, build pack is nothing but it just kind of helps you to like, automate a lot of stuff behind the screen, and it helps you to quickly convert your application code into images and run on any cloud, right? So this is the build pack all about. And if you come to this registry of build packs, so again, as I said, there are a lot of build packs which are available, right? So here you can search like any number of build packs that is available. So as I said, we are going to use Paketo. And so you see that, all these different build packs which are related to Paketo is now being shown over here. So like, all these languages are kind of supported by Paketo build packs. So yeah, that was pretty much about the build pack stuff. So coming back, how do we kind of create a Docker image using build pack? So now what I'll do is I will just ensure that, if there's any Docker image or container running, just ensure you kill it. So just to check it, you can just come to image. You should see that it should not be in use, and here in container, there should be no containers present. Why that is the case? If over the time you create a lot of containers, then it will be difficult for you to delete the older Docker images as you create newer ones. And also like, it will impact your RAM and CPU utilization. So it's always better that you kill any of the existing containers before doing another stuff, unless it is required. So the first step of kind of like, starting our build pack journey to create the Docker images, as usual, just come to the cards project. So just come to the cards, just come to the pom.xml. So if you come to the pom.xml, we just have to do a very simple kind of like, configuration in order to add it. So what I will do is I'll just come to the end of this pom.xml file. You'll see a section called as build. Okay. So this is where I'm going to add my configuration. So under this build, you will have this configuration tag. So what I'll do is I'll just click on this end of this configuration tag, and I'll just press enter. After this, I'll just leave a couple of spaces. So just to align it with the excludes. And here what I will write is I will just type image and then press enter. After that, I'll give name. So this name is nothing but the name of the Docker image which we have to create. So in our case, the name that we follow, if you remember from the previous example of accounts, is we first give our Docker user ID, which in my case is bankin123. In your case, it will be your user ID. And that you can find it by going into hub.docker.com. Once you log in, the name that you see over here, right? So this is the name you have to give. Alternatively, you can also see it from your Docker desktop. So this name over here is what you'd be giving. Okay, so that will be the first step. After that, you have to then give a dollar and open close curly braces. So what it means is here we are going to specify a variable. We are not going to hard code it. So rather we are going to specify a variable. So here we say project dot artifact ID. So what it means is whenever our Docker image is getting created, so automatically the name of that image would be bankin123 and project.artifact ID. And what is the artifact ID over here? Project.artifact ID is nothing but in our case it will be cards and after that the version number. So that is what we tell by this. So the advantage of this is we don't really need to hard code this. So in case even you have to in the future you change your name of this project to something else, you don't need to come back here and update it. It will automatically take it from whatever is the current value, right? So this is the only change which we need to do right now. And once we have done that, just ensure to save this. And as you can see, like whenever and since we have opened this image tag, ensure that you have to close it at the end. So just come to end of the artifact ID and here first ensure you close the name. So always ensure that in XML that whatever tags you open, you have to close it in the same order. So first we add image, then name. So in the when you close it, so first you close the name and then you close the image. Okay. So just ensure you do that. And after that, you see that there's an error over here. Okay, it says that there is some issue with closing this tags. So let's quickly check it. Have we made any typos or something? Okay, so here by mistakenly there are two curly braces, so that's the issue. So remove that, save it, and once you save it, you see that the error is gone. So always ensure there is no error in your pom.xml when you do these changes. So that was step number one. So just to update it again, so the concept is just come to your pom.xml and inside your build configuration, there will be a tag called configuration. So just come there and add these three lines, which is image, name, and here you specify that your Docker Hub user ID, which is bankit123, and after that just give the project.artifact ID, which is nothing but in our case cards, and after that the version, right? And after that just close the name and image ID, and that's it, you're done. So always ensure this alignment is also the same way that I've shown over here, because then it is becomes visually easy for us to identify which tag is where and where it is nested. So this was step number one. Step number two is very simple. So just the way we created the jar file using the maven build command. So here we won't create the jar file, but rather we will be executing another command, which is Spring Boot build image. So how to do that is just click on this cards folder, root folder over here, right click on run as, and here just click on maven build. You will get this window open. In the goals, what you need to specify is spring-boot. So your Spring Boot gives this command out of box for you to create the build image, because as I said, it is using Packito builds behind the scene. So it supports automatic creation of Docker images. Okay. And in that you will say Spring Boot colon build image. So what happens is now once you execute this, your Spring will automatically create the jar, define what are the requirements that is required, and whatever scripts you gave inside your Docker file in accounts, right? Like you mentioned, get Eclipse demo and do this, then execute the entry script as jar, java-jar, copy the jar folder and all that. So instead of you specifying all that, now your Spring will automatically determine what is required based on your pom.xml and other stuff and do all that thing. So now what I will do is I'll just and in the name on the top, I'll just give it as Spring space build. So this is just for future reference and apply. So every time I don't need to type this, next time I can directly go and execute it, right? For that. So just give run. So what happens is in the console, now you'll see that Maven will start building our Docker image. So you see that it's very quite easy. All we did was just added this line to our cards project and just executed Maven Spring Boot build image. That's it. So now you'll see that the same thing happens here as well. So your Maven project will start first download all the dependencies, then it will run the test. And once the testing is done, it will then build your Docker image. And one more thing to notice, since our application is not big, the test is running quite faster. But in case you want to disable the test, which is not really recommended, you can also do that. So you can give an additional parameter in your run configuration after Spring Build as -d skip test true. So that will just skip this test altogether. So it will might save you a few seconds of build time. So for us, unless the test is failing, we will just keep it running. So even in your real projects, it's always better that you write test cases and execute it before, like, building your image. So here now you see that, automatically now the Spring Boot is downloading the Docker IO package to build packs from the hub.docker repository. And now it will create your cards image. So that's what I said, right? Based on whatever dependencies required, it will automatically first download those images from the Docker IO site and then create the Docker image for you. So since we are doing it for the first time, this Paquito build is getting downloaded for first time. It will take some time. So just like how in the accounts we created for the first time, it took some time. So even here, when it's building for the first time, it will take some time. But the subsequent builds might be slightly faster. Okay. So till this gets built, let's quickly recap the few basic concepts we have learned so far. So this is just to ensure that the concepts really stay in your head. So the first thing we understood that instead of you every time creating a jar file and deploying it into a server and doing all that thing, it is better that we kind of create a containerized isolated environment of our application and which we can run across any environment and any platform. So that's the concept of container, wherein like you give your own isolated container environment to your application having its own configuration which is standardized. So the same application will behave the same way no matter which server or platform you run. And in order to create the container, you have something called as the Docker image. So what Docker does is Docker will first create a image out of your application dependencies and all the configuration. And this image, when you execute it, will be running inside a container, right? And this container is nothing but just a isolated environment within your operating system or machine. So which will be executing and hosting your application. So in order to create Docker image, there are two ways. One is you can do it using the Docker file, which we saw over here. So all you need to do is inside the root of your project, you create a Docker file. And inside this Docker file, you just mentioned what is the Docker image which you has to install. And then you say and before that, you first generate the jar file. How we did that is like right click on this account, go to run as, then give Maven build. Then inside the Maven build, you give the goals as clean install. So what you do is just come to the Maven build here. Inside the goal, you just give it as clean install. Just run it. Once you run it, inside the target, the jar will be created. Once the jar is created, then in the Docker file, you just say copy this target jar into the folder of container. So that's why you just give the accounts as it is. Then after that, you give the entry point. So entry point is nothing, but this is the command which will now start your application. So we saw even in the local, we saw right from the command prompt, we can just execute Java hyphen jar hyphen the var name, right? So once you give this, your application starts. So in order for you to execute this jar directly in your local, you just give Java hyphen jar hyphen accounts. So the same way, we just tell the Docker that once the application is ready, just execute Java hyphen jar and the file name. So this is what we copied. So this is how you do it in the normal way. And in the Paquito, the build pack world, we don't need to do any of this. Just come to your pom.xml. And in the pom.xml, you just define this image. And by the way, for your accounts, when you're doing it in the Docker world, and all you need to do is just ensure that, the packaging over here is mentioned as jar. So your Docker always uses jar file to create the Docker image. And in case of the pom.xml, for the cards where we're using the build packs, all we need to do is just add these 3 lines in your build configuration tag property. So wherein we just specify that when you create an image, give it the name of our user ID / project artifact ID. So this will be common for all of you. And this will be whatever is your username, right? So once you give that, after that, all you need to do is just go to cards, go to run as, go to Maven build, or you can also click on run configuration. So over here, you can just click on this cards over here, and in the goals, ensure you mention Spring Boot build. This is important. So just ensure you mention spring-boot build image. And here for your reference, you can just mention it as card spring build. So the next time you want to execute, you by this name, if you just click on this, this will get auto executed. And when you give run, automatically your Maven will start creating the Docker image. And now you see that, the build is success and you have created the Docker image. And now let's verify how we can verify our image. So one way of doing it is just go to your Docker desktop application, come to image. You will see now, there are multiple images created. The first is the cards which just got created, right? And the next you will see there are two extra images, which is Packito build image builder and Packito build image run. Why this is required is internally Spring Boot has installed these images so that it will be able to convert and execute your Docker images without you doing all the steps. Okay. But one thing which you have to notice is here now, since we are created using build pack, for accounts it shows that it was created 1 hour back, which is almost the time we created the image. But for cards it shows like it was created 42 years ago, and for builder also it shows it was created 42 years ago, right? So why this is the case is because this is some unique kind of behavior of build pack. So they are kind of like they don't follow the normal nomenclature. They just have some weird years, so you don't need to worry about that. Okay. So in our case now the cards is created successfully. So if you want to push it to your remote repository, you can do it, but don't do it right now. We'll also see how we can do it through command prompt later. Okay. So I just wanted to show how easy was it to create this image, and now if you want to run it, it is quite simple. Just go to your Docker desktop and click on run if you want, or you can do the traditional way of just go to your command prompt and you can just give docker run. So I'll just do the command prompt because it's always good that you know the corresponding command prompts as well. But anyways, even if you just google it or just do a I'll just give you another quick tip. If you just go to Google and type Docker cheat sheet, so you will get this official Docker cheat sheet, so which kind of gives you all the commands at your fingertip. So how to build, how to share, like how to push it into your repository, and how to kind of run it in your local. So all these kind of things, you kind of get it in a quick way. So in our case, what we need to do is to run this image. First, I will just check what is the image ID. So I'll just give Docker images. And after that, all I need to do is Docker run, then hyphen P means the ports. So for the external world, I will be exposing this in the 8081. But remember that internally our application runs on the 9000 port. How to verify that is if you just go to SRC main resources, application properties. Here we have given the server port as 9000. So what we will do is we will still run our application internally in 9000 port within the container. But for the outside world in our machine, we will be exposing it in the 8081 port. Why 8081 port? Because accounts we have already exposed it in the 8080 port. So we can't have two images running on the same port. So that's why I'm exposing it in the 8081 port. Okay. And after that, here now I need to give the image name. So in my case, it is bankin123. Here you will give your own user ID, whatever it is, /cards. Okay. And once I give enter, so the Docker will now create a container for this image and it will execute it. So now you see that it will start executing it. And once you see started cards application, so you can then go to Postman and check whether it is working fine or not. So just give it a couple of minutes for this to start fully. And once you see the started cards application in whatever seconds, so now you can come to the Postman, go to the cards API, which is localhost. Always ensure that this is 9000 because internally it is using 9000, but to the external world, here we have exposed it to the 8081. So in our case, what will happen is instead of 9000, now I'll change it to 8081. I hope you got this right. What is the point is 8081 is the port which the external world will access our application, but internally inside the container, our application will still be running in the 9000 port. So that is why here instead of 9000, because if you directly run the application to run in 9000, but since we are running it in the image in a container, and the container is exposed in 8081 port, that's why we have given 8081. And just ensure you pass the request body, and now when you click on send, you see that we are still getting the data. And if I change the request parameter, you see that still it is refreshing and giving me the data, which means that our application is working fine. And now just to refresh a few of the other Docker commands which we saw in the previous session. So just to refresh a few of the Docker commands which we saw in the previous session. So and since our Docker image is running right now, I'll just show you a few of those commands. So the first I said is if you want to just check the list of all the container that is running, you give docker ps. It will say what is the container ID, what is the image is running in the container ID, when it was created, what is the status, what is the port. So you see that for the computer it is exposed in 8081, but internally it is using 9000. And what is the name of it? Okay, so this name is some random name which generates, you don't need to bother. Similarly, if I want to just check the logs, right? So what I can do is I can just give docker logs After that, the container ID, just the first few characters. So here you see the container ID is 3E6. In your case, it will be different. So just give the first few characters. I'm just giving 3EF. And after that, I'll give -F just to update so that, 3E6. Yeah. So now you see that, this log is showing here. And if I just hit the application, right? So it will like, also dynamically update the log. So what I'm doing is I'm keeping the log over here and I'm making the postman call. So if there's any error or something, it will just like, update it over here. So that is one thing. To kill it, just give Control C. And similarly, like, if I want to inspect my Docker containers, I can just give Docker container inspect 3E6. That is my ID. If I give Docker inspect container ID, it will show what is the current status of my container ID. That is like, what is the network it is using, what is the network setting, what are the things that is running in it, what are the various build packs, what are the stuff it is doing, what are the other dependencies it is having. So everything, or the environment, what is the server port. So all those details would be kind of, I can see a summary of it over here. Okay. So that was pretty much about the Docker build pack. I hope you understood how easy it is to create using build pack. And in the future, for all the new microservices that we'll be creating, we'll be using the build pack approach. But I will be still keeping the accounts using the Docker file so that you can also from time to time revise how you do it with Docker file. So going forward, any build image that we'll be creating for accounts, it will be using Docker file. And for cards and other microservices which you will create, it will be using build packs. Okay. So the next thing, now let's understand how we can push our Docker image into the remote repository. So that is the next thing. We already saw a glimpse of it in the previous session where I directly did it using the Docker desktop. But let's also understand how we can do it using the command prompt. Okay. So as I said, the reason for pushing an image into Docker Hub is that, we can share our image with the outside world, just like how you downloaded the Eclipse, Temurin image and other things, Packito things from the hub.docker. Even you as a developer or organization might want to share a few images with the outer world. So that's the reason we kind of push the images to the Docker Hub. And in order to push the images to the Docker Hub, we have a command called as Docker push, for which we'll be doing it. But as I said, we can also do it through the Docker desktop as well, as I showed earlier. So in this session, we'll try to do it using the command prompt. Okay. So let's try to push our images into Docker Hub. So for that, the first thing I need to do is I'll just come to the command prompt, just give Control C if you have anything running. And after that, I will just clear the screen CLS. Now, what I will do is I'll just give Docker. Before that, just give Docker images because you'll need the image name and ID for the future. So what I'll do now is I'll just give Docker push, then docker.io. Why docker.io? Because this is hosted in the hub.docker.com. So that's why they use this website of docker.io. So this will be same for you as well. After that, what is my user ID that is created in Docker Hub, which is in my case is bankin123. Why I created bankin123? Because our name of our company is bank.in. So I just kept it as bankin and 123 because this name was already taken. So in your case, it will be your name 123 or whatever, right? So just replace that bankin123 with your user ID from Docker Hub. And after that, the image name, right? So for now, we are going to push cards. And before you push it, right, just when you come to the Docker Hub repository, you'll see that for now, there's only accounts which is pushed into the hub. We don't have the cards pushed yet. Okay, so this is just to verify, for you to verify as well. And also at the bottom, you'll see when it was last pushed. So this is just to ensure that, whatever you're executing is really working or not. So after you give cards, always remember that, you have to push the latest version. That's why you give :latest. So like, and anyways, by default, you just have the latest over here. So that's why we just have latest. So just give enter after this. So now you see that, it has started this process of pushing your image to the remote repository. So since this is like a big file, you see that, it is like 285 MB, and depending on your internet speed and your computer speed, it might take a while. So basically what happens is it kind of chunks your image into multiple streams and pushes it in parallel so that, this uploading happens quite fast. And the same way, if you have to do it through Docker desktop, I'm not doing it, just showing to you. So just come to your Docker desktop, click on image, and whichever image you want to push, just click on this three dot over here. And here you just give it as push to hub. Always ensure that, you're pushing the image with the latest tag. Okay. So we are almost done. Just these two things are remaining. So once this to transfer is completed, our image will be pushed to the Docker. So now you see that we have pushed the image into the remote, and if you just come to your Docker hub.docker.com website and just refresh these repositories, you'll see that now the cards image will also be present in the list, and you see it was last pushed a few seconds ago, which means it got pushed. And similarly, you can also check it in the Docker desktop. Just come to image, click on remote repositories, and under your ID you'll see that cards and accounts both are now present, right? So that's how you do it the manual way. So that's no really the optimized way and all. So if you like, you can just do it from here as well. So you can just go to the local and click on this and push it if that works for you, or you can do it from the command prompt as well. So both of the approaches are fine. So with that, we have come to end of this session. So in the next session, we'll now understand what is Docker Compose all about and the requirement for it. Thank you, and welcome to this fourth session of the fourth week. So now we'll understand what is Docker Compose all about. So Docker Compose is nothing but a tool used for running multiple containers in isolation, but allowing interactivity between them when required. So I'll just give a very simple example of this. So assume now we have accounts and cards. So how are we starting them right now? So we go, we give Docker run for cards, then we come back and another instance we give Docker run for accounts. So what happens is both of these instances are now running independently of each other. And we also have certain manual intervention where we have to manually go and start each of them sequentially. But imagine that you have now hundreds of microservices to be started. Like say in your banks, you have say 10 departments, and each department has like 100 functionalities. So you have to now start 1,000 microservices manually. So you can imagine the pain that you will have, right? You can't just go manually and type Docker run every image name, or go to Docker desktop and manually trigger every images. And also remember that I said every container is independent, meaning that it does not interact or allow anyone from outside to kind of share the data with it. So that's also a potential issue, because if you want to have kind of an interaction between a microservice, so say for example, which you'll be seeing in the future weeks as well. So assume that I want to develop a functionality where for a particular customer ID, I want the list of both accounts as well as the cards which are held by them. So those kind of scenarios, it is important that each of our microservices is also able to interact with the other microservice which is running in a different container. So in order to do all that, we have this utility called as Docker Compose, which is given by Docker. So what happens is Docker Compose is nothing but just a simple script file. It is written using YAML. So YAML is nothing but yet another markup language. It is a different data format, just like how you have XML, just how you saw the pom.xml, where we kind of write the tags and every data is arranged between it. So we also have JSON format, which you would have seen in the Postman, right? So all the data that we get is JSON format. And the other data format we have is YAML. So YAML is very simple. So the full form of YAML is yet another markup language. So it just simply kind of arranges your data in a visual, easy to read format. It uses alignment. So is all you need to do is just define all this configuration in a YAML file for Docker Compose, and we are good to go. So the greatest advantage of Docker Compose is it is a simple configuration, because since you're using YAML, you don't have to write complex XML or JSON configurations. You can run multiple containers on a single host at a single time. You don't need to manually manage and run every containers differently. And so the last part advantages also has security due to isolated execution of each container, because though you are able to bring up multiple containers at the same time, each container would still be running in its own isolated environment. So in that ways, your process and your containers are kind of isolated from the outside world, and so the security is still maintained. So now let's see how we can use Docker Compose for our accounts and cards microservices. So in order to for us to use our Docker Compose, so the first thing which I will do is I will just go to my Docker image over here, and I will first stop all the containers which is using it. The second step, as I said, if you're not going to start this image again, just delete it. So this is just to save some computation space in your local machine, because some of you might not really have the top end machines. So it's always recommended that once you're done with the image container, just delete it. And here you should see that all your image are not in use. Okay. So the first thing that we have to do for a Docker Composes, as I said, the main inspiration for having a Docker Composes, I don't want to individually start my microservice manually, but rather I want to kind of manage all of them from a single place. So what I will do is I just need to create a Docker Compose file. And how I create a Docker Compose file is I can just take any of my microservices. So it's not mandatory you have to create only in accounts. You can create even in the cards because it's just you're just going to create it for one time. So what I'll do is I'll just go into my accounts project, and over here I'll just right click and I will give the root folder of accounts. I'll just give write new, and after that I'll give file. So here I have to now create the Docker Compose file. So what I will do is the name of this file is Docker Compose.yml. Since it's a YAML format, so I'm going to giving it as .yml. So remember the name, it is docker-compose.yml. This is the standard name. You cannot give any other name. So ensure that you give the same name, and it should be created in the root of your accounts microservices. So once you do that, the docker.yml file will be created over here. And how you can update your Docker Compose YAML, I'll quickly show you the Docker docs. So manually it won't be possible for us to cover each and everything in Docker. So what I highly recommend is you just go to docs.docker.com, and for our case, since we want to check on Compose, so you can just click on Compose, and here you will see that all the Compose related things are there. So what you can do is just click on this Docker Compose, and over here you will now see all the documentation available. So this is a sample Docker Compose YAML file, and here it says what are the microservices to be started, and what are the things to be done. So what we'll do is we will also be creating a similar YAML file. And why I said YAML is easier to read, because as you can see over here, we are not kind of doing too much of writing unnecessary code. So whatever is the property colon the value, and if it is nested, we just give manual spaces like a 2 space or a 4 space based on the nesting it is. So it is quite easier to read compared to XML file or a JSON file. So what we'll do is we'll also create a Docker Compose for our two applications. So what I'll do is first I'll give the name services. So services means that you have to these are the two microservices which you have to start, and inside this I have to nest. So what I will do is I will leave 2 spaces by default. Okay. So what you can do is just give 2 spaces. After that, the first microservice which I have to start is the account. Okay. Then semicolon, and inside account again it will be a nested property. So I'll just give 2 spaces. Then I will mention the name of the image. So in our case, it is backend123. You have to put your own Docker user ID over here slash accounts. And I have to take the latest image or the latest version. After that, I will mention the port. So as I said, Docker uses 2 ports. So what you can do is for ports, you just ensure you just give this hyphen. Okay. So hyphen means you can give multiple parameters, right? So what you can do is just give double quotes. For accounts, let's start it locally at 8080, and even inside the container, let's start it at 8080. Okay, so that's what you have given in the application properties. After that, network, we will give a name. So this name is, you're free to choose any name, but for standardization, like just to follow along with this demo, you just give it as bank network. But once you are done with this demo, you can then free to give whatever name you want. So what is this network, right? So as I said, right, each of your microservices will be running independently. So accounts will be running independently, your cards will be running independently. But since we want to have some interaction between them, that is, if cards want to call accounts, how will it do it? So in order to kind of logically group multiple microservices into a single logical domain, we use this concept called network. Okay, so it's not like a physical network or something where actual connection will be done. So just like a logical grouping where you put multiple containers into a single logical domain. Okay, so first we'll give the name, and later down we'll define this bank network. Okay, so similarly what I'll do is next, under this same alignment of accounts, I will also create now for cards. So the same concept. So what I'll do is instead of manually typing it, I'll just copy it as it is, paste it. So ensure that the alignment is matching, and now I'll just kind of update it. So I'll say cards, and here port, as I said, locally we will start it in 8081, but since internally our application starts in 9000, I will keep it as it is, and networks will be bank network. Okay. After this, now we have to define this bank network. So means we are telling the Docker Compose that what is our bank network all about. So we just give networks, and inside this, we just give the name of the network which we have created, which is bank network. And for now, we are not defining any kind of configuration for this network. Let it take the default configuration start. So that's why we are not giving anything and just giving it as empty. and we see a few errors. So just ensure that you don't have any extra spaces in the new lines and the space between this hyphen and text are present. Just remove the space. So ensure that your services and network are in the same line, in the same column, and the accounts and cards are in the same column. All the subproperties of accounts and cards in the same column. So that is pretty much it. Save this. We are done creating our Docker Compose. So just to revisit what we have done. So Docker Compose helps us to kind of start our multiple microservices at the same time and also logically group them into a single logical group so that, if we have to call one microservice to another, we can be able to do it using the same network name. So that's why we are just defined the network name as bank network, and here we are just defined it as empty, meaning it will be just a default network. And here we can also define the ports of where each of the image will run. So in our case, accounts will be locally exposed to 8080. That is, we'll be hitting 8080, and internally also it will be using 8080 in the container. But for cards, we'll be hitting 8081, but internally it will be using 9000 as defined in the application properties. So we are done with this. The next step now is we have to now just execute instead of creating each, like running each Docker image individually. What we will do is we'll just come to the accounts folder, okay, to the root account folder where the docker.compose is present. And now what we will do is we'll just execute this one single command, which is docker compose up. So this docker compose up will just read the YML file which you have defined, and it will start all the services which is there. So now you see that first it creates the network, and once the network is created, the containers of for cards and accounts are created, and now it will be starting both the service in parallel. And also one more thing, in future, we'll be creating a few dependencies for each of these microservices, like we'll have some configuration server and other stuff. So in those kind of scenarios, what happens is if one dependency is not available for another service to start, it will kind of fail, but again, keep retrying. You can also define those policies, which we'll be seeing in the future course of time. Okay, for now, you just remember that Docker Compose is used to start multiple Docker images in parallel, and also you can kind of like logically group them into a single network wherein you can have communications between them happening. So now you see that our applications are started. So you see that started cards application and started accounts application. So to test it, just come to, there are two ways to do it. So first you just go to Docker desktop, you just come to here image, you'll see that both are now automatically in use, and container also you'll see that since we have created under the same network, that's why you see that there are two images present under the same accounts. Okay, so now what happens is we just go to Postman. First we will hit accounts is running in 8080, so that's why we've given localhost colon 8080/accounts. We have passed the query parameter as customer ID 1. Hit it, and you'll see that now we are getting the data. And just to ensure it's working fine for other data, I'm just giving customer ID 2, and you see that it's now returning for customer ID 2. Similarly for cards we have given the internal port as 8080. The port for the server as 8081. That's why I'm given as 8081/cards. Customer IDs, we can keep it as 2 as well, no worries. So now you see that it is returning me the data for customer ID 2, and similarly if I do it for customer ID 1, it is still returning me the data, which means our application's up and running and working fine. So with that, we have completed this week course. So I hope you understood what we have learned so far. So in quick summary, we have learned about why we required containerization and what is containerization. We understood the role played by Docker in containerization. Then we saw how we can convert the account microservices into Docker image using Docker file. Then we saw what is build packs, and we created a Docker image for our cards microservices using the build pack and pushed both of them to the Docker hub. Then finally, we saw what is Docker Compose and how it helps us to kind of start and manage multiple microservices together. So thank you for your time, and looking forward to see you in the next session. Bye. Hello everyone, and welcome to this 5th week of the microservices using Java, Spring and Docker course. This is the first session of this week, wherein in this week we'll be focusing on how we can manage the configurations using Spring Cloud. So let's quickly recap what we have learned in the previous week. What is containerization and the need for it? We understood why we require isolated environments and how we can run them consistently across any machines. Then we saw what is the role of a Docker and how it helps us to create the Docker image which can be run in any containers. We also created our Docker image using the standard Docker file approach, and also we saw what is build pack and created Docker images using build pack for the card microservice. Then we saw how we can publish our Docker images to the Docker Hub, both by Docker desktop application and by command prompt. And finally, we saw what is Docker Compose utility, wherein we can define how we want to start all the microservices together and also link them in a common logical network in order to enable intercommunication between them. So in this week, these will be the following major concepts which we'll be covering. So first, we'll understand what is the basics of configuration management. Then we'll understand what is Spring Cloud. Then we'll see what are the configuration options available in the Spring Cloud configuration. Next, we'll see how we can refresh the configuration on the go. And finally, we'll see how we can secure our entire configuration. So the learning objectives of this week is we will be understanding the basics of configuration management in microservices, how Spring Cloud helps us to manage the microservice configuration, how can we set up the config server for our banking microservices, how to update the Docker configuration post config server setup, refresh the configuration using @refresh scope and annotation, and finally securing the configuration using encryption. So going forward, as I said in the previous week as well, what we will do is we will take up one of the key challenges which we face while implementing microservices, and we'll see how Spring Boot project on a whole helps us to or the Spring project on a whole helps us to go through those challenges and help us to create a more better microservice application. So essentially whatever we do will be in two parts. So first we'll update our local configuration using Eclipse and Java configuration and make it run locally. And once that is done, then we will migrate that setting to our Docker image as well. So that will be the overall setup which we'll be doing in all the coming weeks. So wherein we'll understand we'll first see what are the few challenges which we face in microservices, understand how we can address them, then implement it locally in our Java application, test it, and once everything works fine, we will then move this to our Docker configuration as well. So first, let's understand what are the basics of configuration management. So Docker can be used to develop and deploy microservices across any environment. We saw that. But one of the key concerns which we encountered while managing the configuration of properties of microservices on deploying them to different environments would be as follows. So different configurations of properties can be managed across different environments for same application. So what we mean by here is, as I said in the previous week as well, we have multiple environments wherein our application goes through multiple level of development and testing before it finally reaches to the end user. So as I said, first we have the development environment wherein you as a developer would be setting up the application and all the setup in your local machine, creating the application, testing it with the dummy data and certifying that it works fine. After that, it goes to the QA environment or the system integration test environment where the external testers or the QA testers would be testing your application, finding the bugs and ensuring that it is working fine. User acceptance testing or UAT. So wherein a few business users would be testing your applications to ensure that it's meeting the business requirements. And finally, once everything is signed off and everything looks good, will it go to the production where you and me as end users will be using it, right? So what happens is, if assume that you're developing a microservice application which has say maybe 100 microservices and you similarly have 4 environments. So what happens is, so 100 into 4, you have 400 different configurations which you have to manage for each of the applications. So just think about it. Every environment will have its own different configurations, right? It could be either the IP address or port number of the servers which you're connecting. It could be the username, password of the servers or resources which you're connecting. It could be a server port. It could be some class path. It could be some other custom variables which needs to be updated or configurations which needs to be updated. So say for example, in the lower environment, you maybe want to have the logging set to debug. In the higher production environment, you just want the errors to be logged, so on and so forth. So what happens is, if we just follow the traditional configuration management where we just dump everything in the application.properties as we saw earlier. So if you remember, we saw how we can set the server port and other things from application.property file. So if you do that, what happens is manually you have to maintain so many different configurations. And also the other problem is, every time you want to make a change, you have to bring down your server, update this property file. Update the property file, bring down the server and restart it for the new property for the new configurations to take effect. The key challenge over here is, if you have a critical application, so say you have an income tax website or a IRCTC website where every minute thousands of people are logging in and doing a transaction. If in those kind of scenarios you want to update a configuration on the go and bring down your server, that is not really an optimal solution. So in these kind of scenarios, the best option is that you kind of maintain your configuration properties separate from your main application, which is also one of the 12 factors that we saw in the second week, right? Where we saw what are the 12 factors for an cloud native application. So one of that is we have to separate the configuration from the main application. That is, the configuration should not be bundled with the main application. So what happens is whenever the microservices starts, so these configuration or the properties will be provided to it during the startup process so that it can then configure it accordingly and start. And the configuration of the property should be managed in a centralized repository with the versioning features, just like GitHub. So if you guys are not aware of what is GitHub, so just like how we saw hub.docker.com helps to share the Docker images. So if you want to share your entire code or your application between the developers, we use this version control system like GitHub. So wherein you're free to upload your code, and as you make changes, new versions are created, which you can track the changes and all that stuff. So even configuration management should be kind of hosted in such central repositories, separate from your code, where you can update it on the fly, and whenever you update it, your application will then be able to pick up those changes and get updated accordingly. So one of the essential hallmark of a 12-factor app is that the configuration or the properties of the application, especially the environment specific things, should be maintained outside the code, as we just talked. And also it is necessary to maintain the configuration outside the code to ensure any change in configuration does not invoke a complete rebuild deployment of all the services. So as I said earlier, if you have a very complex or critical app, you don't want just because of a single configuration your entire application or a chain of microservices getting restarted during the actual peak hours. So this is a sample configuration management workflow which we kind of ideally want to follow. So what happens is we will keep all our configuration files in a central repository like GitHub. It is not mandatory to always have it in GitHub. You can also maybe host it in a server, a file server, or you can have it in your local machine as well in a separate path. But why we say GitHub is GitHub makes it easy for us to share the configuration even with other developers and people. And in case if anyone wants to update it on the fly, we can give them access and they will be able to do it. So what happens is between your application and between your GitHub or version control or the configuration file, in between we will use something called as the Spring Cloud config server, which is going to perform this task of reading the configuration from the GitHub and passing it to your whatever microservices in a JSON format. So what happens is ideally when your application starts up and it is configured with config server, it will first tell the config server that, hey, I'm now starting up. Can you please check if there's any config file for me and send it to me. So what your config server will do is it will go to the whatever path or a location you have given. It could be either your local, it could be your local project, it could be a local file system, or it could be a remote area like a GitHub repository. So based on the configuration you have given, it will go and fetch, it will see if there are any configuration file present for this particular microservice or a project which is starting up. If so, it will read it and then parse it in a JSON format and send it back to the account or whatever microservice is being started. And another beauty over here is, since I said we have also multiple environment wherein you as a developer would be doing in a development, but a QA tester will be doing in a QA environment, UAT testing will be done in a UAT environment. So each of the environment will have its own instance of application running. So we also have this concept where we can define configuration for each of the environments separately. So if your account service is going to run in QA, you can pass the startup option as QA and it will fetch only the property file of QA environment for you. So the advantage of that is based on the environment, you can fetch the specific configuration of that environment and get back to your application. So let's quickly get into whiteboard and just recap all those concepts we have learned, because this is very important before we proceed any further. So before we go into whiteboard, I just quickly will come into the accounts project and the cards project just to show you what I mean by configuration. So if you just come to the SRC main resources folder of accounts and inside that you come to application property. So this is the file wherein we kind of define the core properties of our application or the configuration of the application. So you see that here I mentioned the database has to be S2. Then what is the username and password for this database. Then we say whether we want to enable the S2 console and what is the server port which is running. So similarly, you'll also see in the due course of time, we'll be adding multiple configuration to this file as we keep on adding new dependencies. So it is quite important that, as I said, for each environment, a few of these will differ. So say for example, in development and production, I will not have the same user ID and password for obvious security reasons. those kind of scenarios, it is important that, I kind of have different configuration for each environment. And also it is important that, I don't keep everything in my application properties. Why? Because if my application is running right now and suddenly I decided that, I want to, and someone from the DB team says that, we have changed the server password. I don't want to bring down my entire application down when it is running during the peak hour just to change the password or some other minor parameters. So instead of that, what I will do is I will just take out all the configurations which is kind of dynamic. I will put it, either store it outside this project in a file system or like, in a repository like GitHub. And then whenever I need to change anything, I'll just change it over there and automatically my application should be able to pick it up. So how it happens, we'll see it during the next session when we'll be actually implementing these changes. But for now, just understand that, this is what we mean by configurations. So all the dynamic runtime environment related configurations which you define in your application properties, many of them we might change over the time, and it is better that, we kind of move it to a independent location outside your project where we can easily manipulate it. And the ideal way of storing it is either you can put it in your GitHub or in an external file server, FTP based file server, which will ensure that, you can easily manage this configuration. And in order for this to talk with that external system like GitHub or FTP servers, we have a project in Spring called as the Spring Cloud project, which will help Spring Cloud configuration server project, which will help us to kind of establish a link between our project and the configuration file. So I hope now this concept is clear with you. So in the next session, we will now get into the task of creating our config server and see how we can implement it. Thank you and looking forward to see you in the next session. Bye. Hello everyone and welcome to the second session of 5th week. So in this session, we'll be understanding what is Spring Cloud config server. So Spring Cloud is nothing but a tool of Spring framework used to build common patterns across distributed systems. It is specifically used to build cloud-ready applications, and within Spring Cloud, you have a feature called as Spring Cloud config. So what is Spring Cloud config is, it helps send server-side and client-side support for external configurations in a distributed system like microservice. So what happens is, a microservice is a distributed system where you can have multiple number of independent services running in parallel. And you can, as we discussed in the previous session, host all your configuration related to your application in a separate external environment and have Spring Cloud config act in between, stay in between and kind of do that interfacing of fetching the config for you and passing it to the application as required. So this is the sample schematic diagram of the Spring Cloud config server. So you will have the Spring Cloud config server sitting in between, which you'll be creating in a while. So and all your microservices, like for example, your accounts, your cards, your loans, all this would be kind of requesting configuration from the Spring Cloud config server, which in turn would be retrieving this from a version control system or external system like GitHub or your local file system and so on, and get it back and provide it in a JSON format back to these applications. So the Spring Cloud config provides the features of both server as well as client. So as a server, it helps to read the configuration stored in the repository like a GitHub and exposes it as a HTTP REST API, either in the name value pair or YAML configuration. And we can easily embed this Spring Cloud config server inside Spring Boot by just using this annotation of @enable config server. And it also helps us to perform encryption and decryption of this property value if required. So later in the last session, we'll also see if we are storing some confidential information like maybe your user ID, password or API key, those kind of critical information, which we don't want any of the external world to kind of just quickly find out. We can also kind of encrypt and decrypt this property values. Similarly, the Spring Cloud config also provides client feature. So as a client, it will be able to interface with any of the config server and initialize the Spring environment with all the external property sources value which is found. It also supports the encryption and decryption of property, like how your server supports encryption. Your Spring config client will also support the encryption and decryption of the properties. So what happens is your server will encrypt it, and dynamically when you fetch the property, the config client will decrypt it and send it to the application. And to use the features of config client, we should be selecting the dependencies in the Spring initializer for the config client while creating the project. We'll also be looking at it when we are doing it. So now what we will do is we will set up the Spring Cloud config server and client configuration for both our accounts and cards microservices so that we would be able to read a few configurations from them. And also finally, we'll be updating our Docker image with the new changes that we have done. So this is, as I said, will be a common pattern. First, we'll do it in our local machine, that is in Eclipse. We will first check all the configurations working fine. And once that is done, then we will update our Docker image as well at the end of the course. So now let's get started and create our first Spring Cloud config server and then the config client for accounts and cards microservices. So the first step of creating a Spring Cloud server is you have to come to our Spring Initializer website, that is start.spring.io. So always remember that whenever we have to create any new features or any new server or any new projects, we have to do it with the start Spring.io because it will be again a Spring based application. So here a few things remain common, just like as you did for your accounts and cards microservices. You just select Maven, you have Java, you just select the latest 2.7.4 or whatever 2 series version that you see over here. After that, in the metadata, the group, since we have named our application as in.bank, so we'll give the group name as in.bank. So as we said earlier, a group is nothing but just the high level domain name in the reverse order. So if, for example, you are developing a site for skilllink.com, here you will give it as com.skilllink, something like that. Then the artifact ID. So artifact ID is whatever is the name of your project. So here our project name would be config server. So you can also give the same, and as you type it, automatically these three will get updated. And for description, you can just give it as config server for bank microservices. Ensure that you select the Java version as 11 because that's what you're using across our application. And now is the major part. We just come to the dependencies. So here we have to select the dependencies. So since we are creating a config server, search for config server. So here you see a config server. You also see a config client, but that is not for this. So config client will be used by accounts and cards microservices. But since we are going to create a server, ensure that you're selecting config server. And along with that, we'll also select our actuator. So why actuator is required is whenever you want to kind of monitor the health of your applications, or you want to check certain metrics, or you want to perform certain maintenance operations, Spring Boot actuator will make it easy for you, as you'll be also be seeing it down the line. So once you do this, what you can do is you can just quickly check explore tab over here. So this will expose the pom.xml for you. So where you can see that for our application, the config server application, so far we have selected what are the dependencies added. So first is the Spring Boot, that is by default because any Spring application will have Spring Boot. Then we have the Spring Framework Cloud, so that is also required for as part of the config server. And then you have Spring Framework Boot, and then here you have the Spring Cloud dependencies, and here you'll see that the version is selected, and that's it. So once you have done that, just click on download. It will create this config server.zip for you. So what you do is you can just open it and extract this config server to the same folder where you have your accounts and cards folder. So now you see that I have pasted this config server in the same path, in the same location like where my accounts and cards are there. So the next thing which I have to do is I have to first import this into the same working set which I have of accounts and cards. So for that, what I will do is I'll just come to my Eclipse, click on File, click on Import, click on Existing Maven Projects, click Next, Browse, go to the location where my project is present. So this path will be different for you based on your local path. And you select config server, hit select, and once you see the pom.xml, just click on add project to working set and finish. So now you see that config server is now added to our Eclipse. So once you come here and click on the config server, you'll see that automatically now the Maven is importing all the dependencies and creating your project. So this will take some time. I would highly recommend that whenever you create a new, add a new project to your Eclipse, please check the bottom right bar. If something is happening over here like importing Maven and all, please wait till it is completed, because without that you might encounter some error if you try to start your application or do some changes. So depending on the speed of your computer, this might take anywhere between a few seconds to some time. And meanwhile, as this is getting imported, I will quickly take you guys to the Spring Cloud website. So as I said, Spring Cloud is a project within Spring, and these are the various features or the tools which are available within the Spring Cloud. And the one which we are currently interested is the config server. So which you can see over here, Spring Cloud config. So here you can see that all the details about the Spring Cloud config. The current version of Spring Cloud config as the date of recording this video is 3.13. 3.1.3. And here they have given you a quick documentation of how you can start using the Spring Cloud config and all the stuff. So what are the advantages, how you can learn it, and what are the samples you want to try out and all that thing. So I would recommend that, whenever you're learning any new frameworks or be it Java or any other language, always go and check out their official documentation and website. So this is where you'll get the complete idea of what the technology is all about. So I'll just come back to my Eclipse now. It seems that still the dependencies are downloading. So we'll just wait for a couple of minutes for it to get completed. And one more thing before we proceed, I just want to tell for your information that Spring Cloud, right? Not the config, I'm talking about the cloud. So when you have the Spring Cloud has a different versioning name. So you'll see here that, earlier it was named Alston, then Edgware, then Finchley, then Greenwich, Hoxton, Ilford, and the current version is called as Jubilee. So the way it is named is, these are named after London metro station in alphabetical order. So starting with D, then E, F, G, H, I, J. The next one would be probably K, so on and so forth. So that is how the Spring Cloud versionings are happening. And each version is only compatible with the corresponding boot version. So that's why you see the current version is compatible only with 2.6 and 2.7. And the earlier versions were compatible only with 2.4 and 2.5. So why I'm telling this is, in case in a future, if you are able to, you happen to import a Spring which is of a higher version, maybe 2022 or something like that. So you need to ensure that the Spring Boot version that you're using is also kind of compatible with it. You don't need to do anything. The start.spring.io will automatically take care of it. But this is more for your reference and your understanding. So so now the Eclipse has completed downloading. So what we will do is we'll just open our config server over here. I'll just minimize the other two projects. I'll open config server, and the first thing that we'll open is the pom.xml. And remember that, as I said, going forward for all the new projects that we had, we are going to take the build pack approach for generating the Docker image. We are not going to create the Docker file and go through all the hassles. So as we saw for the cards, so if you remember for the cards, what we did is, I'll just quickly show the pom.xml for cards. So for the cards, in order for it to use the build pack to create the Docker image, we just added this configuration at the end of the config file. So same thing we'll also add for the config server as well. So what I'll do is I'll just copy this from the cards microservices, come to the pom.xml of config server, come down to this build configuration, and I will now add it. So since here the configuration tag itself is missing, so what I will do is I will first add the configuration tag. So as you can see over here, first we need to add the configuration tag, and then I will add this. So I'll just copy this. So just for your case, what I'm trying to say is, after artifact ID, press enter, first add the configuration, then add image name, and after that just close the configuration tag. So once you are done with that, so always ensure that you are also matching the placement of the tags. So as I said, so each of these properties should be in the same column as they are opening and closing. So what we have done now is we have just added the name of the Docker image for the build pack. So in our case, it will be Bankit123 project artifact ID. So in this case, it is config server. So it will automatically pick that up. So this is the first thing we have to do. So this is just for our Docker image configuration. So the next time when we create the Docker image for config server, it will automatically do it by reading this in the pom.xml. So I hope that is clear now. So now that we have created this, the next thing is we have to now convert this application into an actual config server. So far we have just kind of added the dependencies, but we have not done any coding or any wiring. So in order to do that, what we will do is we'll just go to the main class of this config server, which is config server application.java. And here at the top, just after Spring Boot application annotation, we will add this enable config server annotation. So as we saw in the slide earlier, in order to make any project as config server, we need to add this annotation. And once you add enable config server, you'll see error because it is not imported. So just right click on that and just left click on that and click on this import enable config server from Spring Cloud config server. So once you do that, the error will be gone. So that is the next step which you have to do. Okay. So now we have kind of created the config server. So the next step is we need to have something for a config server to read upon. Okay. So there are multiple ways to do it. I will first do the simplest way. That is, we will just add a config folder with all the local configurations for each of the environment, and we will have this config server read from it first. So this is the first iteration. Once that works fine, then we will move the configuration from local system into GitHub. Okay. So in order to do that, what I will do is I have already created a config folder, which I will just kind of move into my accounts folder. So what I'll do is I'll just go into my accounts folder, src main resources. So under resources, I will just paste all my config folder content, and I'll go to Eclipse and show you what is there in this. So just to save time, I have just done it beforehand. So what is happening here is, and if you don't see the config yet, just kind of refresh, right click and refresh. So here you will see an option to refresh. Yeah. So just refresh this once. Now you see the config folder added. So what I've done in config is very simple. I just created 3 files for per project. So first 3 is for accounts, the last 3 is for cards. Normally we add each of the properties to individual per project, but this is just for demo purpose I've added. So what we have done is, I just made a mistake. So instead of moving it into the accounts folder, we have to move it into the config server folder, because config server is where you will have all the configuration. So I'll just cut this folder accounts microservice and move it inside the config server src main resources. So any third party files or configuration which need to add, you should always put it under src main resources. Okay. So now when I come to my config server and come to the resources and just refresh it once, you will now see that the config is present, and now it is all the 6 property files are present now. So what are there in this is, I'll just open account properties for your understanding. So what I've done basically is I've just added a few configuration just for testing purpose. So where I've given a variable name called message, where I've just passed this message. I have passed a build version as 1, and theoretically, let's assume that we are going to send email from our accounts microservice, which we are not going to do, just for theory purpose, demo purpose. So I just kind of hypothetically defined some mail server IP, and what is the from address, what is the subject, and what are the active branches that this account bank has. So say for example, currently the active branches of the bank are Delhi, Chennai and Mumbai. And maybe we will then test if we kind of change this configuration later. Okay. So this is just some test properties which we have added. And also it's not that, you can also add your application properties over here. But since we are just going to do some test, we are just adding some dummy values over here just to test it out. So similarly for dev, and we have also created dev and prod properties for accounts, so that for each of the environments we have separate configurations added. So if you see for accounts.property, I have Delhi, Chennai and Mumbai. For dev, I have New Delhi, Old Chennai and Navi Mumbai. And for prod, I have Delhi Old, Chennai New and Mumbai Old, just to kind of separate between each of these configurations. And remember that the name that you give here is very important. The name should start with the name of the project. There should be no other extra casing or characters. And if you are not adding for any particular environment, just give dot properties, which means this is the default one, which will be picked up if you are not supplying any environment information. And in case if you want to give environment information like dev or prod, just add hyphen that environment name like dev or prod dot properties. So similarly for cart, also I have done the same thing. For carts dot property, this is the default one. And for dev and prod, I have just kind of created an additional kind of files which will have the properties with some different values. So this is what we have done. And also if you see the message, I have kind of just given the environment name just to also differentiate. So this is prod, this is dev. For carts, this is dev, and this is the default. So for default, there will be nothing coming over here. Okay. So that's kind of the config which we want to test if it works fine or not. So now what we will do is we will come to the application properties of the config server, because the config server also needs to have some configuration done. Like we have to tell it from where you have to pick up this configuration file and all. So the first thing that we'll give is spring.application.name, and here we will pass the same config server. So this is required for the Spring to identify your application. So whenever you give any namespace, it has to match with this particular thing. And the next configuration is Spring profiles active equals to native. So what does this means is, So which is the file system from which you're reading? So since we are going to read from the local server, this is given as native. But in case when you are going to read it from Git, as we see in the oncoming uh, demo, this will be changing to Git. Okay, so for now just give it native because you're going to read it from your local config folder. And the next we have to define from which path it has to read. Okay, so for that the property is Spring Cloud config server dot native dot search location. And over here now we have to specify from which path it has to read. Okay, and from here we will specify which path it has to read. And since we had already put this config folder inside our src main resources, this is pretty much in the class path of the application, which means that this is already present inside the application class path. For that reason we will just specify the path as class path, which means it will take the current path, and inside that it will get into config. So automatically what your Spring will do is when you give class path, it will come into this src resources and it will come into the config folder inside that. And finally we have to also define the server port where this will run. So just for convention purpose we will give it the port number as 8071. Okay, so you are free to give any other port number as well. So just for standardization, let's go with 8071 so you are able to follow with me. So once you are given all this configuration, now we are good to start our server locally. So what I will do is the same step. Just go to your src main Java, come to this Java application and give run as Java application. So this is starting our config server, and now you see that the config server has started. So how do we test if it is reading the configuration is? Our config server kind of exposes a few URLs, okay, so which helps us to kind of read the configuration. So what we need to do is, since our config server is running in 8071, we just give the port localhost colon 8071. Now let's try to read the properties of accounts, right? So if I just give /accounts/default, meaning I would just want to read the default configuration, you'll see that it has now passed me all these values which we had given. So in order to better read it, what I'll do is let's make this call in Postman. So I'll just go and add a new call. Just do a new request. And here I'll paste the URL. It is a get call. You don't need to give any request body or something. And when I do send, you will see that whatever configurations we had given in our this file is now visible to us as a JSON. So as we said earlier, the config server will convert all this configuration which you are given into JSON and give it back. So now you see that this profile is default, meaning it is the default environment. And whatever you given over here, like account message, you see that this is account message, and you see in the mail details, account service of bank's default environment, and whatever you given over here, everything is now available to us as a JSON. So what happens is, if you are accounts microservice and you consume this config server or you connect to this config server, it will give you all this config in this manner, which internally then you can map and read and start your application. Similarly, if you want to read for production, so I'll just give prod sent, and now you see that it is now my prod configuration and all my data is changed accordingly. And similarly, if I want to do for dev, so I can just change dev, give send, and now you see that the profile is dev. It is now all the data is from dev. And always remember that whenever you get the response, you will get two set of response. So one set of response will be for the environment which you selected. For example, say if it is dev, you will get for dev. And by default, you will also get the configuration which is given for default environment. This is more like a fallback. So in case if there is no environment or no data defined for the environment, you'll also get your default data as well, along with whatever calls you make. So this is also one point for you to note. Similarly, for cards environment, for the cards microservice, so if I give card/dev, you'll see that now it is reading from my cards microservices dev. And if I give default, it is going to pick up default. So profile is default, this is card services, and it's from default environment. And similarly, if I make it prod, you see that it's now taking all the prod related information. So that's pretty much how your config server works. So now for our demo, we are just using two microservices, which is accounts and cards. But in your case, in the real world scenarios, we will have hundreds of microservices. and we can define all those properties in this format and have it in our config folder or in a repository where this can be maintained. So this was part 1 where I first quickly showed you how we can have these different properties created and saved within the project. But this is not really optimal for 2 reasons. One thing is, even now if I want to change any properties, I have to kind of restart my application, which is kind of cumbersome. But still I would say, if not that, even that, if this application is kind of hosted or if this is kind of in a remote repository, this entire application in a GitHub or somewhere, and if I have to change something, I have to commit the changes and it will trigger another set of DevOps and all that thing. The second problem is I don't want all my developers or all the people with access to this repository to read all the critical detail. So at times it may be possible that a few of these configuration details should not really be visible to the entire world. So for those reasons, what I will do is I will move this config folder from here and I will put it into a remote repository like GitHub. Okay. So let's see how we can do that. So just to save some time, what I have done is, I hope most of you know what is a GitHub. If not, I strongly recommend that you first go through what is github.com. You understand how you can create repositories, push repositories and all that thing. So what I've done is, from my personal account, I have created a new repository called config. So it's just a new repository and it just holds all the files which we saw now, right? So the same file I have kind of uploaded over here. So how would you create a new repository? Is quite simple. You just create a new GitHub account, and over here, once you come to repository, it's just similar to your Docker, right? So you have a repository tab, come to repository, click on new. But here you will get your user ID, whatever you create, and here you can give the name of your repository. So in our case, it is config. So I have given config. Keep it public or private, that's up to you, but I prefer keeping it public. And after that, you just give create repository. The repository gets created for you. And once you have the repository created, you again can kind of update the files and do all the things from here itself. So what happens is, if I want to kind of add a new file, so I can just go here, click on add file and I add it, or even upload it. I can directly create it or even upload it from my local. So what you people can do is, once you create the repository, just give upload files and select all the files which you created so far, and it will be uploaded. So don't worry if you see a few extra property files. This is, we will be seeing what these are in the future sessions. But for now, just focus on these 6 files, right? The accounts dev, prod, accounts dev, accounts prod, and cards.property. So all the 6 files, just ensure that you upload it in your remote repository. And by default, the branch that gets created is your master branch. So this is a core branch which has all these files. Okay. So this is the step which I want all of you to do. What I will do is, I'll just stop my config server, and we will have to make a few changes to our config server in order for this to read from the GitHub repository. So the first change which we will do, as I said earlier, is come to your application properties of your config server. So the first change that you will do is, the profile active instead of native, since now we are going to read it from Git, you are going to change it to Git. So this tells our application that we are going to read our configuration from a GitHub server. The next thing is, we are going to update this path. So what we will do is, I'll just comment this line so that for your future reference, you still have it, but you kind of just comment it. And also same I'll do with native as well. So in future, if you want to just have a reference, you can just quickly go through. So what I will do is, first I'll give Git. The next is, I have to give my Git repository information and from where it has to pick it up. So the first command which I'll give is, the first property which I have to define is Spring Git. Ensure it is URI and not URL. Okay. And here I have to give the address of my repository. How to find that is very simple. So all I need to do is just go to your Git repository, that is the config repository which you created. And over here, you will see this green button of code. Click on that. And here you will get this URL under HTTPS. Just copy this. And the same thing you just paste over here. So in my case, it is my name /config.git. That is my username /config.git. For in your case, here it will be replaced with your username. But it will be ending with config.git. So that is the address of your repository. So that is step number 1. Step number 2, we have to define from which branch of your repository it has to pick up. So in our case, we have our code in the master branch. We can also create different branches and put this files. But for standardization purpose, we always have it in master. So we will define it as master. So for that, the property is Spring Cloud config server git default label, which means the default branch from where it has to pick, and I will give it as master. And you can optionally also specify another property. So this is optional, but kind of recommended, which is Spring Cloud config server dot glit on clone on start equals to true. So this is an optional property. So what it means is whenever your Spring Cloud config server is starting, so instead of directly reading from the Git repo, it will first clone that repo in your local. Clone in the sense it will just kind of copy all this file data into your local server and then read from it. So if required, we can also enable that. And that's it. These are just a few changes which you need to do in order to convert reading your config file from your local to the Git repository. So the first change is instead of profile active native, you give it as Git. And the second thing is you define from which repository it has to read, what is the default branch, and if required, you can also enable clone on start to true. So the rest of the things remains as it is. So what we will do is we'll now check if this is working properly. So now we'll just go to our, since we have already stopped the server, we'll just again restart the server. So just go to your config server, application server, right click, run as Java application. It shows that the application has failed to start. We made a small typo. So instead of -server, it should be .server. So if we just do that, ensure to save the file and do run as. So now you see that it has taken the profile as Git and it is now starting the server. And yeah, the server is also started. And now if we just go back to the the Postman and check the same thing. So you see that still it now reads the data and sends it us. And now you see that the property sources, instead of your class path, it is coming from a GitHub. And since you gave it the clone on true, that's why it has first taken the data from here and cloned into your local temporary cache. And from there it is reading and sending it to us. And similarly, if I do it for accounts, so if I just do it for accounts, maybe dev. And since it's now reading from Git, that's why you see a slight delay, because it goes to Git, clones it, and then reads it. So yeah, now you see that it works fine. And similarly, if I just do it for accounts prod, you see that yeah, the same thing for the prod is also now visible. So you see prod and also the default is getting returned as we discussed earlier. So that is how you kind of migrate your configuration to any of the remote GitHub repository. So what we have done is we have now kind of migrated both our accounts and cards configuration to the remote server. So that was from us config server part. So far we haven't wired our accounts or cards yet. So that is the next step. What we will do now is we will wire or update the configuration of accounts and cards microservices in order to read from the config server. So the first thing that we will do is since we have to add a new dependency, and since we have already created accounts project, we are not going to again go back to the Spring initializer project and kind of create a new project and all, because we already have the existing accounts folder. So we don't have this luxury of directly adding the dependency from here. But instead what we will do is we will just update the pom.xml of the accounts and the cards project. So first we'll do for accounts and then you'll get an idea on how to do it for cards. So if I just open the pom.xml of accounts. So what you'll do is under this, inside this property folder under Java, so we'll just create a new line. And now what we'll do is just like how we have the dependencies over here, we'll create a similar dependency for our config client over here. So how to do that is, first we will define, this is a standard pom.xml syntax. So there's nothing much which we have to go through. So it's all simple thing. So first we'll say it is a dependency management. Then under it, nest it with a dependencies object or key. Next you have dependency. Here now you define the group ID. So just to save time, I'll just copy one of the group ID from below and let's modify that rather. So the dependency that we have is of cloud. So what we'll do is org.springframework.cloud. So that is the group ID which we want. Next is the artifact ID. So under artifact ID, we have to give Spring Cloud. So this tells pom.xml or Maven that fetch all the dependencies of the cloud, Spring Cloud framework, and in the version, just mention it whatever is the current version of the Spring Cloud version which is active. Okay. After that, we define the type which will be POM and the scope will be import. Now we are good to go. We just need to close all the open properties, which is dependency and dependencies, and that's it. So once, just ensure that you just add it properly. So it's not required for you to kind of by heart it or know every step. But if you had used the Spring Start IO to create a new project, all this will be given to you by the Spring Boot initializer itself. But since we already have an existing project, so that's the reason we are manually adding it in the pom.xml. There is some formatting issue, so just let's quickly fix it. Let's just cut it and we'll see if we can find the issue by pasting it at the end. So what we'll do is we'll just kind of retype the entire thing and wait for this build to complete. And if we still have the issue, so even if you are having a similar issue, I would recommend that we just go to the accounts project on the top, go to Maven, update project, and just ensure to check all the three boxes, update, refresh, and clean. Give OK. Let's just update the Maven once again. So you see that it's now started to build and the red icons is the issue is gone. So what I would suggest is just go through this file once. So basically there was some spacing error typos. So just ensure that you add this dependency manage block that we added at end over here. And once we do that, just wait for it to complete the downloading of all the dependencies, because once you add it, it automatically starts to download the dependencies. So wait for that. So once this is completed, go to the app.properties of the accounts. Just go to the accounts, resources. So here you have to do a few changes. So the first thing that we have to do is we have to add the Spring application name. So remember, as I said, the name that you give here is what your Spring config server will use to fetch the file from the remote repository. And similarly, next you have to define which environment this application is running. So we will give Spring profile active. So assume that I'm going to assume that this application is going to run in production. So I'm just giving it as profile active prod. You can also give it as dev, and if you don't give anything, it will be considered as default. And next we have to define what is the config server from which it is going to read all this data. So we already have a config server here in our local, so which is running at localhost 8071. So the same address you have to give. So we just give config server HTTP. And one more thing is we can also give an optional parameter over here. So what this means is, if my config server for some reason is down, I don't want my application startup to fail. I can still allow my application to start. So for that reason, we have given this optional parameter over here. So this is the part till where we have kind of now completed the initial the setup. The next part, we will now see how we can actually fetch the configuration from the config server and consume that JSON in order to read in our application. So that part we'll continue in the next session. So for now, we have come to end of the second session, where so far we have created the config server and also kind of done the initial configuration for the accounts microservice. Now in the next session, we will see how we can now consume the data which is returned by config server inside the application. Thank you.
Congratulations on completing Cryo.do's ultimate guide to microservices using Java, Spring, and Docker. And your hard work has paid off. If you found this course helpful, please like and share this video. Don't forget to leave your questions and feedback in the comment section, and we'll get back to you as soon as possible. Make sure to subscribe to our YouTube channel for updates on more courses like this one, and check out our website to explore the premium programs we offer. Until next time, goodbye and happy learning.